চলছে ওইটা ইউটিউবটা একটু চেক করে নাও। এটাতে তুই চেক কর, আমি আর পাচ্ছি না। এটাতে মানে চেক কর, লিংকটা কোথায়? হ্যাঁ, ওই ইউটিউবের লিংকটা কোথায়?
হ্যাঁ দেখো ওয়াইজেফ এর কোনো মেল আছে কি আর? হ্যাঁ এই যে এখানটা আছে,
মারা একটা ইউটিউবটা একটু চেক করে নাও। এটাতে তুই চেক কর, আমি আর পাচ্ছি না। ওইটাতে মানে চেক কর, লিংকটা কোথায়? ওই ইউটিউবের লিংকটা কোথায়?
হ্যাঁ দেখো ওয়াইজেফ এর কোনো মেল আছে কি আর?
আর বলা আসছে।
হ্যাঁ তুমি যেটা বলছো এখানটা আছে,
মারা একটা তো ওখানে অন আছে।
আমি চেক করলাম স্ট্রিমিং ঠিক আছে।
ইউটিউবটা চেক করে নাও। এটাতে তুই চেক কর, আমি আর পাচ্ছি না। ওইটাতে মানে চেক কর, লিংকটা কোথায়? ইউটিউবের লিংকটা
হ্যাঁ দেখো ওয়াইজেফ এর কোনো মেল আছে কি আর?
আর বলা আসছে।
হ্যাঁ তুমি যেটা বলছো এখানটা আছে,
মারা একটা তো ওখানে অন আছে।
আমি চেক করলাম স্ট্রিমিং ঠিক আছে।
ইউটিউবটা চেক করে নাও। এটাতে তুই চেক কর, আমি আর পাচ্ছি না। ওইটাতে মানে চেক কর,
সব অন এইটাতে অডিও অন।
আমি অফ করে দিচ্ছি।
হ্যাঁ আপনি অফ করে রাখুন, বাইরে কথাটা শুনুন।
হ্যাঁ দেখো ওয়াইজেফ এর কোনো মেল আছে কি আর? আমি একটা কাজ করছি, আমি অডিও ভিডিও সব অফ করে দিচ্ছি।
ও আচ্ছা এখানে সাউন্ড আমি অফ করে দিলাম। আমি দেখে নিলাম যে ঠিকঠাক চলছে কি ইউটিউবে আর কিছু না। আচ্ছা আর কি কাজ আমাদের ইউটিউবটা ঠিকঠাক হলো।
বাবাম কি করছো? এই দেখো কপিল কাকাই এসেছে, দেখো তোমার জায়গায় কপিল কাকাই বসে আছে, দেখো দেখো তুমি জিজ্ঞেস করবে তোমার কম্পিউটারে কপিল কাকাই কি করছে?
কোথায় তুমি?
কোথায় তুমি বলে দাও। হ্যাঁ বলে দাও। ফটু ফটু হ্যাঁ বলে দে, আমার লজ্জা কিসের তোর? মনেও তোর লজ্জা? বলে দে কোথায় তুই? কোথায়? আমবাড়ি? শুনলাম দিদি নাকি কালকে তোকে হেল্প পিটিয়েছে। পেটাইনি? পেটাইনি, নিজের ফোনটা ধরেছে কিন্তু। পেটাইনি আর গুড্ডু পিটিয়েছে? গুড্ডু পেটাইনি? ওরে বাবা, আচ্ছা কপিল কাকাই ভাবছে তুমি নাকি কথাই বলতে পারো না। তুমি কথা বলতে পারো? তুমি কথা বলতে পারো? হ্যাঁ মাকে একটু দে না, একটু মাকে দে। ফটু মাকে দে, তাড়াতাড়ি মাকে দে। ওরে বাবা রে, কি সুন্দর লাগছে। কালকে আসবি। বাবা কুকুর, বাবা একটু মাকে দে বাবা, আমায় দৌড়তে হবে বাবা, একটু মাকে দে প্লিজ প্লিজ, একটু মাকে দে বাবা, তাড়াতাড়ি করে একটু মাকে দে প্লিজ। হ্যাঁ তাড়াতাড়ি, আমি ইউটিউবের লিংক পরে পাঠিয়ে দেবো, দেখে নিস। আর এই যে কপিল,
না চেনে না তো আমায়।
তোকে চিনতে না কেন?
না তুমি পরিচয় করিয়ে দিচ্ছে, এই যে কপিল। হ্যাঁ
ঠিক আছে, আমাদের কোনো ইয়ে নেই, টাইম নেই। ঠিক আছে
বাবা।
পরে কথা বলছি, 10:30 স্টার্ট।
Good morning.
Good morning, sir.
কেন কত স্ট্রিমিং আছে?
হ্যাঁ?
কত পার্টিসিপেন্ট লগ ইন করতে পারবে তোর গুগলে?
250 তো পারবে।
পারবে?
হুম।
ঠিক ঠিক।
স্ট্রিমিংটাও হচ্ছে বোধহয়, একটু একটু চেক করে দেখুন।
কি কিসে, ইউটিউবে?
হ্যাঁ।
হ্যাঁ,
গুড
ওটা
মর্নিং
দেখেছি।
স্যার।
গুড মর্নিং, গুড মর্নিং।
শুভেন্দু,
হ্যাঁ কবিতা,
আমি বলছি
ইয়েস ইয়েস।
তোমার ফোন থেকে মানে মোবাইল থেকে ইউটিউবটা একটু অন করে চেক করে নিও না। আসছি।
এখনই চেক করছি,
ওকে।
এখনই চেক করছি।
একটু চেক করে দেখুন।
কি কিসে, ইউটিউবে?
হ্যাঁ।
হ্যাঁ হচ্ছে, হচ্ছে কবিতা।
শুভেন্দু, শুভেন্দু,
হ্যাঁ বলো। অলরেডি করেছি, অনলাইনেই আমি চলছে এখানে। আমি ল্যাপটপেই চেক করে দেখলাম চলছে।
একটু চেক করে দেখুন।
কি কিসে, ইউটিউবে?
হ্যাঁ হচ্ছে, হচ্ছে কবিতা, হচ্ছে। হ্যাঁ কবিতা, হচ্ছে হচ্ছে ওটা। হ্যাঁ
হ্যাঁ হ্যাঁ, ঠিক আছে ঠিক আছে।
তুই একটা কাজ কর, তুই তুই আমার কাছে জিপ ফাইল করা রয়েছে ওটা আলাদা করে। তো ওটার মধ্যে কেন পাচ্ছে না? অনেকেই তো ডাউনলোড করেছে, আমার মনে হয় ঠিকঠাক ভাবে ডাউনলোড করেনি। আমি একটা কাজ করছি, আমি স্ম্যাশে আরেকবার পাঠাই। তুই একটা কাজ কর, তুই আমার যে পার্সোনাল ইমেল আইডি আছে না, সেখানে জাস্ট ইমেল গুলো জাস্ট বডিতে পেস্ট করে পাঠা, আমি সেই ইমেল গুলোতে আবার পাঠাই। মানে যাদের যাদের প্রবলেম হচ্ছে, এটা কি করতে পারবি একটু? দুজনেই করেছে তো? তুই এদের ইমেল আইডিটা কি জোগাড় করতে পারবি? মানে তোকে আমি পাঠিয়েছি ফাইল। হ্যাঁ, মানে আমার খুব সুবিধা হয় তাতে, যদি সেম নেমে থাকে। তুই একটু ওইখান থেকে রিট্রিভ করে আমাকে জাস্ট একটা কাজ কর, তুই আমাকে হোয়াটসঅ্যাপ, না হোয়াটসঅ্যাপ করিস না, তুই আমাকে মেইলই কর, ঠিক আছে? জাস্ট বডিতে দুটো আইডি লিখে মেইল করে দে, তাহলেই হবে। আমি তাহলে ওইগুলো তো ওই স্ম্যাশ বা উই ট্রান্সফার থেকে পাঠিয়ে দিচ্ছি, ঠিক আছে? ঠিক আছে, তুই এইটা just করে দে, তাহলেই হবে। ঠিক আছে।
Good morning, sir.
गुड मॉर्निंग सिद्दीकी साहब.
Sir, you are muted, sir. Siddiqui sir, you are muted.
Good morning, all of you. Good morning, Professor Sunil Kumar Deji. Good morning,
morning, sir.
Dr. Kapil Ghosh, Dr. Shantanda, Sovik, Tuendu, all the geomorphologists of the country and abroad.
गुड मॉर्निंग सिद्दीकी साहब.
Good morning, good morning.
Sir, you are muted, sir. Siddiqui sir, you are muted.
No. Am I audible, sir?
Yes, sir. Yes, sir.
Dr. Shantanda, Sovik,
Sir, why the sound is echoing?
all the geomorphologists. Yes, the country and abroad. Why it is late? Good morning, good morning.
না, সাউন্ড ইস্যু বলতে মেবি ইউটিউব এন্ড গুগল মিট আর
There is difference of, I think, 30 seconds.
Yes, sir. Yes, sir.
I'll come back by 2 minutes.
There is issue of voice. इको कर रहा है और बोल पहले दे रहा है, आता बाद में है. I think there is a two system are open. That's why there is a echo and there is a difference of time also.
Sir, still
Think there
the
is a
sound-related problem is going on?
two system are open. Hello. Am I audible?
Yeah, you are audible, sir.
I think there is no echo now. I think there is a two system are open. That's why there is a there is a difference of time also. This thing I have.
Yeah. Sir, still
Think there
the
is a
sound-related problem is going on?
two system are open. Hello. Am I audible?
Yeah, you are audible, sir.
I think there is no echo now. I think there is a two system are open. That's why.
আমার ওখানে কি ইউটিউব ওপেন আছে?
YouTube open.
বন্ধ করো। ইউটিউবের সাউন্ড আসছে।
YouTube, sir.
Hello.
সায়ন্তন দা, তোমার ওখানে ইউটিউবটা তুমি মিউট করে দাও, তাহলে প্রবলেমটা হবে না, আই থিঙ্ক।
Yes. Yes.
Hello.
Yeah, it is now okay.
Oh, it is now.
It is now okay because the YouTube was turned on in one of the
Okay.
machines.
ইউটিউবের সাউন্ড এখানে ক্যাচ করছে।
Thank you. Now it is okay, I think.
Now it is okay. আমি তোকে হেডফোন দিই। Just do one thing. You just send the email. See, the program will start at 5 minutes. So how can I send the mail right now? No, lot of other things are going on. So you send one email. You don't call me. You don't need to call. Because how can I know who is calling and what is his email ID? It is yeah. It is easier to send one email that I didn't receive the product, and or you do one thing. You just put it on the Telegram group, or you do the code. And will yes, I will send. What is your good name? Now the thing is that Rafiq, we have sent yeah. Rafiq, the thing is that we have sent to everybody. I mean every email to every email we have sent. Now link for the class, but the participation. I don't know. Not for the class, not for the school. What do you need right now? Please tell me quickly. Please tell me quickly. Now you sent mail, but you didn't get the program email. You didn't. What is your designation? Please tell me. Designation. I'm talking about the designation. I know, but just a moment. You just hold on. Hold on. Also, copy email ID. Please, please. My dear. কোনটা কমে আছে দেখ one thing. You just call Shubhendu, the co-convener of this program. The phone number is there. Yeah, the co-convener is there. You just tell me. I have already talked with Shantan sir, and he told me to get the that link from you. Okay, you just contact him, please, because a lot of things are going on. I have to finish it up a lot of things. Please, please. Okay, okay. Right now you call him. Right now. নিজে বেরিয়ে গেছে এই গুগলের পাকামির জন্য। ফোনটা এসে পুরো গন্ডগোল করে দিল একদম। That's something went wrong. আমি কি করবো, পাগল হয়ে যাচ্ছি আমি এখানে। আরে এখানে দেখ না কি করলো পুরো ফোন। তো একটা ফাঁকা জিনিস না, দেখ না ঘুরছে তো ঘুরেই যাচ্ছে। কি কালার স্ক্রিন দিয়েছে না, তুমি একটা যেটা মানে আছে বলতো, জাস্ট কোনো মানে আছে এই সময়টা নষ্ট হওয়ার? এসে আমাকে জয়েন কর তাড়াতাড়ি। নাও।
বুঝছে? করেছি।
Please switch off your subsidiary devices. Means mobile and other things.
I'm just requesting all the participants to turn off their microphones. Otherwise, we cannot start the program. Still open.
এইটাতে সাউন্ড অন
Good morning, President IGI, Professor Chonial. How are you?
Good morning, Siddiqui ji. Good morning, Sunil. How are you? I'm fine. Good morning. What happened? There is some sound problem, I think.
But now it is resolved. There is no sound problem, I think.
Yes, it's already 3 minutes gone.
Oh, maybe. Dr. Franson?
Yeah, it's fine now. Yeah, it is fine now.
Okay.
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 There were some technical problems actually, so we sort it out. We have sorted it out. Okay. So good morning, everyone. Good morning to everyone present here. Myself, Dr. Shantan Das, and I am the president of the Indian Institute of Geomorphologists, Young Geomorphologist Forum for this current tenure of 2020-2021. And as the convener, I welcome you all to the second edition of this intensive training program for the young geomorphologists. It is my honor to introduce to all of you to the dignitaries and speakers of today's event. They are and will get connected from different parts of India today to share their valuable knowledge. Now, why this event is so important to, for all of us? Because of this pandemic situation, for the first time, this event is occurring in the online mode, and this event will host more than 170 participants from different parts of India and around 65 registered participants from outside India. Now, despite coming from different backgrounds related to geoscience, they are having a common thing, and it's their interest in geomorphology. Under the aegis of the Indian Institute of Geomorphologists, IGI, this Young Geomorphologist Forum was established in November 2019 with the objectives like promotion and popularization of geomorphology-based research work, training researchers for carrying out geomorphology-based research both in the field and laboratory, and guiding them how to write good quality research papers. Now, the first edition of this training program was held in Kolkata, India during last year, March 2020. And it was comprised of lecture series, then laboratory and field-based hands-on exercises, and obviously the field visit was there. So I'm pleased to inform you that just like the first edition of this program, this particular event is also going to be an International Association of Geomorphologists, or IAG approved training program. So we got the auspices of IAG for this time also. So I'd like to take this opportunity to share some glimpses of the last year's program with you. Let me just share the screen for a moment. Just a moment. Give me a moment. Just share the screen. Some problem is still going on. Just দেখছি এটা আছে। Yeah, I'm just sharing the screen with you. And so if you see the screen,
Yeah.
so this is just the report of the last year's program. And on the right, you can see the photographs of last year's inaugural session. So the last year's event was inaugurated via video message by Professor Mauro Soldati. He's the president of the IAG. And then we have these field sessions. You can see the photographs and the classroom sessions. Now, Professor Takashi Oguchi from University of Tokyo and Professor Abhijit Gupta from University of Wollongong, Australia, they actually contributed as resource persons for last year's event through Skype because it was just the onset of this pandemic situation. And then we went to this field work to the coastal regions of this part of the country, the West Bengal, which is the deltaic coast, which we are having the deltaic coast here. And this is the group photograph of the last year's event. Okay, I'm just putting this off once again. Okay, so this upcoming event will be a very good opportunity, I think, for the young researchers to learn about recent trends in geomorphology related research, innovative techniques, and usage of modern equipment, along with multidisciplinary approaches in geomorphology. And I, on behalf of this particular forum, would like to convey my best wishes to this edition's participants. So with this, I would like to welcome, just a moment. Okay, with this, I would like to welcome on this platform Professor Sunil Kumar De, Professor of Geography in Northeastern Hill University. And most importantly, he is the Vice President of International Association of Geomorphologists. He was previously the publication officer of this International Association of Geomorphologists for its previous tenure, And another thing is he's the international representative from the IGI, that is the Indian Institute of Geomorphologists. So, sir, on behalf of the forum, I would like to welcome you once again. The platform is yours now.
Thank you. Mr. President, Sir of the Indian Institute of Geomorphologists, Professor Devidas Chonianji, the Secretary General of the Indian Institute of Geomorphologists, Professor Siddiqui Sahab, Professor Shunando Bandopadhyay, Professor Sudhakar Pardeshi, this Young Geomorphologist Forum in charge, professors, the President of this Young Geomorphologist Forum of the Indian Institute of Geomorphology, Dr. Sayantan Das, the Vice President, Dr. Shubhendu Rai, and all the organizing committee members and my dear participants. In fact, just 1 minute, I will share my screen. In fact, this program was to inaugurate by our President, Professor Mauro Soldati, or Dr. Mata de la Seta. But you know, today is the National Picnic Day in Italy. So that is why they delegated the power to me to inaugurate on behalf of them. So in this training program, I welcome, on behalf of the International Association of Geomorphologists, I welcome all the participants. Now, firstly, I will say a few words about the International Association of Geomorphologists. It's aimed to develop geomorphology through international cooperation, promote and dissemination of geomorphological knowledge between the scientific community and the general public, provide geomorphological advice to international institutions, encourage the membership of the countries around the world, promote geomorphological research and establishment of working groups on a specific geomorphological topic, and support, the most important is to support the training of geomorphologists at an early career stage from all around the world, and especially those from economically disadvantaged countries. So with this mission, the IAG has been working since 1987, and we have fixed our goals during this tenure 2017 to 2021 to increase the number of national scientific members. Last year in 2017, it had come down to 39. Now presently, the number of life membership, scientific members throughout this world has increased to 63. So 63 countries are at present the member of this International Association of Geomorphologists. Most importantly, many of the organizations do not have their legal base. Legal base means they do not have any registration in any country. But with long trying, the IAG has established its legal base, and the headquarter of this IAG is in Spain. And if you go through the website www.geomorph.org, you will find the headquarter address is also given. So under this objectives and the priorities, we have been working since past. I was the publication officer from 2019 to 2013, and then became elected as the Secretary General from 2013 to 2017. And presently, I am one of the Vice Presidents. We have 3 Vice Presidents. One is Susan Conway. She is from England. She is looking after our website. Me is looking after the working groups. And Francisco Gutierrez is looking after this international cooperation and membership aspects. So this is a brief about the IAG. And Professor Mihaimicu from Romania, he is the Secretary General. And Emmanuel Renard, he is our Treasurer. And officially, Cosmos Pavlovas was our publication officer till now. Now, joining this IAG activities, it is an opportunity to become international scientist. See, I was also a young geomorphologist in 2001, but that time there was no young geomorphologist recognition, but it was decided that before 2002, those who got the young geomorphology scholarship, they will be they will be able to join in the IAG alumni. Is it worth to actively join the IAG activities as a early career scientist? What are the facilities we are getting? Number one, outstanding travel opportunity worldwide. We offer many scholarships during the quadrennial conferences. Next year it will be held in Portugal. Every after 4 years we organize, and we offer 17 to 20 scholarships from different developing and underdeveloped countries. So partially or fully some of these scholarships are given for the young geomorphologists. So you can get this travel opportunity worldwide. Number two, you can get chances to visit wonderful geomorphological landscapes, even in remote countries. Many of these participants in this group, they have got this young geomorphologist scholarship from the IAG, and they visited different countries, also participated different the scientific lectures, laboratories, and many others. Number three, enhanced contacts with geomorphologists worldwide. Those who are renowned geomorphologists, you can get a chance to contact with those physically, not through email or anything else. Opportunities to become part of the international research team. So you can utilize this opportunity to get these collaborative projects or to be involved in different research projects. And through this IAG platform, this year it is. I am glad to inform you that one of the Indian girl from Pune, she has got opportunity to in the PhD program in the University of Modena. So many these youngsters, they get this opportunity through this interaction in this platform. Stronger chances of publishing in highly ranked journals, and how to write these good quality papers. We also give guidance. Then opportunity of reaching leading positions within the IAG and affiliated organizations. See our present president, Professor Mauro Soldati. He was also a young geomorphologist in 1997. I was in 2001. After that, our present Secretary General, Mihai Micu, he was also this IAG young geomorphologist scholar. Now till today, since 2002, I told you there was a conference, this 5th ICG was held in Tokyo. And that year, before that, there was no recognition of this young geomorphologist, although it was a mission of the IAG. But in that year, it was formed that IAG Young Geomorphologists Alumni Group would be formed and will keep the statistics. Since 2002, this Professor Mauro Soldati was the in charge of this Young Geomorphologist Forum. After becoming vice president, he handed over the charge to this Marta de la Seta of the same country, and they are looking after this group very well. Now, till today, we have offered 196 grants to 178 young geomorphologists from 56 countries. And some of them, repeatedly, they have got 2-3 times. So that is why the number of young geomorphologists is less than the grants awarded. So we have had 196 grants till today. And during this period, this in red, new country, this Costa Rica, Iraq, Switzerland, and UK, these new countries have been added in the list in the present one. Sorry. So this was the young geomorphologists in 2017. The conference was held in New Delhi and at Vigyan Bhavan. And you see from throughout the world, this backside, this front side and backside, many young geomorphologists are there. But along with the senior members, he is the president now. He was the president during this 2013 to 17. And many of this IAG executive committee members are there. But we are happy to announce that altogether, we offer 22 young geomorphologist scholarships plus this European Geosciences Union 2 and the Italian Geomorphology Group, they offer 2. So This is this IAG International Conference in Geomorphology on Geomorphology. After 4 years, we offer this major grants to this young geomorphologists. These are the recurrence event, and this was held in this during this Delhi conference. This is the young geomorphologist field trip and intensive workshop in the Himalayas. This is the theoretical training. This was the field training. This is certificate getting, and this is again field training in Dehradun. This is this British Society of Geomorphologists. We also offer these scholarships, 2 scholarships per year to participate this British Society of Geomorphology intensive training program. Then this is Early Career Researcher Conference travel grant we offer from the developing countries. Then IAG workshops we offer. These are occasional, of course. If any working group or if any our partner organizations, they organize any type of this event, we offer them to 1 or 2 scholarships we offer. This is Young Geomorphologist Meeting and Workshop. We are happy to say that we have a group in European Geosciences Union, and now this geomorphology have been recognized by the European Geosciences Union, and you can be involved in this group, geomorphology group of this European Geosciences Union. So they also organize this type of this intensive training program, as well as this Polish young geomorphologists. Last year they organized this intensive training program for young geomorphologists. Now, how to obtain the support? Number 1, organizations of geomorphological conferences, symposia, workshop, and intensive courses willing to have IAG grants included in their event program are expected to submit proposals to the IAG Executive Committee, possibly 1 year in advance. So this program could also get some funding assistance from the IAG, but due to this pandemic, within a very short period of time, these intensive courses have been organized. So this year we could not get anything. Events including intensive courses for young geomorphologists normally have priority. So in all of our activities, we give priority to this young geomorphologist group. And information you can get from our IAG website, www.geomorph.com, and also social media, Facebook and Twitter, and via the mailing list, Geomorph list. So we have all this access through website, through Facebook, through Twitter, and the application procedure is very simple. The selection of young geomorphologists to be granted is carried out by a panel of experts appointed by the International Association of Geomorphologists. Usually we consider 5 experts from 5 different countries. So, and it is kept as confidential. Nobody knows from which country this the expert is being selected. Calls for grant for online conferences and events are foreseen for 2021. So now, if you go through the website, you will get all the information. Now I will come a bit very briefly about the Indian Institute of Geomorphologists Young Geomorphologists Forum. As per the decision of the International Association of Geomorphologists, that all national scientific members would have to promote the young geomorphologist. The Executive Council, as well as the General House of the Indian Institute of Geomorphologists, in their meeting held on 4/10/2019, and it was held in the Jamia Millia Islamia University in India, have approved to form a young geomorphologist forum under the banner of the IGI with the following objectives: promotion and popularization of geomorphological research among the Indian young geomorphologists, favoring the interaction of Indian young geomorphologists with the international geomorphological community, becoming aware and favoring participation in the IAG activities with special reference to the International Association of Geomorphologists training program, training them for carrying out geomorphological research both in the field and laboratory, and guiding them how to write good quality scientific papers. So this was the initiation on 4th October 2019. To look after the program, the IGI has formed a committee, and me, Professor Sunanda Bandyopadhyay, Professor Sudhakar Pardeshi, and of course Professor A.R. Siddiqui are the members of this senior geomorphologist group to look after this young geomorphologist forum. And their activities are to organize at least one field or laboratory workshop before or after the annual conference of the IGI. So this is field or laboratory workshop, but since this is pandemic period, so we are organizing this workshop through online mode. To organize at least one scientific session for young geomorphologists in the annual conferences of the IGI under the co-chairmanship of any senior member from the aforesaid committee and the president of the forum. To organize at least one session per year on how to write good quality scientific papers and projects on geomorphology, and to discuss about the recent trends in geomorphological research. And lastly, to contribute scientific papers to the Journal of Indian Geomorphology. There are many international participants in this forum also. So I would request to all of you, you can submit your paper through email. This Journal of Indian Geomorphology is now well-recognized journal. We are glad to inform you that outside Europe, the first young geomorphologist group was established in India in 2019. It is 4th October 2019. It was followed by Australia and the New Zealand group 2019 and South Africa in 2020. So outside Europe, these three countries have now this young geomorphologist group, but the Indian young geomorphologist group has been successfully organizing intensive training programs since 2020. This is the only training program organized outside Europe under the banner of IAG, International Association of Geomorphology. So this is the active group, and I hope many countries will be encouraged to organize this type of training programs to promote geomorphological issues among the youngsters of the world. On behalf of the International Association of Geomorphologists, I thank the presidents and vice president of the IGI Young Geomorphologist Forum 2020, Dr. Shreya Bandyopadhyay, President, and Dr. Sayantan Das, Vice President, for organizing the first intensive training program. And this year, 2021, Dr. Sayantan Das became the President and Dr. Shubhendu Rai, Vice President, for organizing the second intensive training program. The IAG will have full support for organizing these types of intensive training programs. At the end of the day, certainly some questions come in the mind of these youngsters. What is the benefit of studying geomorphology? What is the benefit of organizing and participating in this type of intensive programs? What are the scopes getting job in geomorphology? So these questions naturally come. If I would be the youngster, of course, these questions would come in my mind also. So to answer this question, we need to know the following points. Why geomorphology is important? What are the tasks of geomorphologists and career opportunities? Very briefly, within 2-3 slides, I will cover this answer. Now, geomorphology is such a subject which links with all other subjects, all other environmental sciences. In one side, this is geology, structure, and petroleum. For this thing, you need to include geomorphology. Number 2, environmental engineering, geomorphology participate that one. Geoarchaeology, geoecology, planetary science, it has been a new branch of geomorphology now. And environmental policy and management, of course, this is very important. So this geomorphology interfaces with and contributes to many different aspects of the earth, environmental and social sciences. So there is, in many countries, there is a contradiction between geography, geology, and geomorphology. Geographers say that geography is a social science. Geologists say that geology is this pure science, including physics and chemistry. And geomorphology, this exists in between them. So now the question comes, if you do not get a proper topography, if you do not get a proper place, how can you establish settlements over there? This is a question. So at the same time, this along with the social sciences, geomorphology is this important. At the same time, there is no friction between any subject. So at this era, at this age, this I would say that all the subjects are interrelated. We cannot say that one subject is social science, another subject is physical science. No, all subjects are interdisciplinary. Now, what are the tasks of geomorphologists? Number one, communicate geomorphological findings by writing research papers, participating in conferences, or teaching geological science at universities. Analyze and interpret geomorphological data using computer software. Nowadays, it is very important. Locate and review research articles or environmental, historical, and technical reports. I had 2 years projects with this Italy, University of Torino, and I have gone through this historical library, record library of the CNRI, this National Geophysical Research Institute. They have a very good library over there to investigate the composition, structure, or history of Earth's surface through the collection, examination, measurement, or classification of soils, minerals, rocks, or fossil remains, to prepare geomorphological maps, cross-sectional diagrams, charts, or reports concerning geomorphological resources using results of fieldwork or laboratory research, to conduct geomorphological studies to provide information for use in regional development, site selection, or development of public work project, identify risks for geomorphological hazards and disasters such as flood, landslide, riverbank erosion, and many others, to measure the characteristics of the Earth's surface using instruments like total station, GPS, UAV, and others, advise construction firms or government agencies on dam or road construction, foundation design, land use or resource management. And the previous, one of our geomorphologists, Professor Takashi Oguchi, he has a very practical experience on all of these aspects. Develop applied software for the analysis and interpretation of geomorphological data. Develop strategies for more environmentally friendly resource extraction and reclamation. Assess ground or surface water movement to provide advice on issues such as waste management, route or site selection, and many others. To identify deposits of construction materials suitable for use as concrete aggregates, road fill, and other applicants. To study climate change indicators to found locations such as ice sheet, flood, or landslide to develop climate change models. Review work plans to determine the effectiveness of activities for mitigating soil or underground contamination. Determine impacts of paleoclimate and geomorphological processes through dating techniques. Determine ways to mitigate the negative consequences of human intervention on geomorphological resource extraction. To collaborate with medical and health researchers to address the health problems related to the geomorphological hazards or processes. When this flood occurs, this pre-flood, during flood, and post-flood events. So during post-flood, there may be different types of health problems among the victims. So we can help them geomorphologically, where is the secured place. Research ways to reduce the ecological footprint of increasingly prevalent megacities. Nowadays, this has become a very important issue, although including India. And lastly, to take part in the EIA preparation for any project where geomorphology is an important component. See, for example, any dam construction, any type of mineral explosion site. So they will have to prepare EIA to get the clearance from the government. So in that EIA committee, geomorphology is an important subject, and of course, there is an option to be involved in that group. What else? Lastly, I will tell you that sincerity and adaptability with the changing environment is very important. Now, career opportunities. An individual's decision to become a geomorphologist based on informal discussions seems to relate of two separate steps, both of which encourage success towards attaining this goal. One is this first phase is the initiation of an interested awareness of landforms and landscapes. Landforms and landscapes also have strong appeal to the general public, as evidenced by the heavy visitation of public lands where the landforms are spectacular, interesting, attractive, and instructive. So in all areas, if you see the coastal belt, if you see the mountainous belt, so these are the geomorphological resources along with the physical planning. We can use these resources for tourism purpose also. So firstly, you need to understand and you need to create the awareness among the youngsters. The second phase of formal education in the classroom, field, and laboratory. So this will be particular. So when you are learning this in the laboratory, you should go to field and learn what is the actual nature of the feature. These two phases mark the beginnings of a career in geomorphology. The professional practice that follows may vary widely, centering on teaching, research, consulting, professional practice, or as in often in the case, some combination of these endeavors. And in these sectors, you have the job opportunity, teaching positions, of course it is right, Research Institute, this Kazrim in Central Arid Zone Research Institute, National Center for Earth System Sciences, then Coastal Research Institute. So in all these sectors, you can get opportunity. Then fluvial geomorphologists or hydrogeomorphologists in water commission. In different countries, they have water commissions, so there is opportunity. Then geomorphologists in different projects like dam site, desertification, geoarchaeology sites. Of course, it is needed. Thematic mapping organizations, for example, in India, NATMO is their national atlas and thematic mapping organization. Many geomorphologists are required. Then pollution control boards, archaeological organizations, military sectors, EIA team, planning institutes. So there in each and every allied sectors, you can get job through this geomorphology. Now these two references, these are very important. You can go through, you can download it from our IG website also. And lastly, I thank you for all of your attention. And on behalf of the International Association of Geomorphologists, we thank the organizers, especially the President, Professor Dr. Sayantan Das, Vice President, Dr. Shubhendu Rai, and the Organizing Secretary, Dr. Kopil Ghosh, to organize this event in a befitting manner. And you all for participating in this conference, and wish you all the best in life. Thank you very much.
Thank you, Professor Day, for your important talk, for your inaugural talk. And now I would like to warmly welcome our guest of honor, Professor A.R. Siddiqui from University of Allahabad. He is also the head of the Department of Geography in that university. And most importantly, he is the Secretary General of the Indian Institute of Geomorphologists. Sir, over to you now.
Thank you, Dr. Sayantan Das, for your kind words. First of all, I would like to congratulate Professor Sunil Kumar Dey, Vice President, International Association of Geomorphologists, for his address. Really, it was very informative and valuable address for our young geomorphologists. And nicely you have presented and you have covered all the aspects related to opportunities in the field of geomorphological studies. And in the last slide, you have mentioned also, you can download and what are the opportunities in the geomorphological studies. Basically, in India, researchers are doing original piece of work and they are publishing their papers. And you have already mentioned that how to write a good paper. And these are the important aspects. And they are doing good work, but they are not having canvas to know how they can publish and from where they can engage. So indeed, this is a very good effort of President Young Geomorphologist Forum and Vice President Young Geomorphologist Forum to organize this type of program. Here, many senior professors are there. So first of all, I would like to congratulate Professor Sunil Kumar Dey, because under his leadership, we all are exploring our opportunities from different parts of the country. Professor Sunil Kumar Dey, Vice President IAG, Professor D.D. Chaunial is here, President IGI, and many good scholar, well-recognized researcher of India and abroad, like Professor Vishwas Kaleji, Professor Milab Chand Sharma ji, and also I have seen some names that they have to deliver their lecture for our young morphologists, Dr. Balin Basu ji, Dr. Sujay Bandhopadhyay ji, Dr. Paras Kevi Namikau from University of Athens, and Dr. Vitena Vendeli from Italy, and many scholars are there. And I have seen many of your programs which have already mentioned in the brochure. So I would like to congratulate organizing team of IGI Young Geomorphologists Forum for organizing second intensive training program for the young geomorphologists. Professor Day mentioned about the Kolkata training program. Really, that program was also very intensive and very good program before Corona. I have already attended. So there are many geomorphologists from different corners of India. They are working in different branches of geomorphology, coastal geomorphology. They are working in desert landscape also, mountain ecosystem. So I want to tell them that Indian Institute of Geomorphology, IGI, was founded by Professor Savinder Singh on 19th January 1987. From the very beginning, geomorphologists from Kolkata, geomorphologists from Kerala, from Pune, from Srinagar, from Delhi, they all are pillars of Indian geomorphology and contributing a lot to make good conferences and good program for the young geomorphologists. And I already mentioned in the constitution of IGI, the main objective of IGI is to bring the entire earth scientists dealing with the geomorphological studies and allied discipline on the common platform. I would like to congratulate Dr. Sentan Das and Dr. Swendu and Dr. Kapil, Dr. Anmesha, Dr. Rindam, those who are associated with this program. Really, you have done a major objective of IGI, and you have already associated our IGI to many countries. As you have mentioned, there is a participation of 40 countries. I cannot imagine in the very short time you have organized all these things. And I would like to appreciate the effort of President YGF, Dr. Santan Das, and Vice President Dr. Swendu Rai for organizing second intensive training program for the young geomorphologists at international level. Another main objective of IGI is to hold the conference and training program for the young geomorphologists, covering allied aspect of the geomorphology. Really, again, I would like to appreciate President YGF and Vice President YGF for designing well-structured program. The training program will highlight the career opportunities. I'm very happy that you have designed very good brochure for young geomorphologists, and you have given many inherent and insights of geomorphological study. And those students are doing research in the field of geomorphological branches, and they should know what are the career options, and Professor Sunil Day already covered, and where they can apply and where they can publish their paper. There will be a lecture on geochronology and unmanned aerial vehicles mapping. This is very important aspect. As mentioned by Professor Sunil Kumar Day, what are the recent advances in geomorphological studies? So our research student will know about the UAV-based mapping, unmanned aerial vehicles mapping, and you have already included the lecture of a very well-recognized scholar like Professor Vishwas Kale and Professor Milab Chand Sharma ji from JNU, paleoclimate and fluvial responses and process-based studies in glacial landform also. And you have mentioned already field experiences in extreme environmental condition, and about also dating the quaternary sediment and landforms. So this is very good opportunity to explore the young geomorphologists to a world geomorphological landscape. And one of slide Professor Sunil Kumar Day shown, and there is 21 Indian scholar received the fellowship. This is a big number. So this is the effort of Professor Sunil Kumar De. And I would like to mention here, third objective of IGI is to make linkages between academic institutions and universities for academic exchange program. So, and again, I would like to thank Dr. Sayantan Das and Suvendu Roy. You have already you are already making linkages between different universities of the world. Here, I am very happy, and many of my students are here, and many faculty members are here, and they are also very happy. You have already made the linkages of IGI to different academic institutes of the world. So to give more emphasis to applied aspect of geomorphological researches, and your efforts are highly appreciable. Really, I would like to appreciate all your efforts from the banner of IGI. You have done a very tremendous job. I would like to thank and congratulate our Vice President and my good friend also, and Vice President IAG, Professor Sunil Kumar De, for his dynamic leadership and dedication for shaping students of geomorphology for global at global level. Every day I discuss with Professor Sunil Kumar De, and every time he talks about the student, and this is the quality of a real teacher. And they are emotionally, particularly Professor Sunil Kumar De, Professor Sunando Bandhopadhyay, Professor Maiti, Professor Ashish Kumar Paul, all the geographer, Professor Sudhakar Pardesi, all the geographers from Kolkata, Pune, and other region of the India, they are emotionally attached with the IGI. So from the bottom of my heart, on the behalf of IGI, I would like to congratulate and I wish this program will explore the possibilities of opportunities of the geomorphologists, and they can explore themselves. And Professor De, you have already mentioned this is an opportunity for young geomorphologists to explore the world geomorphological landscape. So from the bottom of my heart, I would like to congratulate for the success of this conference. Thank you, Dr. Sayantan Das, for giving me space to share a few words. Thank you.
Thank you so much, sir. We have a very special guest with us, Professor Devidat Chonial from Doon University, India, and he is the current president of the Indian Institute of Geomorphologists. Over to you, sir.
Okay. Good morning to all of you. First of all, I congratulate to Sunil Kumar De for giving a very nice lecture on geomorphology, on the meaning, concept, and scope of geomorphology. Today's guest, chief guest, and vice president of IAG, Sunil Kumar De. Guest of honor, Professor A.R. Siddiqui. Eminent speakers, Professor Bishwas Kale, Professor Milap Chand Sharma, Dr. Balen Basu, Dr. Sajay Bandhopadhyay, convener of the event, Dr. Sayantan Das, co-convener Suvendu Roy, organizing secretary, Dr. Kapil Ghosh, and all participants of the Young Geomorphologist Forum. I am very happy to know that the Indian Young Geomorphologist Forum is organizing second 2 days intensive training program for the young geomorphologists. I hope this event will be a good opportunity for the young researchers to learn about recent trends in geomorphology, related research, innovative techniques, usage of modern equipments, and multidisciplinary approach in geomorphology. On this occasion, I intend to share some of my perception regarding the present status of Indian geomorphology. It is very necessary to consider the overall trends of ongoing research in this field in Indian perspective. Now the time has come, we have to focus on geomorphological study for human welfare rather than an only a academic exercise. It is felt that water-related problems are a very serious problem in the physical and anthropogenic environments. Climatic change, increasing demand of water for drinking, irrigation, and hydroelectric generation, and overutilizations of groundwater are directly or indirectly creating a number of environmental problems. And next one is the most of the problems are related to mountain geohydrology. The most of the problems are related to mountain geohydrology. The geohydrological studies of the mountains are poorly understood because of extreme topography that result in complex interactions between climate and water storage. There are numerous stacks, but an accurate understanding of the mountain geohydrological cycle is imperative. To study and solve these water problems, young researchers should focus on mountain geohydrology. Mountains are the freshwater tower of the world. About 10% of the world's population depends on mountain resources. According to UNO, about 31% land of the world is under mountains, and it covers 15% population of the world. Mountains are very important for human beings all over the world. Most of the hazards have occurred in the mountains, and hazard create disaster in the inhabited areas. Tectonic movement, earthquakes, landslide, glacial avalanches, rockfall, cloudburst, etc. are the major hazards of the mountains. Spring geohydrology and climatic hazards are the burning problems of the mountains. Therefore, the knowledge of mountain geohydrology is of basic importance in all walks of the life that involve the use and supply of water for any purpose whatsoever. There are immense potential of geohydrological study in the mountains. In this platform, I invite all researchers, young researchers, and students who are interested to become hydrologists, who need a strong emphasis on geomorphology, geology, chemistry, and environmental science. The field of mountain geohydrology is worth considering. Hydrologists play a vital role in the finding solution to water problems in the mountains, and interesting and challenging career are to those who select to study hydrology. And hydrologists can work well with mountain people and general public as an expert, advising government agencies, administrators, and planners on any water issue. Emphasis should be given to the experimental studies, such as measurements and monitoring of water discharge and sediment budget of measurement, glaciating, water harvesting, each one of us has been and is engaged in research activity and has contributed whatever little we could to the Indian geomorphology. On behalf of IGI, as the president, and on my own behalf, I thanks to the organizing committee for giving the opportunity to express gratitude on this day. I once again thanks all the participants of Young Geomorphological Forum and eminent speakers of this day. Thank you very much. Thank you.
Thank you, sir. Now I would like to call Dr. Shubhendu Rai, the co-convener of this particular event, to express the vote of thanks.
Okay, thank you. Good morning, all. And it's an honor to present the vote of thanks on behalf of IGI, Young Geomorphologist Forum. And the forum would like to thank International Association of Geomorphologists, IAG, for supporting us with their auspices. And we would also like to thank our own institute, Indian Institute of Geomorphologists, IGI, Allahabad, for their kind support here. And we also like to thank specially our Professor Sunil Kumar De, Vice President of IAG, for his immense help to us to make this event actually happen within a very short time frame and with a very valuable inaugurating lecture regarding the prospect in geomorphological research. Besides, we also thank our special guest of honor, Professor A.R. Siddiqui, Secretary General of IGI, for his kind presence in this occasion. And we also thanks to our special guest, Professor D.D. Chonial sir, the current president of IGI, for his kind words. And we also thanks our senior patrons of IGI, Professor Sunanda Bandyopadhyay, Professor Sudhakar Pardesi sir, Professor Ramkrishna Maiti sir, for their kind support in Young Geomorphologist Forum. And I also like to thank our heartily gratitude to all the distinguished speakers for today and tomorrow for accepting our invitation and sharing their works with us in this event. And lastly, we sincerely thank our organizing secretary and all the members, active members of this organizing committee, for putting up this event in very systematic manner. And the most important part, we also like to thank all the participants for their showing interest in this training program. And I am very sure you will have a great time during this event. Thank you all.
Thank you, Shubhendu. So, on behalf of this IGI Young Geomorphologist Forum, it is my privilege to welcome Professor Vishwas Kale, our first speaker for this event. Professor Kale is a former professor of the University of Pune. Now it is called as the Savitribai Phule Pune University in India. And he did his post-graduation from the same university, and he completed his PhD in archaeology from Deccan College, Pune. Now, Professor Kale is one of the most decorated geomorphologists in India and also a former president of the Indian Institute of Geomorphologists. Professor Kale has more than 100 publications in reputed national and international journals. But more than these numbers, it is the quality of his research work that stands out. He is the member of the editorial board of the journal Geomorphology. His research interest lies in the fields of fluvial geomorphology, sedimentology, and paleoclimate studies. He has intensively conducted field-based research in a number of peninsular rivers in India. He has also carried out research on the ancient channels and hydrological cycles of the planet Mars, and this work is still regarded as an important contribution to extraterrestrial geomorphology. And you can find his paper, this particular paper, in the journal Nature. Now, recently, Kale sir has brought out the Atlas of Geomorphosites of India, which was released during the quadrennial International Association of Geomorphologists conference that took place in New Delhi in 2017. Professor Kale has been an inspiration and role model for many of the young geomorphologists of India and abroad. And I strongly believe that the young geomorphologists of today's session will be highly enriched by his deliberation. Thank you, sir. And I'd like to welcome you again on behalf of this organization, and you can share your screen now, sir.
Yeah. Hello.
Yeah.
Can
Yes,
you see
sir.
my screen?
No, sir.
For some reason, the camera is not getting on.
Yes.
Yes.
The screen is there.
Yes, sir. If there is any issue, sir, you can log in once again. If you log out and log in once again.
No, my mic is on, but camera is not getting on.
Yes, sir. That we can understand, sir. Sir,
Fanton, just request him when he will restart his computer, no?
Hmm?
When this dialog will come, do you want to use your camera? You will have to click on it.
He has presently logged out from the system, I think, and he will rejoin again.
Just I'll come back by 2 minutes.
Yes, sir.
Okay, I don't know, turn on camera, I'm clicking on that and it's not turning on.
Sir, what browser you are using? You are using Chrome.
Yes, but I don't have any problem. This has been going on.
Sir. One thing you can do if you have any external camera, otherwise. Sir, you can do one thing. You can use another browser. That might solve the problem.
I'll try another, my laptop.
Yes, sir. Yes, sir. Yes, sir. No problem. No issue.
But it's from your side, it's not off, na?
No, not at all.
Please try to check that.
Yes, sir. We have already checked, sir. We can only mute you, but we don't have the authority to turn off your camera.
But I don't. But the mic is on, right? The camera is
Mic is on, yes, sir. Sometimes this Chrome browser, creates some problem then. Maybe using Mozilla or Explorer or Opera might solve the issue. Just request all the participants to turn off the camera, apart from the speakers, of course, to turn off the camera. Please, everyone, you please turn off the camera so that there won't be any problem with the bandwidth allocation. So whoever is not speaking, please turn your camera off. Ajib Shaha, please turn your camera off.
No, it's not turning. His camera failed.
Sir, in fact, I am also turned off. I've also turned off my camera. So I don't think there is any problem with the bandwidth allocation. Sir, are you using a different laptop? Sir, I'm just giving you
I'm trying to set my laptop. Just
okay, sir. Okay, sir. No issue. It is once again a request to all the participants to turn off their cameras and the microphones so that there won't be any issue with the bandwidth allocation. Sir, are you using a laptop? I mean, the machine from which you have logged in? This one? Sir, if this machine is a desktop, then you can restart the machine. Okay, I think he's logging in from another machine.
शांतनु, जब तक वो ठीक करते हैं दूसरे स्पीकर को बुला सकते हो.
No. Sir, actually the times are very fixed, you know. Professor Sharma will join at 12:20.
Okay, no problem.
20. It is not a very big issue, sir.
Take it as a tea break.
Kapil is saying that you can take it as a tea break. Let's see, I'll call him actually.
A.R. Siddiqui is here or not? Siddiqui.
Hello, sir.
Siddiqui.
Still the problem is going on.
Okay.
With that machine. Sir, if you are using a desktop, I mean, I'm talking about the first machine. If you are using this desktop, then sir, you restart the machine. That's the only way to solve this problem. And otherwise, you can log in from the laptop. Yes, sir. I think that will solve the issue. We are waiting, sir. No problem.
Okay, now it is fine.
Yeah, it is fine now. Just a moment. Oluwatsin, okay, bola, turn off your camera, please. Turn off your camera. Oluwatsin, please turn off your camera, please. Okay, sir.
Turn off.
Yeah, no, sir, not you, sir. There was another participant. Okay, sir, you can share your screen. Over to you.
Yeah. So sorry about this. Can you see?
No, sir.
No, sir.
No, sir.
So present now, huh?
Yes.
Huh?
Your entire screen.
Yeah, but that is what I have done.
This is the Chrome browser, sir, or something else?
No, Edge.
Edge browser, no problem with Edge browser. Edge is fine.
Yeah, present now, entire screen.
You share the entire screen, sir.
Yes.
And then that option is coming on the top of the screen. Yeah.
Share your entire screen.
Yeah.
Now click on the screen, sir, then share option will come.
Yeah, that's share. Yeah.
Yes, sir. On top of the screen, something has come.
Now
Yeah,
it is
sir,
coming.
it is coming, sir. It has come.
Okay.
Okay, okay, sir.
So I have lost 10 minutes in the whole process. So anyway, I'll try to stick to my time. So hello everybody. I'm sorry, extremely sorry for this technical issue. See, we are talking about the global warming and climate change, and in order to understand the consequences of the human-induced climate changes, it is necessary to have some idea about how the climate has changed in the past and how the rivers have responded to these changes. So I'll be talking about the last 10,000, 11,000 years, how the climate has changed, particularly with reference to the peninsular India and the response of the rivers to this particular climate change. Now, you often see such deposits along the bank of the river on a terrace, and these deposits, they indicate that at some time in the past, geological past, the river was depositing, was aggrading these sediments, and then it has cut through. So there is a change in the fluvial activity. And these sediments, they give us some idea about the fluvial environment if we study the deposits, whether these are channel deposits, whether they are floodplain or fan or delta deposits or flood deposits. And ascertaining the age also gives you some idea about the fluvial history of the river. So one can identify periods of aggradation and degradation. Now, when we talk about the climate change during the Quaternary, large-scale changes in the climatic conditions have taken place on different time scales due to changes in the Earth's orbital parameters, which are known as Milankovitch cycles, and these have resulted into the glacial and interglacial periods. Now, in the high latitudes and the mid latitudes, there were significant changes in the geomorphic processes, but in the low latitudes, during the glacial and interglacial periods, only there was significant changes in the precipitation conditions. So the glacial periods were characterized by relatively drier conditions, and the interglacial were characterized by wetter conditions. This is in general. And in the last 2-3 decades, the fluvial records of the last glacial period, that is almost last 120,000 years, in general, and Holocene in particular, have been studied extensively in different parts of the world. Now, this gives you a general idea about the climatic changes during the last 130 years. And as you know, that the glacial periods have been assigned even numbers, the glacial period, and the interglacial periods have been assigned the glacial periods have been assigned the even numbers and the interglacial as odd numbers. So we are presently in 1, which is interglacial period. We go back, that is 2, which is the glacial period, then 3, which is an odd number. So again, interglacial, 4, like that. Now, in general, from the available data on fluvial records from different parts of the low latitudes, it indicates that during the drier periods, which are associated with the glacial periods, there was general aggradation. The rivers were depositing. And when the climate became wetter, they started incising. So this is the general picture. However, to reconstruct climate from the fluvial records, it is very difficult. The climate affects the river via hydrology. And this relationship is not very straightforward. And fluvial sedimentary records have been used to reconstruct only the hydrological conditions, whether the runoff, the discharge in the catchment area and the rivers, whether it goes higher or lower. But when we try to understand the effects of climate simply from the fluvial records, there are several challenges because of number of reasons. One of the main reasons is that different rivers have a different response time. Some rivers, they respond immediately, others, they take a longer time to respond to the changes in the climatic conditions and the environmental conditions. And one of the reasons is that it is a question of the threshold. Every river system has a different threshold. So some rivers which are close to threshold, they respond immediately to the changes in the climate and the environmental conditions. And other rivers, they take a longer time to respond. So the main river, the response of the tributaries also varies from region to region. Then the second reason is that the fluvial records are often destroyed. They are not continuous. Because of large flood events, the sediments which were deposited during low discharges are flushed out and eroded. So the fluvial record is not complete. And there are other reasons like the alluvial rivers in general, they keep on shifting their courses, they migrate, or sometimes they are abandoned because of erosion and other reasons. And the fluvial response...
May I disturb you for 1 minute?
Sorry?
Just, can you click on this hide? There is a bar in below, no? Stop sharing and hide. Please click on this hide.
Okay.
Now it is okay. Thank you.
Okay, thank you. So, and another reason why the rivers, the fluvial records cannot be used directly to interpret about the climate is that the fluvial activity is also governed by non-climatic factors, like, for example, tectonics in that particular region. So as you know that in the uplifted areas like the Himalayas, incision is a dominant fluvial activity. Then along the coastal areas, the changes in the sea level, rise or fall in the sea level also determines whether the rivers will be aggrading or they will be incising. And there are some rivers which are known as allochthonous or autochthonous rivers. Like Nile, for example, is an allochthonous river that it originates in a high rainfall zone and passes through a very dry region. So the characteristics of the river are determined by the rainfall that or the climatic conditions that prevail in the catchment area and not in the lower reaches. So because of all these factors, it is often difficult to understand the response of climate, of the rivers to the climatic changes. Another problem is that we have many different types of rivers, but two main categories are bedrock rivers and alluvial rivers. And in bedrock rivers, the response is very different than the alluvial rivers. And the alluvial rivers, as per the definition, these are self-formed rivers and they adjust because they flow over alluvium and they can adjust their dimensions, they adjust their slope. So they have a lot of degrees of freedom. And depending upon changes in the climatic condition, they adjust their morphology. The bedrock rivers are more controlled by the substrata characteristics rather than climate and other factors. So it is relatively easier in case of alluvial rivers to reconstruct the fluvial history. A general cartoon here gives you some idea about two major types of fluvial activity, that is fluvial aggradation and incision. So during aggradation, the valleys are filled with sediments because of transport limited conditions. That is when the sediment supply is more than what the river can transport. And during incision, there is supply limited conditions. That is, the river is able to move all the sediments received from the catchment area. And in between these two, when there is an equilibrium between the supply and transport, that is referred to as steady state. The river does not show any major changes in its morphological and fluvial characteristics. So the fluvial aggradation and incision therefore reflects the characteristic of discharge and the sediment budget. And this is recorded in the sedimentological archive or record, as it is known as. So normally, in order to reconstruct the fluvial history, the earth scientists, they undertake sedimentological and stratigraphical studies, the textural characteristics, the mineralogical characteristics, the stratigraphy. Then the age is determined, and on the basis of that, one can reconstruct the fluvial history. Now, a very important part to identify these phases or episodes of aggradation and incision is to date these sediments. Now, dating is a big problem because of the availability of datable material. And different methods are used, like carbon-14, uranium, thorium, and optically simulated luminescence, that is OSL. Now, in case of carbon-14 and uranium, thorium, you need organic material, basically for carbon-14, like wood, charcoal, shells, or bones. And in case of uranium, thorium, bones and calcaretes and other material can also be dated. But if you do not have any fossil or any organic material, still now this new method of OSL, luminescence dating, can be used to directly date the sediments. In addition to this, the occurrence of fossils, these are some of the fossils that I have discovered, like the elephant tusk, and the Acheulean or Paleolithic tools, they also give you some idea about the age of the deposits. Sometimes you have volcanic ash. Now, for example, in many rivers of peninsular India, you have this layer of volcanic ash coming from Sumatra, Toba volcano, and which was deposited about 74,000 years ago. And this is a distinct marker, stratigraphical marker, and wherever it occurs means the sediments which are lying below that, they are older than 75,000 years, and those sediments which are occurring above that are younger than that. So by using these different techniques, one can establish the age of the deposits. Now, when we want to identify periods of aggradation and compare it with the climatic characteristics or changes in the climate, we have to first constrain the period of aggradation. And for that, for example, in this photograph, you have to have an age from the top as well as the bottom. So this will tell you that how long it took for the sediments, this huge thickness of the sediments to get deposited. And from this, one can identify the aggradation phases. However, the basic assumption is that no material has been eroded. But there is a problem with dating the erosional events, because erosional events cannot be directly dated. So these erosional events can be ascertained only if you have large number of dates of the alluvial deposits. So which are the previous deposits and which are the younger deposits. So the time interval in between can be considered as a phase of incision and excavation. Now, one of the methods that has been adopted is that when you have large number of carbon-14 dates, fortunately, because since 60s and 70s, this technique was available, the dates are available. So all these dates can be compiled and analyzed, and probability distribution plots. This is known as meta-analysis, that is change analysis. And from this diagram, which I have prepared for peninsular rivers, as you can see, these peaks, they represent period of aggradation. And when you have low probabilities, but a number of smaller peaks, that indicate continuous phase of deposition. There was no major short period of aggradation, but a long duration of aggradation. So this is how we try to reconstruct the fluvial history. Now, if you want to correlate it with climate, then I have already told you that from fluvial records, it is often very difficult because the fluvial records are incomplete to reconstruct the past changes in the rainfall condition or other climatic parameters. So for that, you have to use different types of archives. And these archives are known as proxies. And proxies, they can be used to infer some climatic parameters like temperature and precipitation. These are the two climatic parameters which are often inferred indirectly from proxy records. And I'm sure most of you know that there are different proxy records, and these are high resolution records on the decadal scale or century scale, or even sometimes on the annual scale. You can reconstruct the climatic parameters. And in the low latitudes, the interest is always in case of the precipitation, that is rainfall. In addition to ice cores and tree rings and corals and speleothems, the sediments in the oceans, they also provide a more or less continuous record of changes in the precipitation on land. And another source of valuable information about climate is the lacustrine deposits or the lake deposits. Now, here is one example that recently appeared. This is from Laos. They have used the speleothem, and they have obtained a very high resolution, almost on the sub-decade scale. And this shows these are carbon isotope plots, these particular graph, and this shows a very distinct period of aridity. And this period of aridity has been observed from Africa to Asia. That is the end of the green period of Sahara occurred around this particular time interval, between 3,000 to 5,000 years before present. And lake records can be used. This is a sediment core from Lunar Lake, and a lot of different geochemical proxies, stable isotope data, magnetic data, magnetic susceptibility data, as well as pollen data can be used to infer about the climate, the environmental conditions. So from this, once the climate is, the different periods of climatic changes are identified, then the data from the fluvial records can be plotted below that. For example, here, as you can see, this is LGM, that is last glacial maximum. When the conditions were driest in the low latitudes, this was the period where you see most of the clustering of the radiocarbon dates. And during the early Holocene, when you have a wetter climate, there are very few dates. So this indicates that during LGM arid phase, the rivers were depositing, and the whatever organic material, bones, animal bones, or wood was getting buried. That was the phase of aggradation. And then during early Holocene, represented by this light blue color, the rivers were aggregating. So there was no deposition, so no organic material has been preserved, and therefore there are fewer dates. Now this period appears to be shorter because the x-axis on the log scale, please note that. So like this, the fluvial records are studied, they are dated, and then we try to compare them with climatic records. And climatic, the phases are inferred from other proxies, like the lake record or speleothems, which provide more or less a continuous record. But in India, there are a lot of problems with the speleothem records because there are long gaps. The formation of the speleothem sometimes suddenly stops because of local factors or regional factors. So now, after giving a general background, I'm going to tell you a little bit about the Indian peninsular rivers and the geomorphic history, the fluvial history during the Holocene. So the Indian Peninsula is one of the largest province of India, and the oldest, underlain by very old rock. It is basically an erosion landscape. So the deposits are very, very limited. And this is a very old landscape, as you know, as a part of the Gondwana land, only covered by younger rocks in western and central India by the Deccan Traps. And the western and the eastern margins are passive margins, and on the western margin, you have a major escarpment known as the Great Escarpment of Western Ghat. And this is the source of the three main rivers, that is Godavari, Krishna, and Kaveri. And all these rivers are rain-fed. During the last 10 million years after the establishment of monsoon, they are monsoonal rivers. Now, here in this map, I have compiled all the available data, different types of proxies, like blue circles, they represent the lake records. Then these diamonds, they represent the alluvial record with luminescence date, alluvial records with C14 dates, and the paleoflood records. So apart from the river data, fluvial data, I'm going to first talk about these three paleoclimatic record. In center, you have the Lonar Lake, and then in the Bastar area, you have another speleothem record, and in Meghalaya, you have another speleothem record. So this is the Lonar Lake record, and it indicates that the first half of the Holocene, roughly about up to 6,000 years, the climate was better, and after that the monsoon has become weaker. Now, this is not the only study. Lonar is one of the biggest, it's a meteor lake, as you know. It's one of the biggest natural lake in peninsular India. But there are other lakes also, and I have compiled the data for all other lakes which have been studied by different scientists from different parts of the country. And they more or less, there are special variation. And there are problems with the interpretation, as well as we know that the monsoon rainfall is not uniform regionally. It varies spatially. And that is reflected in this particular record. So by and large, the early Holocene was very wet. Now, this is the record from the Meghalaya cave. But this record ends at 5,000 years. So we have, before 5,000, what was happening up to the last 35,000 years. This gives you a clear picture when the monsoon was weaker, when it was stronger, and it became weak again during 7,000 to 5,000 years before present. So by using these records, I have compiled this information also from the ocean records. So from ocean records also you can see that the early Holocene, these are Arabian Sea record, and this shows that the monsoon rainfall was increasing. This was the time of increased insolation over the northern hemisphere, as you know. Then I have compiled all the radiocarbon dates, and I have prepared this probability-based record. And from this you can see, we can identify distinct phases of aggradation, which are represented by high probabilities, and it is shown by these bars at the top. These are the major clusters. So this was the period when the rivers were depositing, dominantly aggrading. So these are the alluvial phases. And in between, when the probabilities are low, that indicates that incision was taking place. Incision was the dominant activity. So roughly from 8,000 to 7,000 years before present, and 4.9 to 4.1 kilo years before present, the rivers were aggrading. And these periods, they roughly coincide with two major global events which have been identified at 8.2, 8,200 years ago and 4,200 years ago. Roughly they coincide. But the regional picture is much more complex. And you find that some rivers were also aggrading during early Holocene. And in this map, I have shown these two areas. One area, these rivers, there are some rivers tributaries that originate in the rain shadow zone. I told you that you have this Western Ghat escarpment, and on the eastern side, you have this rain shadow zone. So because of the rain shadow zone, there is semi-arid conditions already, even during early Holocene. And the rivers originating in this area were responding, behaving differently. And then the data available from the Tamil Nadu area, these are small rivers that originate in the Eastern Ghats and drain into the Bay of Bengal. And they were responding to changes in the sea level. So there were other factors apart from the regional change in the monsoon rainfall. And therefore, you see the response is regionally, by and large, same for major rivers. But for other rivers, there are some rivers which show a mismatch, that they show out of phase aggradation. Okay. Now, when you compile all this data from the ocean records and the lake records and the fluvial records, you find that in general, during the drier periods, there was deposition, and during the wetter periods, the rivers were in general incising. As I told you, yes, there were some rivers which are not following this particular trend, and because of non-climatic factors I have mentioned. Now, this was also, so during the early Holocene, I'm confining to Holocene, so I've told you that during Holocene, which begins about 11,700 years ago, and the first half up to 6,000, this was a wet, very wet period. And all the major rivers of the peninsular in India, they were incising. But there were some rivers that were also depositing. And I have already told you the reasons that we think is responsible for this abnormal behavior. But there was a distinct phase of aridity, and which I have also shown you from Laos. So this is a global period of very severe aridity, almost 1,000-year period of severe drought in Asia to Africa. And this was followed by a slightly wetter condition. Now, because of this aridity, a recent paper that was published in Scientific Report this year only, they have studied the pollen data, the vegetation data from the lake records, particularly in Nonar, and they have inferred, they have proposed a theory that after 6,000 years, the forest cover or the trees, their frequency significantly declined, and this led to the expansion of the grasslands. They call it savannahization. And this was responsible for the introduction of agriculture, that is, the people living in about 4,000 to 5,000 years ago, they were forced to settle and start practicing agriculture. Now, when we plot these settlements, these are known as Deccan Chalcolithic cultures and Neolithic cultures. When we plot this, you'll find so far 800, more than 800 sites have been identified where agriculture was practiced immediately after the very dry period that occurred during the mid-Holocene. So they are mostly confined, as you can see, not to very wet areas, but a semi-arid region. So the high-resolution climatic records suggest that the rivers have, not only the rivers, but the human cultures and their behavior was also determined by changes in the climate during mid-Holocene. Now I am coming to the common era. So common era is the last 2,000 years. Now we do not have a continuous 2,000 year record, high-resolution record from any proxy. But for the last 1,500 years, roughly, it tells us that the monsoon rainfall has varied depending upon the global climatic events. Now, these are the global climatic events which I have written on the top: the Dark Age Cold Period, the Medieval Climate Anomaly, the Little Ice Age, and the current warm period. So you'll find that this graph, the blue color graph, shows that here during the medieval climate anomaly, the climate was better, the monsoon rainfall is increasing. And during the period before that, the frequency of droughts were these stars, they represent droughts. And the Little Ice Age was characterized by severe drought. Now, this was the time, the Little Ice Age, when the Mughals came to India. So a lot of changes, even on different time scales, have occurred during this period. And one of the major, one important information that tells us about the climatic changes is the introduction of tank irrigation in South India. Now, in South India, if you see any topo sheet or map, you'll see thousands and thousands of tanks. And many of these tanks, some of these tanks are very old. And this tank irrigation was introduced when the monsoon rainfall was very weaker before 900 CE, Common Era, and during the Little Ice Age. So this was the time when the emphasis on tank irrigation in southern India was more because the monsoon was very weak. Now, I have also plotted a lot of data, and I don't have time to discuss about the flood behavior during the Common Era. But in general, although there are lags and leads, the rivers have responded to the major changes in the climatic conditions which have occurred even at the global scale. Now, I'm going to summarize because I've lost 10 minutes. I went a little faster. So, in summary, I would like to talk about what we have understood about the behavior of peninsular rivers. Now, I have already told you that the peninsular rivers are, the peninsula is an erosional landscape. It's a rocky landscape, unlike the Ganga plains, for example, where you have extensive alluvial deposits. So here, alluvial deposits are confined to certain areas only. But in spite of the rocky and erosional nature of the landscape, the sediments, the fluvial sediments, have been preserved in this area for thousands of years. And as I've shown you that in some of these deposits, the volcanic ash, which is about 75,000 years occur. So we definitely know that some of the deposits are almost 1 lakh or 100,000 years old. So that then in general, if you look at the regional picture, if you take the consideration, the behavior of all the major rivers, then during the early Holocene, I have told you roughly from 10,000 to 6,000 years, fluvial incision was the dominant because that time the climate was very, very wet. It was one of the wettest climate in the last 100,000 years, in the last 1 lakh years. And because of increase in the rainfall, in the vegetation cover, the rivers experienced significant increase in the discharge and the stream power, and they started incising into their older deposit, giving rise to terraces. So they have basically excavated their own deposits. Then after about 6,000 years, the climate became drier and the river started depositing. So that was the mid-Holocene. And in the last 3-4 millennia, 3,000-4,000 years, basically the fluvial activity in peninsular India has been dominated by incision. But sometimes small phases of degradation have occurred, and we know about this because many of the Chalcolithic settlements are covered by flood deposits. Many of the historical sediments are covered by flood deposits. So some aggregation has occurred in this particular year, but during the last 3,000-4,000 years, the fluvial activity was dominated by incision and excavation. And as I told you, during the Common Era, The medieval climatic anomaly, this was the time when the monsoon was relatively wetter and there were more floods and there were, so the flooding activity was more. And the flooding activity was minimum during the Little Ice Age, particularly what we have found in the Central Indian region. So now what are the take-home points? So from this, the case study of peninsular rivers and the general introduction that I gave you about how we infer about the fluvial activity and how we compare them with the inferred events, climatic events, we can draw certain conclusions. And these conclusions, what they tell us, that some rivers show a reasonably good correspondence with the wetter and drier phases. But because of other factors, non-climatic factors, other rivers display a very complex response in processing the climate events. And as I told you that there are many, many other factors apart from tectonics and base level changes. For example, I mentioned that the rivers originating in the rain shadow zone, or which are draining directly into the sea, smaller rivers. So the rise and fall in the base level has dictated their response rather than climate change. And one of the main problems in the reconstruction of fluvial history is that the erosional phases cannot be directly taken. So they have to be always inferred by ascertaining the ages of the previous aggradational phase and the subsequent aggradational phase, and then the time interval between these two phases is then inferred as the phase of erosion. So with this I conclude. Thank you very much. I'm sorry about we lost 10 minutes, but I've tried to complete it before time, so we have 10 minutes for discussion.
Okay, thank you so much, sir, for your deliberation. And now it's the time for discussion. If you have any question, you can write on the chat box or you can raise your hand so that one by one you could interact with Professor Kale. Ram Kolabkar, yes. Yes, Ram, please turn on your camera and ask the question.
Yes, please.
Ram, please turn on the camera. Yeah.
Yes, sir. Am I audible?
Yeah.
Absolutely.
Sir, my query is just a little one that how can we segregate the volcanic ash from the other material?
Sorry?
How can we differentiate the volcanic ash from other sediment?
Yeah. I mean, volcanic ash, the layer is very distinct, provided that it is not mixed with other sediments. Okay. So if you have this layer, distinct layer, which has not been eroded and redeposited, then you can see a distinct whitish or buff colored layer. I have shown you one photograph. So if it is not eroded and it was immediately buried after the ash fall, then it is very well preserved. It is about never more than 15 centimeter thick. Never more than 15 centimeter thick. So you can identify. But if it is mixed with sediments, then it is very difficult to identify in the field. If you suspect that there is ash in that, then what you have to do is just observe the grain under microscope. They look like fragments of glass, glassy appearance they have. And they have very sharp edges. So before you talk to an expert geologist about and verify this, you can just observe it under microscope if you suspect that this is a volcanic ash. Okay?
Yes, sir. Yeah. Thank you, sir.
Okay, then Manushi Devnath, you can see.
Yes, please.
Manushi, please open the camera and ask the question.
Yes. Good afternoon, sir.
Yes, please.
So it is a wonderful lecture for us. Sir, I had one question. using this through this presentations, we can find a wait period in between nearly 4.8 thousand, like 8,000 BP to nearly 2.2 BP. So, sir, is it just opposite to what we know Meghalayan ages that started around 4K? Is it matches with that, or it's just contradictory part we can find in peninsular India?
I'm sorry, I mean, little louder, please. It's not very clear.
So,
Yeah, 4.2.
Yes.
4.2. Yeah,
4.2
4.2 is a globally identified event. Okay. And that has been considered as the boundary between the Meghalayan and the earlier period. Yes. So it is a globally identified event. Yes. Yes.
So, is the peninsular India also respond with the same climatic events?
So the problem is that depends. No, there is directly it cannot be identified. And one of the reasons for this is that you really need high resolution data to pinpoint that. But changes have occurred. There is some change. But whether it is 4.5 or 4.2 or 4.3, we're talking about 100 years. So you need that kind of accuracy and high resolution data to pinpoint that this is a 4.2 event. So far, we have not, because some of the best record is coming from Lonar, and this Lonar is a sedimentary record. It is not a ice core or a speleothem record. So exactly cannot be identified. And whatever data from Bastar and Kurnool and from Karnataka is available, for that period, there is no data. No speleothem of that period was found. So that is a problem. Yes.
Okay, sir. Thank you so much.
Yeah.
Anyone else? We can take, I think, 2-3 questions. 2-3 more questions. The young geomorphologists, we are still waiting. We can take, I think, 2-3 more questions. Sir is here. You may go ahead. I'm sure you have many queries. Ankita Paul. Yes, Ankita, go ahead and open the camera, please. Yeah.
Yes, sir.
Go ahead.
Yes, please. Yes,
Good
please.
afternoon, sir, and it was a wonderful presentation, and we got to learn a lot from it. Sir, would you please tell us more about the way of data collection for OSL analysis?
Data collection for OSL analysis.
Yes, sir.
Data collection for OSL, basically it measures luminescence of quartz and feldspar. So rocks which have good amount of quartz and which have good amounts of feldspar, particularly granitic rocks, the sandstones, the quartzite, the sand, the sediments coming from these rocks. These are best, not from volcanic rocks like basalt. Basalt rock is not suitable. The sediments coming from basalt terrain, but from the granitic terrain, sandstone terrain, quartzitic terrain, the sediments, they are rich in quartz. That is one. So basically, what is the type of rock in the catchment? That is important. Secondly, the luminance tells you that when this sediment was exposed to sunlight or was on the surface the last time. Okay. So when the sediment is in transportation, it is exposed to sunlight and its luminescence or its record is zeroed, which is called as bleaching. So the sediments get bleached. Once they are deposited, they acquire the luminescence from the radioactive minerals which are present in the sediments surrounding that. And the older they are, they acquire more luminescence. Okay. So therefore, sunlight exposure, when you take the sample, there should be 0 sunlight exposure. Otherwise, the record will be reset. So therefore, it is in PVC pipes or in steel pipes or iron pipes, the samples are taken, they are hammered into the sediments, and immediately they are closed and taken to the lab. So from that, then in the lab, the luminescence can be measured and the age can be ascertained. Is it clear?
Yes, sir. Thank you, sir.
Yes. Yes. Anybody else?
I think we can accommodate one last question. Arindam Chaudhary, open the camera and ask the question. Yeah, Arindam, please go ahead.
Yes. Somebody in the chat box, there was an answer. There was a question.
Turned off his microphone. Arindam, could you please turn on? And sir, I'll just read out.
Yes.
What
Can you hear my question?
Okay, let Arindam speak first. Yes, Arindam.
Sir, I have one question. How to compare the paleoclimate of two different regions in a specific time frame or specific time window?
How do you compare?
Yes. Compare the paleoclimate of two different regions in a specific.
No, I don't understand the question. I don't understand the question. Why you want to compare two different region paleoclimates? And paleoclimate means you are inferring that this is a wetter phase from the proxies, geochemical proxy or some other proxy, biological proxy. You are inferring that 8 to 10,000 years ago in Western India, the climate was wetter. And another proxy, another record from Eastern India, you infer that it was not 10 to 8,000, but 11 to 6,000. Okay. So that is how you infer. So for that, you have to have a local proxy.
Okay, sir. We'll just take two questions more. I think Shantomoy has raised his hand. Shantomoy, please go ahead. A bit fast.
Yeah, sir. Yeah. So, one of the main problem with this luminescence method and this...
Little louder.
Sorry, sir. One of the main problem of this luminescence method and this carbon-14 is redeposition of the sediment or the carbon material. So the material can be transported, deposited, and then
that is, yeah, in the fluvial system, yes. The problem is particularly in fluvial system. Therefore, you often get age reversals. Yes. That the younger units, they give older ages. So this means that the charcoal or wood was eroded and retransported and redeposited. But in lake record, this does not happen. Okay. Because the lake record is usually not eroded because it is at the lowest level. So normally it doesn't happen. Only thing, if the charcoal is brought by some tributary, older charcoal and deposited in the lake, then you will have this particular problem. Yes, this problem is there. So age reversal is a very, very common, and this also occurs in oil cell dating also. So it is not just this issue of whether it is eroded and retransported, but there are problems with the dating methodology also. Yes. So all those problems are there. But everybody knows, everybody understands, so nobody will question. In fact, people try to hide. They should not hide this kind of data. I mean, in science, you should not hide anything. I mean, whatever data is coming from the lab, that has to be presented objectively.
Thank you, sir. Thank you.
Okay, sir. So we are not taking any more questions because the second speaker, Professor,
yes,
already here. Sir, one thing, may I request one thing?
Yes,
there are some messages in our message box. You can see that 3 questions are already there. Sir, can I please ask you to answer this question in the message box itself, if it is possible for you? Otherwise, I can tell them to mail you. So whichever.
No, I'll try to do that.
Okay, sir.
Yeah, I'll try to reply there.
Okay, sir. Okay, sir. You please reply in the message box itself. Three questions are there. And sir, if there is any question from the participants, any more question, can they mail you?
Yeah, they can mail me, no problem.
Can I share the email address of yours?
Yes.
Here.
Or the other thing would be, because if others participants are also going to benefit,
yes,
we can, if you have a session, general session, then so I can answer that, so other participants can also listen and benefit.
Although we haven't,
No, I'm just saying that this is one option. If you do not have that, then it is okay.
Okay, sir. Sir, I'm just pasting your email ID here in the message.
Sure.
In the message box. Sir, please answer this question in the message box itself. These three questions. Okay, sir.
Okay,
Thank you so much. Thank you so much, Professor Kale. And I'll just move on to our second speaker of the day, Professor Milab Chand Sharma. Sir is already here with us. Professor Milab Chand Sharma is a professor of geomorphology in Center for Studies of Regional Development, Jawaharlal Nehru University, and he obtained the master degree from the same department, and he got the doctoral degree from the Royal Holloway University of London. With more than 60 peer-reviewed research papers in internationally reputed journals, his primary research interest lies with glacial processes and geochronology, and he also works on geomorphological hazards assessment in mountain environments. So he has also been associated as a visiting fellow at the University of Heidelberg in Germany and University of Salzburg in Austria. Sir, would like to welcome you. I would like to welcome you on behalf of the IGI Young Geomorphologists Forum. Professor Sharma. Let me check if... Sir, another thing, Professor Kale, sir.
Yes, please.
Sir, could you please turn off the presentation? You have still presented the screen, so you please stop presenting. Yeah, from below. I mean, I'm talking about this Google Meet. Could you please stop presenting? Yes, sir. Yes, sir. Yes, sir. Fine. Okay, let me just check with Professor Sharma. Participants are requested to wait for a couple of minutes. Sir will Meanwhile, I have shared Professor Kale's email, and if you have any query, you can email him. Just to tell the participants, another message I have that please, if you have any problem with that particular file, which is supposed to be used in the latter part of today's program, just let me tell you that we are still in the program now. I mean, you should have tell all these things before the program. I sent this mail well in advance, about 10 to 12 hours ago. So right now it is not possible to send the file again and again. Okay, so it is a request to everyone. If you have any problem with the files, with the materials which we are sending to you, you please tell us well in advance, because when the program is underway, it is very difficult for us to cope up with everything, to manage everything. So please bear with us. We'll try to reach you after some times. Your introduction, just start your presentation. You just start your Yeah, just talk with Professor Sharma and he will start his presentation anytime. So please bear with us for a moment. The presentation will be starting anytime.
কোথায় উনি আছেন এখানে?
বুঝতে পারছি না। ফোন পাচ্ছি। তো শুনি স্যার, ফোন করি।
Hello, Santanu.
Yes, sir. I have already talked with Professor Sharma. Actually, what happened?
Is he not available?
No. He is available. He was on YouTube actually. There was a confusion. He was on YouTube. And he's just joining.
Okay.
I have already sent him one email. I previously sent the email also, but somehow he missed it, and he was on YouTube actually.
Okay.
But don't worry, sir. After that, we have this lunch session, so we have some spare time. So.
Okay. No problem.
Still 15 minutes only.
But it is a very nice program.
Thank you, sir.
You organize a very well manner.
Thank you, sir.
I in between, I congratulate you and Sunil and your co-convener.
And Kapil is also there.
Kapil, Kapil, yes, मिलाओ जरा इनको Kapil. Hello, Kapil. How are you?
Hello, sir.
Hello, bye. Bye. कैसे हो? Fine. Kapil.
I'm fine.
Okay.
How are you, sir?
Fine. I'm also fine. Very fine. But my cousin brother lost a few days back.
Okay, sir.
So I not in original position.
Due to this corona?
Yes, not corona, but he is old man, 80 years old. Okay, good.
Kapil, sir is saying that let me join. Milap sir is saying let me join.
Okay.
Yeah, I think. Yeah. Sir has joined. Yes.
Okay.
So, on behalf of the forum, I once again would like to welcome Professor Milap Chand Sharma, Professor Jawaharlal University of India, and His primary research interests lies with glacial processes and geochronology, and he also works on geomorphological hazard assessment in mountainous environments. So, sir, welcome you once again, and you can share your screen for the presentation. Thank you, sir.
Sure. Is it visible now?
Yeah, sir. It is visible now.
Thank you, Professor Kale. You have covered many of the aspects that I wanted to speak today, and I'll take up from what you have discussed in this talk, but referring just to the mountains in the mountain landscape. So thank you, Professor Dave. Thank you, organizers.
You are not audible, sir. Sir, you are not audible. Like, can you listen to me, sir?
Hello.
Yeah. It is now coming. Yeah, the sound is coming.
Hello.
Yes, sir. It is better now. It is better. I think you have to come a bit forward because the microphone is not that, Yeah, this much forward and you can speak, I think. From this distance, it is okay. Yeah.
Hello.
Yeah, it is audible, sir.
I'm
it is
audible?
Yeah.
Okay. I just need to thank everybody and especially Professor Kale to have covered many aspects which are emerging fields and where we can compete with the international, geoscientists when it comes to the data that we produce. Today, I wanted to speak on fossil landforms fossil landforms that we have for the mountain areas and how we are using it as climate event reconstruction for the Himalaya. So I'll cover the techniques also. I'll cover the fossil landforms. That is what I wanted to discuss today. First, what is fossil landform? A landform which is there, but it is disconnected with the process that it had formed at one point of time. So most of the landforms which are related to the glacier and some of the glacial fluvial also and some of the mass movement deposits, I would like to share that these informations with you, and I hope I would be in a position to share some of the techniques. Yes. Yes. Hello. Hello.
Yes, sir. Yes, sir.
Is it visible? Is it?
Yeah, it is.
Yeah.
It is visible.
Okay.
The second point is, what are the data sources?
Yes. What are the data sources? So we have the data sources: our legs, our eyes, our brain, and also eye in the sky, and also and some of these modern techniques of geophysical investigations that we are doing, and some of the dating techniques that we have employed for understanding the time event when it happened, and also I would like to take you around the mountain landscape where these fossil landforms are there and how we are interpreting them in terms of its timing, in terms of its evolutionary history, and in terms of its the technique that we have used to determine the ages. So these would reveal the time of deposition, time of erosion, time of exposure also, and these we are making use in order to make a story out of whatever we do. As I said, data is a lot of data is there. So the timing we are considering, because the timing of glacial expansion or timing of these fossil landforms are to be related with global climate pattern, whether these fit into the system or we are trying to look at regional control of the climate, regional climatic control or regional topographic control on some of these events. Why do we need fossil evaluation? Because the timing has to be corrected in terms of whether it was global, whether it was regional, whether it was local, whether it was global. So this is necessary for us because the Himalaya is complex. Himalayan areas, if you look at the ranges, if you look at the altitudes of these and the terrain, it has a lot of variety of landforms, and the timings also, which are varied over small distances across the distances. So we are looking at this aspect as well. And what are the way forward that we will talk at the end of the talk. So the first is altitudinal organization of the landforms, that we look from the sky, we look from the higher peaks. Yeah, sound. No, I can hear you. Yes, Professor Day, I can hear you. Hello.
You are audible, sir. You are audible. You continue, sir. You are audible.
I'm audible. Okay. So looking from above, what you see is a process which is glacial process controlled by the altitude and the landform distribution. Hello, hello, hello. Hello.
Yes, sir.
You are audible, sir.
You are audible.
Hello.
Yes, sir. You are audible.
Are you letting me? Yeah. Are you letting me present it, or there is a discussion that is going on?
No, sir. Sir, first you can present your slide, then we can move to discussion session.
There's a lot of Sayantan, there is a lot of discussion going on behind the scene. Hello.
No, sir. Your voice is completely clear. The audience, they're getting your voice.
I can hear many of the people talking, and I cannot concentrate in presenting anything. If this goes on, you have to mute the others. Let me present. Let me present. There is discussion going on, behind the scenes. So I'm not in a position to concentrate.
Sir, let me just give a message to all of the participants. You please don't put any message in the message box right now. Don't need to say thank you and all. You please write the messages after the presentation is over. Otherwise, it is very difficult for the speaker to
behind the scene. So.
Yes, sir. It is very difficult for the speaker to concentrate. Please don't put any message right now on the message box. Sir, I'm so sorry for this. Sir, you continue, please.
I have already shared. I think it should be visible.
Sir, it is visible.
Is it visible?
It is visible, sir.
Okay.
Sir, you continue.
So, please, background discussion, it distracts me. So either you have to, mute others or let me speak on this.
Yes, sir. I have already sent the message to all. Okay, sir. Okay.
Hello, Professor Sharma. You please. Yes, sir. Yes, sir. Continue, please. we are actively hearing
discussion going on, so I couldn't concentrate on what I wanted to present. So please, mute the others. Let me present, and then we can discuss many things once I finish.
Okay, but we are
not audible.
You are audible.
Hello.
Clearly, you are
Sir,
audible.
you are clearly audible, and everyone here is muted.
Hello.
Hello, sir. You are audible, and sir, everyone here is muted, sir.
So, multitudinal organization that I.
Sir, everyone here is muted, sir. No issue.
Okay.
Yes.
Everyone here is muted,
So
sir.
let me just talk about that. I hope I will be in a position to, reach you.
Hello.
Okay. So the first control is the altitudinal control for creating processes of this nature. You can see how the glacier is formed. We will talk about it. But here, it's all landform distribution is controlled by the altitude. And you go away from the active process of glaciers, you will always find a lot of fossil landforms. These antiquities are to be interpreted, investigated, and then understood in terms of climate that these are related to. So identification is the first thing. Antiquity you will determine once you put the image on these, and the context you have to relate with whether it has come from the mountain itself or has it been deposited, brought in by and left behind by some process. So process identification is necessary for us. Now, this process, the process is well understood from accumulation-ablation relationship. Once accumulation exceeds, you will have expansions. But what is happening over the years, over thousands of years, is accumulation has reduced, ablation has increased. So, hello.
Yes, sir. You are
from that side.
No, sir. Yes, sir. Yes, sir. Yes, sir. Yes, it is fine, sir.
There's sound. There's my own voice coming from the other side. I don't know.
No, sir. Everyone is muted here, sir. I don't know. Sir, you are clear.
No. My own voice is coming. My
Okay,
own
sir.
voice.
Okay. That might be the issue.
Accumulation-ablation relationship that we're looking at and how these would affect the sustenance of glacier mass and evolution of landforms. So if there is changes in the accumulation area itself, what we initially see is the cirques. And if you look at here, the cirque is visible. So if this entire mass of ice is gone through ablation, which is the root of the day, what are we going to get? In the frontal areas, if you look, these are fossil landforms, whether it's rounded mountain edges, the interlocking spurs, or whether it's the lateral moraines which extend many kilometers down. So these are to be related. These are to be interpreted in terms of climate. When climate was cold, accumulation was more. How it extended. So but once this entire ice in the accumulation area, skew, which is called Cori, which is called Cirque also, what we are left with is this. The lakes, evolved lakes are there, so you can have the Dal lakes. And in most of the areas in the Western Himalayas, in the Trans Himalayas, you can see many of these Dal lakes have developed over the years. So that is indicator of climate change. Accumulation is reducing, ablation is increasing. So what we understand is the temperature possibly has gone up, so precipitation has reduced over the time. These cirques, the failure cirques, are the best ones that you look at in terms of how high how big the glaciers were, where they were originating from, and now these have been taken up by the Tarn lakes because the glacier is no longer there. So this is something which is a point of concern for all of us. Similarly, you can have high up areas. There are moraine lakes also. Yes, moraine lakes are there. So moraine lakes are there, but unfortunately, ice is no longer there. That means we have seen this temperature rise. This is Dholadhar, which is the lower Himalayas, middle Himalayas, sorry. In such areas, you can see lakes forming just because of the moranic damming of the area. If we get into the active glacier, and hello. So what is happening here is GEOMORPHOLOGY or survey that we talked about. So medieval, you see two glaciers coming here. One is here, one is coming here. This here, third form. What is this? Up from the mountain. Okay. Perfect. So if you look at the configuration of landforms here, this glacier used to flow in this direction. Now it has has become smaller, so the direction. Indian moraine has become lateral moraine concentration, which is very surprising.
Sir, sorry for interrupting. Gopal Kumar, please mute yourself. Gopal Kumar, please mute yourself. It is very difficult for us.
I had the sense of my students helping me in the system is there, the fund is there, Suresh is there, Sanjay. So we used to pick up this. So this is something that we want to look at. We are doing ourselves. We want to look at the exposure. These erratics have been brought in here by the glacier once it expanded from this. And these exposure ages, we are looking at when the glacier started retreating, when so antiquity of Tapoban, we have antiquity of the glacier, that the antiquity of the area that you can look at. We have done some exposure ages for Tapoban lateral moraines. We are doing more of this. But then what does it indicate? It indicates that glacier has shrunk in size from this to this now. This is the present surface. So it has downgraded. It has shrunk. Yes, sir. Okay. So we have the ablation valley. Ablation valleys have been looked at. So glaciers have been becoming smaller over the years, and over the last 1500 years or so, we are seeing it is becoming smaller and smaller, except for a small period of ice age. We do have the fossil landforms, glaciers, up in the mountain. Now, if you look at events, how events can Hello.
Yes, hello. Hello, sir.
Yes.
Yeah, it's fine.
It's visible?
Yeah, it is visible. I think the YouTube browser was open that time. There was.
So if you look at this picture of of the frontal area of Gangotri in 2017, we could count the number of ridges which are recessional moraines, and these are dated. These are historically recorded as 1889, 1935, 1971, 1980. These are all historically photographed positions. But then this happened in June. In July, August, there was a flood which has destroyed everything. So potential of preservation of the landforms, which are fossil landforms, is very, very poor in the mountain system. So this needs to be looked at. So whatever we had here in June was gone by October. So this dynamic nature of the process in the mountains is very important to look at. Now, if you look at this fossil landform, which is the upper limit of the glacier at one point of time, it's 270 meters higher as compared to the present floor of the river or channel of the river. So we have lost 270 meter thick ice from this area, but then time period can be anything in many thousands of years. So that many thousands of years we will bring out at the end of this presentation. Now, in the time when we started measuring this, in about 30 years, we have lost 25 meters in the frontal area. I used to walk on this in 1991, 92, but now there is no ice left. So this thinning of the ice is very, very fast in such areas all over, but larger glaciers are showing faster thinning as compared to the smaller glaciers. Here, if you look at the fossil records, one trimline, you have second trimline, you have third trimline, and you have the streamline also, but there is no glacier. So we need to interpret that 4 phases of glaciation have taken place in such areas. This is in the Great Himalayan part of the mountain system, and we are trying to work out on the ages of these also, using exposure ages, using vessel also. So we will come to that. Now, here we have a complete, different story altogether. If you look at the trimline of the higher order of glacier, this is the higher order of glacier that it existed at one point of time. It became smaller. So over the millennium, glaciers have become smaller and smaller in size, but then definitely there have been little expansions. But these expansions you can work out from the linear ridges, the lateral moraines, or the end moraine complexes that you have. Some have been destroyed by the debris flows. So debris flow has but if you look at these truncations and the smoothing, polishing of the bedrock, this is very, very important. But if you look at the relationship, cross-cutting relationship, this is the trunk valley. This was fully glaciated. This is the tributary. Tributary was blocked, so you had evolution of thick layer of lacustrine sediments. So these sediments, we are working on this right now. We will be in a position to give you some ages of this within a month or so. But then we have to think about the size of the glacier, ice thickness here, and when it was blocked, and how this lacustrine environment was created by blockade in the blockade of the tributary valley. Now, some of the fossil landforms are pavements, which is not very common, but we do have the shoulders. These shoulders are specific shoulders of higher orders, but then tectonics is also to be looked at, the uplift relationship and the previous glaciation. So this pavement is one which is very, very peculiar, and this is only found in Gangotri area, close to Gangotri. So this is not found in other glaciers. We have been to tens and tens of glaciers, but only places this. And we have tried to look at the exposure of this pavement also. I will give you some examples of this. Now, these polishings, as I said earlier, glacier ice was very, very thick. Timing is something like 60,000 years ago. So this is a huge, large number that we are talking about, many tens of thousands of years. But then these shoulders still remain undated, the higher ones. So there must have been previous glaciations and then the uplift also. But we do have the erratics, which we are dating these days using exposure date ages. Now, these polished surfaces are the ones which really give us very, very good results, because glacier ones went from here, as I said, 56,000, 60,000 years ago. So glacier was moving down. And then the variety of lithology that you see the striations also. So these are all indicators of the movement of the ice, at one point of time, but right now there's no ice left. So if you look at the smoothing also, some of these have been destroyed by rockfalls also, some of these. But this is very typical that you will have variety of lithology also. This polishing is very common, but you have to identify in the field where it is. Striations are all around in this, but no longer the ice. So paleo landforms of, as I said, many thousands of years ago, the glacier was going down. So you have to put these in order to understand whether this was one phase or smaller expansion, or whether this was one phase when it became very large. But then the directions of these landforms, fossil landforms, can give you some idea that this was something to do with interrupted episodes of expansion and contraction. Now here, as I said, we have dated these also. 1.4 to 1.7 Ka is what we got. We have lateral moraines all around, lateral moraines. We have ablation valleys. But then look at the amount of ice that we have lost over the years. Ice has just gone down. So in 1500 years, the glaciers have shrunk in size, whether it is thinning or whether it's shrinking from the size. So this is this we have observed over many of the glaciers that we have looked at. Some of the typical fossil landforms that we see. This is this glacier, Lamkhaga, if I correctly remember. But you have potential for dating these exposure ages you can get for these erratics. The typical U-shape that we as students, school-going students, college-going students, are used to learn about the glaciation, previous glaciation. This is the one that is very, very typical. Now, our best tool is the mapping. So we have mapped the entire area. We have dated the sediments. Whether it is these are the red ones are the oyster ages. The blue one is exposure age of erratic. So if you look at this glacier has been retreating for last almost 500 years. Roughly about 500 years. So Gangotri has been retreating for last 500 years. It's nothing new, but here we have 1.6, 1.3 as the timing of glacier becoming contracting in size and thinning from the surface. These are very, very typical. We have Roshamatanes. This is Paralacha. So Roshamatane also tells us that amount of ice was large, but there's no longer any ice left. So these do give us the idea that the previous glaciations were much larger than what we see today, current as compared to so this is very, very typical feature. Roshimatane, normally you don't get in the mountain areas, but we do have in the great Himalayan areas of Paralacha and close to Chandatal, Roshimatane are very common. Rogue glacier is one, but the rogue glaciers are indicators of reduced precipitation. Temperature has not reduced because caterpillar movement of the mass is still taking place, but precipitation has reduced. So that is how we would, interpret rogue glaciers in such environments. This is Nanda Devi Biosphere or Nanda Devi Park, National Park area. Even here, the glaciers have gone up. So this is a typical rock glacier in Nanda Devi Sanctuary that we tried to look at. We tried to date it, but then we didn't get much of the parts that was required for exposure dating. As I said, Baralacha is one where we saw Roshamatanic, but Baralacha also has beautiful pattern ground. So the temperature is staying as possibly it stayed long ago by keeping that periglacial conditions, but ice is no longer there. So it was vacated possibly 16,000 years ago, 15,000 years ago that we did some exposure dating of these boulders, erratics of this area. So 15, 16,000 is what we say. The complexity, pavement is there. Pavement is exposed. These exposures are 3.2 to 3.7 1,000 years. Okay, 3,500 years. We will keep it. So 3,500 years ago, do we understand that the glacier was flowing over this, or there was something else? So nearby borders, the erratics also we tried to look at. It seems that there was a massive flood which exposed this, otherwise overburdened pavement area. So that happened something 3,500 years ago. So that is how we have been interpreting not the glacier, but an event which was related. Maybe it was a trough that exposed this entire pavement, which was earlier overburdened by sediments. Okay, so streamline landform, the drumlins. Normally we say we don't have drumlins in the Himalayas, but then there are areas which are often broad areas. Drumlins are very common. We have tried to date these drumlins. It comes to 4K to 6K. So 6,000 onwards, these started evolving. That means glaciers had started retreating faster, and such landforms were created. Now, if you look at the present to recent past to further past, present, mid-Holocene, and late Quaternary. So this has given rise to the lake formation in the abrasion valley of abrasion area of this glacier. Glacier at one point of time possibly was this thick, but it has gone down. So Holocene, lateral moraine we have, and late Quaternary. We do not know when it happened. We have not been able to date this. In recent years, in decadal scale or in centennial scale, if you are talking in terms of 100 years, you compare 100 years of event. This is 1909, 2008, almost 99 years. It has retreated by 800 meters. This is Zemu Glacier, the Kanchenjunga Glacier. That we try to look at, and also the thinning that is important to capture from these fossil land records. Thinning has taken place all this while, and these erratics that we have here, we have some of the samples taken, so you know when this event started, the event of thinning, when it was deposited, when it started thinning down. So we are trying to do century of 1 century of record. All this glacier is gone from here, and this is the snout, present snout up there. 800 meters is lost in 100 years. And from above, if you look at, this was the 1909 position, but now this is where the glacier is. So, and previous glaciation, if you look at the larger ones, This extended up to Tista River at Zema. So this is high lateral moraine of the Zemu Glacier. As I said, at Zema, this is the record that we have of lateral moraine. This has been dated. Parvinder had done the OSL for this. So this comes something like 28,000 years. So 28,000 years, in 28,000 years, we had, we have been seeing the glaciers becoming smaller and smaller. Similarly, here, if you look at these erratics, these are fantastic, records, sampling sites for exposure ages, such as thinning here. So the thinning has taken place. We find that this thinning started something like 8,000 years. So 8,000, 9,000 years is what we are looking at. So Holocene evolution of landforms. In Gangotri, we have looked at, vertical succession 16,000, but the higher ones show 4,000, something like 4,500 ages. So this is what the area that you are looking at. So in this has been becoming smaller over a long period of time. From the close view, 4,000, these are aeolian sediments on top of the laterals, 4,004 and 16,000 bottom. So sediments kept, accumulating at the edges, of the ice on one side, on the other side of the glacier, giving this as older ones and the upper ones being younger. Now, this is something like 18 kilometers from the presence now, Lekustrain deposit. Professor Kali just said Lekustrain is the best sediment for the OSL. So these give us 35,000. 35,000 years ago, the glacier was almost 15 kilometers larger than what it is. Right now, it is 30 kilometers. So 35,000 years ago, it was another 15 kilometers longer. The glacier has become smaller and smaller time period. But these we have not been able to date, but then the U shape and then the successive lateral moraines are still there. This we need to work on. One of my students, Laura, is working on this. But one of the fun, surprising fossil deposits is erratics in the forest area. This is in the Mountaineering Institute complex in Manali. Huge erratics are there. So we have tried to look at the ages of this. Ishita is getting the age, so the ages should be coming in any day now, or within 20 days from now, because samples have been processed. We are just calculating the age. But it's again something like 20 kilometers from the present glacier. So glacier is 20 kilometers from this position. The sampling sites, quaternary records that we have sampling sites for OSL, Lekustrain is or the lenses that we have are the best ones where you can pick up the samples from. Lekustrain, as I said, large thick lacustrine deposits that you might have. You might have even drop stones in these because the ice normally floats into the margins in the lakes. So you may have some of the drop stones. Pavement, I said, we talked about the pavement. Now, here if you look at ice contact area, sedimentation, deposition would be different from the proglacial zone. So you can pick up the sample, the variety, the sharpness, the shape, the size, the orientation, all can be looked at. You can measure while in the field. That's why I said the best data source for us is the legs that we have. Two legs that we walk up to these glaciers, pick up the samples, identify the samples, and then process the samples. Some of the fossil landforms, possibly glaciers here today, these have become boulder trains. So periglacial process is still continuing in these areas. Glacier is no longer there. I will avoid these. But midland, upland relationship can be built. midland areas have many of the terraces that you can count. 5 terraces. Are they related with each episode of glaciers? Upstream, this is Bhagirathi River, Bhagirathi, before this, then known as what is Tehri. Before Tehri, this is much before Tehri. So you have 5 sets of parallel, terraces. Are they related to the glaciers upstream? The events of glaciation in the higher areas? I do not know. I still need to look at these and build the relationship someday. And in Nubra, if you look at most of the sand that you have, the dunes, these sediments have come from the glaciers upstream, from that largest glacier that we have. What is the name for that? I can't recollect. Siachen, yeah, sorry. From Siachen, it is being picked up by the winds and deposited downstream in Hunda. So upstream, upstream and low stream or midland areas, you can have the relationship built on these areas. In terms of looking at decadal changes or centennial changes, these are the changes. 1889, Grease Wedge, and 2017 we took some exposure ages also, which comes closer to 1889. So these are the stories of British time that we have the records from. So records are there from British time, 1866. If you look at the same place, take the photograph from the same place, you will see the thinning of the ice. This tributary was joining it, but tributary is not there. So this has been happening 1859, 1991, 1889, 1950. You can compare it, how these are happening. So decadal scale, you can have a lot of landform there. Landforms are still preserved, but in one event like the 2017 floods, it can destroy everything. So these are the decadal changes that we have observed in these areas. Some of the glaciers do not show any changes. They are expanding, but why they are expanding, I have no answer to that. Okay, decadal changes, 50 years. 1971, 2018. If you see, this has gone back. Glacier has gone back, but shape is retained. The mass is thinning down. Some of the techniques which are modern techniques, these can be used for looking at the older ones also, older platforms that we talked about, and then glacier becoming smaller. Incision, as Professor said, incision took place upon subsequent expansion of glacier, and glaciers have become smaller and smaller. So you have all these records are there in the watershed that you go to. This is a glacier. So you have the little deposits. You have the terraces also. So modification takes place. Verification we do from orientation, we do from the shapes, we do from the size, we do from the micro analysis also, and we do from all these glacial equestrian relationships that you can build. All these have been deposited by the glacier, but lagostrine margins have deposits like this, best for optical dating. But in Qutub Minars of mountains, these hoodoos have been left behind. So earth pillars are typical, but difficult to date. Dating of these landform is very, very difficult. Now, relationship, if you work out, once the glaciers became smaller, the slopes started failing. So you have Protalus rampart also. You have huge slip of the mountain sides. So you can have complex landforms of this type. The modernization, you have techniques, you have probatic total stations. You can map it. You can take the GPRs also. You can look at the thickness of the ice. So for Gangotri, we tried in the lower areas. 121 meters thick ice is still there, but then retreating. This we talked about 400 and this. Optical edges, if you look at the concentration, 3,000, these are all to do with the bluff that I said, the floods, but the recent ones are 1.6, 1.32 KAs. For OSL, these are the sampling size. These are the typical areas from where you can get the best of the edges, and these are the edges that we have from 16,000, starting from 4,000 to 37, 35,000 to 74,000 to 88,000. So this has been the story of the glaciation in the mountain areas. If you look at large number of dates we have, we are still relating. The best thing that has come out is the best of the geomorphologies for this area, geomorphological maps we have done, and from past. This was the past event of 8,000 years, 9,000 years, and then when the tributaries expanded, there were lacustrine deposits, but presently this is how it looks like. So this is the reward that we get, perfect picture through time. And as I said earlier, each successive expansion or episode has been many degrees limited in extent and magnitude. So glaciers, each glaciation has been smaller to the previous. Prostocalysis evolution rainfall curve, if you look at oxygen oyster. So 9,000, that expansion, smaller expansions we talked about. This one, this is the 9,000 event. This can be related to the intensification of the monsoons that we have. Some of these timekeepers are there. This river comes from Tibet. This is not this is a tributary of Indus. This has been like this. These are Grand Canyons with thousands and thousands of years of history. We have not looked at this. We need to look at to build on. Neotectonics is one that one has to look at. The scarps are forming. Whether Pangong Lake is going to drain into this side in the future, we do not know. But nature has many things, in store. So this may, if this fault becomes more active, if it is activated, this may drain into the other side. Best of my teachers. Map that I make use of, identification and association, and from identification and association of the fossil landforms, you can use it for exposure, you can use it for OSL, and if possible, you can use it for the radiocarbon also. The hotline that we get from God Almighty, it comes straight once you are in the field. If you look at the hotline here, you see this message is coming from our God when we are confused, and whenever I failed in the past to establish scientific rationale, I took God's refuge for everything. Because once you do not have the scientific explanation for an event, you say, Bhagwan, you have done it. Chahe Bhagwan ne kiya, koi Ram ne kiya, या भगवान कृष्ण ने किया या हनुमान ने किया. So it is the continuity of our inquiry and relating it, interpreting it, and associating it in scientific manner. That is what we need to do. And I would thank you with this slide. Thank you very much. The questions are most welcome. I would benefit from the questions if you raise some typical questions. Thank you very much.
Thank you so much, sir. And yes, we indeed enriched by your talk. And now it is time for the participants to ask the questions.
most important part. Yes.
Yes, the most important part. So you may go ahead. You can raise your hand.
Yes.
And ask the question. Please go ahead. I'm sure there must be many. Yes. Oh, I'm so sorry. Accidentally, I raised my hand. No, it is for the.
Oh, you asked me something. Yes.
No. I let the participants ask first. I will let them ask first. Please, you go ahead. The participants, you please ask the questions.
All have left for their lunch, it seems.
Yeah. They were. No, we are just 5 minutes behind schedule. Nothing, not much. You go ahead and you please open the camera, please.
I'm not in such a position to open the camera, so extremely sorry for that. Actually, I have a question to our respected Milap sir. Actually, there exists one very old dictum in geography. We know that the Britishers actually invented this particular created this particular dictum in geography that is called as related with the Carboniferous glaciation, and the hypothesis is called as snowball earth hypothesis. Sir, you have got a very vast experience that you spend in field and expeditions. I just want to know one thing, that sir, did you experienced any kind of glacial imprints that is related with Carboniferous, or that we can relate with the snowball earth hypothesis in Indian context, sir?
No, sir, not at all. Not in the mountain areas, as it's extremely dynamic. It's not just the altitude, but also the tectonics. So the previous records you won't get. All that we have is 100,000. 100,000 is not something that you can relate with Carboniferous. You see? And also, largest of our glaciation, what you call, which is known as European last glacial maximum. Our largest of the glaciation occurred something 60,000, 80,000 years ago. Ever since, our glaciers have become smaller and smaller. It was not that just like Europe, it expanded 20,000 years ago or 22,000 years ago. No. But we do have the records of 9,000 in the Holocene, because the younger the landforms, better control we have of the dating. So it can be related with intensification of the monsoon. One of the pictures the diagrams I showed you, intensification of the Indian summer monsoon is showing glaciers to have expanded in the early Holocene. But ever since, these have become smaller and smaller. We try to look at the Little Ice Age also. And Little Ice Age of the Himalayas is much later than the European style of Little Ice Age. There's a 16th century, ours is coming to something like 18th century. So regional control is also there. Is that all right?
Yes, sir. Thank you, sir.
Okay. Anyone else, please? Please go ahead and ask the question.
Thank you, Sarji.
Sarji, thank you. I had some problems with the machine, and because I'm on a holiday back in my village, so connectivity is also a big issue.
Yes, I understand.
I'm very sorry, because it initially I thought I was listening to some sound and voices. Please feel free to ask us any question. The techniques, technology that we are using is all available in India. Whatever I talked about is available with all over, in different institutions in India. Make use of it for all investigations that you want to do. We have one OSL, lecture for the entire day, where we will show you how to collect the sample, how to separate, how to process also, that we can always think of. We can have the same thing for the exposure ages, CRN ages, because it's available, it is functional now in India, so you can make use of it. Yes, please.
Anyone, please? Please raise your hand. Please go ahead, raise your hand and ask the question, please.
There's no question on the glaciation, no question on
It's very
fossil
surprising.
landform.
Sir, I'll just, it's not a question. Sir, I mean, just one word of one, sorry, sir, are you there, sir?
Yes.
Okay, you just put off your camera. Okay.
Yes.
Sir, I just seek your advice. Like many of us, we are working on the deltaic environment or on rivers or various places in India. It is not very common for Indian geomorphologists to work in glacial environment. So I know you, I know your scholars very well, but there is, not too many people who are working in the glacial environment. So, what would be your advice to the budding geomorphologists? Why would they take up glaciology as their, special discipline? And how to deal with the difficult conditions related to the terrain and climate in the high mountainous regions, especially in the Himalayas? It is not very easy to work there.
Sure.
So what would be
my answer is simple. Glacier ice is the most sensitive parameter of climate change. And today, because accessibility has reached all corners of Indian mountains, you can ride and reach the glacier within few hours. You have to have, you don't need special training, but you have to have the sense that how the weather is going to change, because weather is a factor here, because it can snow anytime here. Otherwise, crossing the rivers, streams, that is another problem. One has to be very careful about it. One has to know how to negotiate, these mountainous small streams. And at times, the problem is with the rockfall also. Rockfall becomes slightly dangerous. So you have to choose a route which is the safest. And till today, we never had any problems because we make sure before we go, we have everything in order. The routes are charted out, that we will take these routes. If we have to cross the stream, we take, those collapsible stairs that come, aluminum stairs. We take that, so nobody has any accident. Nobody meets with accident. So care has to be taken. But these days, it has become very easy to reach the glaciers because roads are up there in the mountains, so you can reach within few hours time all these things. Okay. And techniques are there, remote sensing is there, your field technique is there, your lab technique is there, everything is available in India. And my students have done wonderfully good. They have been my assets, really. They are the ones initially.
And in spite of the remote sensing techniques, you obviously have to go to the field to monitor how much the glacier is receding and all. And there must be some stations that you and your team have put up in different parts.
We have a station. We have a permanent station on one of the glaciers, which we call as benchmark glacier. We are doing GPR. We are taking weather parameters also there, and we are doing discharge, measuring discharge also of the glacier. All kind of little things to understand. So this is with us for last 5-7 years. We would like to continue working on that. And people who want to work with us, they are most welcome. Summers, June is the time when we go, and in autumn we go in September, October, before 15th of October. But unfortunately, last 2 years have been really bad time.
Yeah, obviously for a field, for a subject which is totally oriented towards the field visits, so it's very difficult. For the last 2 years, the field works and everything is completely hampered. Yes.
Sure.
Sir, I'm asking for the last time. If there is any question, you may go ahead. Otherwise,
yeah, sir, I'd like to ask a question.
Yeah, you may please. You can please open your camera if you if you can.
Yeah, am I visible?
Yeah.
Yeah, hi, good afternoon, sir. This is Sakshi Mankotia. I'm a PhD student and my research area is glaciers. And I'm working in Kargil region, particularly Suru Valley glaciers. So my question is, sir, I come from a geography background, but this year I visited my field survey and I went to the field and I got to know that there are various other factors I can include in my research, like the geomorphology aspect of it. But as I have no background of geomorphology, I want to like ask you any suggestion you can give me. Like I was calculating the mass balance, and then for that I need a 2 or 3 years data. Within that, I want to include the rock aspect of that, the lithology aspect of that. So, like, is there any kind of training I can have in between my study region or somewhere else I can pursue that, so that I can use the essential knowledge to include in my PhD?
See, for geomorphological mapping, you are most welcome to come to us for glacial geomorphological mapping.
Okay, so yeah.
Where are you located?
I am in Jamia Millia Islamia. I'm from geography
Jamia.
department.
Okay, you are close by, so you can just come to JNU anytime.
Okay, sir. Thank you so very much. Thank you for that, sir. I'll get in touch with you, email, sir, and then I'll
anytime. Most welcome.
Thank you, sir. Thank you.
And sir, another question. I think Devashree Sinha, she raised her hand. Devashree, please open the camera. And before that, sir, may I please have your permission to share your email ID with all the participants, please?
Yes, please. Yes, please. It's given in this presentation also.
Okay, sir.
You're most welcome.
The recording is there, sir. So I'll share it, and the YouTube streaming is also going on, so they can access it afterwards. All the participants can access it afterwards. So I'm just putting your email ID in the messages so that everyone can get your email ID. Devashree, please go ahead with your question. This is the last question we'll be taking, and after that we'll be going for the lunch. So Devashree, please go ahead.
And I have to go to the glacier.
Absolutely, sir.
Yeah, I will drive to the glacier after finishing this presentation.
Yes, sir. Glacier is very nearby. Yeah, you're very near to your home. I know.
2 hours from here.
Yeah. Devashree, please go ahead.
Okay, thank you. So, sir, I was just wanting to know that just like glacial studies, as Dr. Sayantan Das pointed out, are perhaps not as well developed as other aspects of geomorphology in India. I think similarly there have been fewer studies on glacial lake outburst floods. So in the era of climate change, and if it is to continue the way it is, what would be the significance of glacial lake outburst floods for particularly the Indian Himalayan glaciers, sir?
Sir, 2 of my students are working. Arindam was here. Arindam, I think Arindam is here with Professor Day and me. He's working on Sikkim to look at globes in the Eastern Himalayas. And one of the girls from JNU, she's working with me on Western Himalayas. So we are covering this aspect also. Since we thought that glaciers are important, that's why I have trained many students now. Every year we make sure that we have master students going to the glacier. And master students, that is where we train them on the glacier. That is where we try to motivate them towards glacial studies. It has become easier. Earlier it was difficult to go to, but today you can drive and then within 2 hours you are on the glacier. As I said, I'll be off to the glacier, after this talk. I think we can contribute a great deal. Professor Chimya talked about, the hydrology of the mountains, why it is required. We need to look at it because these are the sources of fresh water. Once you lose it, your groundwater will go, your community will go, your civilization will go. So this is necessary for us to study.
Okay, sir. Thank you so much, sir.
Okay, sir. Thank you so much. Thank you. Thank you so much for being here.
I'm so sorry for initial discussion.
Absolutely okay. These things happen very often. So no issue, sir. Okay, sir.
Thank you very much. Have a good day today and tomorrow also.
And
Because I won't be there.
it's my request to you, sir, to please attend our other programs, sir, if it is possible for you. Okay, sir.
Not this one, not today and tomorrow, because I will be off.
Okay, okay, sir.
On the road.
Okay.
That is unfortunate. But those who want to contact me, you have my email, you can contact me. I'm available.
Okay, sir. So thank you once again.
Thank you, Professor Dave. Thank you, sir. Thank you. Bye-bye.
Thank you. Bye-bye. Okay, the participants, I'm now closing this session, and you may go ahead for your lunch and for your breakfast if you are in other time zones, if it is the morning time. So we will be back here in 25 minutes at 2:15, 23 minutes to be precise. And the next two sessions will be interactive ones. And as I have already sent you the files regarding that, no problem if you don't have it right now. You may have your laptop with you for those two lectures. You may have the laptop ready, laptop or desktop, whatever you have ready with you. And you may join once again on 2:15 India time. That is exactly 23 minutes from now. Okay, so you may go ahead with your lunch. Thank you. Thank you so much. We'll be joining here in 22 minutes. Thank you.
Fantastic. Everything is going on time almost.
Yes, almost. Yes,
Yeah.
let's see.
ঠিক আছে, আমি এবার আউট হয়ে যাব, বুঝলি তো?
আপনি পরে দুটো থাকবেন না?
আমার ক্লাস আছে আর কি, আমি শেষ বেলা জয়েন করব।
ঠিক আছে স্যার, কোনো ব্যাপার না। ওকে, আমি যাই, আমার স্নান টানও হয়নি ইনফ্যাক্ট। ঠিক আছে, ওকে।
দেখি আগে খেয়ে নেবো। হ্যাঁ, কিন্তু সারাক্ষণ আছে। আমি ওনাদের সবাইকে ফোন করে নেবো। আছে তো ওরা ভিডিও অডিও সব মান রাখবে কলেজে সবথেকে কাছে বলতো আমি তো পুরোনো আছি না তারা বেশিরভাগই এখানে এসে প্ল্যান নিয়েছে এখানে তো সময় ও বাবা নোমেন অনেক জন আগে একটা লোক নাগের পারে সে মন্দির তলায় পাঠিয়ে দিচ্ছে সোজা ও আমার নিজের গোটা এক মাস সেপ্টেম্বর আমি তো মুভ করতে পারিনি না তুই যতক্ষণ না অব্দি ওদেরকে কোনো ডিরেকশন দিচ্ছিস প্ল্যান করে দিতে হবে ততক্ষণ অব্দি কিছু করবে সব কোথায় ওরা কিন্তু ভালোই তোমার তখন পটি করতে সোজা বলছে শোনো সার্টিফিকেট তো মালদাতে এক মাসের মধ্যে মানে 2013 জয়েন করলো আমাকে স্মৃতিরা ফোন করেছে এক মাসের মধ্যে কি মাল পাঠিয়েছিস বলতো কি মাল পাঠিয়েছিস একখানা ও তো কয়েকদিন টুটুদার ছিল পাঠিয়েছিলাম তখন এক মাসের মধ্যে সুইগি মোটামুটি সবাই পেরে ফেলেছে আমি ট্রাই করে ফেলেছি সুইগি তারপরে সুখী তারপর লোপামুদ্রা দি তখন সবে গেছে বা দিন 15 জন্য কি ওদের পরীক্ষা নেওয়াটা থাকে গেছে। সুখী ওকে চলো তোমাকে মালদার বিরিয়ানি বড় কোনো জায়গায় ঢুকেছে। তার আগে আমি বুঝতে পারছি না শালা তুই যাচ্ছিস তোর ব্যাপার, তুই কোথায় নিয়ে ঢুকবি না, যে জায়গা সব থেকে ভালো পাওয়া যায় না ওখানটাই নিয়ে যাবো ভেবেছিলাম, কিন্তু জায়গাটা না পরিষ্কার হয়ে গেছে খেতে। তারপর নিজেই বিরিয়ানি নিয়ে ভালো হয়নি গো। মালদাতে তারপরে কোন দোকানে বেড়েছে বলছিল না, কোন মুদির দোকানে গেছে তো দুজনকে বলছে আপনার ছেলে এসেছিল না কি একটা তো পড়েছিল ওরা টুটুদা বলে সুখী বাজারে গেছে, সুখীকে বাজারের মধ্যে তো চেয়ার সুখী বলেছে আরে আজ ফিরে যাবো উঠতে বসতে সুখী মালদার নামে গালাগাল দেয়। হ্যাঁ হ্যাঁ
বাজারে আছি। সুখেন্দু কোথায়?
Dr. Basu. Dr. Basu, we are just yes.
Yes, good afternoon.
Yes, actually, we are just waiting for a few more participants to join.
Sure.
Because actually, our last session it was supposed to be end at 1:30. So
Right.
it was stretched a bit. It ended at 1:50. So we only got 25 minutes.
Absolutely.
Two more minutes. Okay.
Sure.
Akash Mondol, unmute yourself. Sorry, please mute yourself. Akash Mondol, you are requested to mute yourself. Akash Mondol, you are requested to mute yourself.
কটাতে গেছিল টাইম?
2:15. So we are starting once again the technical session. This is going to be the second technical session of today. And now we have the presentation. Now we have the presentation on the use of UAV in surface model generation. And the resource person is Dr. Balen Boshu from Opsys Systems Private Limited, India. So on behalf of the forum, I would like to welcome Professor Dr. Basu here on this platform. And let me introduce the speaker to the participants. Now, Dr. Balen Basu is the founder and managing director of the Opsys Systems Private Limited, India. And he has experiences in the field of GIS and remote sensing since 1996. And he has been associated with Computech International, Rolta India, and PCI Geomatics Canada. So he had his postgraduate degree in applied geophysics with remote sensing as special paper from Indian School of Mines, Dhanbad. And he completed his PhD from Jadavpur University from the Department of Geological Sciences. He's a fellow of Council of Scientific and Industrial Research, CSIR. Many of the Indians know about it. And he's also a life member of the Indian Society of Remote Sensing and Indian Society of Geomatics. And he has national and international experiences as far as the usage of technology in geosciences is concerned. And he was trained in PCI Canada and has traveled worldwide in connection with his expertise. So, sir, welcome you once again. Before starting the deliberation, I think there are 76 participants who are present here, 78 right now, including ourselves.
Right.
So last session it was more than 100. But if you allow, then we will take 2-3 more minutes, because if they join from the middle, it may be a bit difficult for them.
Right. There's no issues. There's no issues.
2 more minutes, sir.
Sure, please.
Okay.
Sure.
Okay. Yes, the number is increasing, as you can see.
Right.
Increasing. We'll wait for 2 more minutes and then we'll start.
Absolutely. No issues.
So I've already distributed the materials, and I have told you over the phone that there was some issue with this zipped file. Okay. Actually, not from your end, maybe the internet connection from their end, because I didn't find any difficulty in downloading it.
Right.
So I myself have downloaded it. Then again, I zipped it once again. I unzipped it and zipped it once again and sent it to them. I don't know if it is working in spite of that. But still,
you can always resend.
Yes.
If it is required.
And I have already asked the participants to keep their laptop with them, so that they could, could work in tandem with you.
Yes.
They could work in.
In fact, I shared the working steps, also the video of the working steps.
Yes, sir, I have seen that.
Yeah, I can share some more videos also if it is required. And today we will discuss a lot of things.
We have categorically told everyone to see the notepad document. Some instructions are there.
Right.
Yes.
So we will cover a bit of theory at the background, what happens and things like that.
Dr. Reshmi, please mute yourself.
Sir, actually, I faced a difficulty in unzipping the folder, so I just want to tell you this. That's why.
What is your email ID?
Sir, reshmiarun.mr@gmail.com.
Just a moment. Let me send another set of file. Just a moment.
It was a Google Drive link. Basically,
Google Drive link
should not be a big problem.
Sir, actually, I think we didn't receive the Google Drive link. We got a .rar file.
Because there was some issue with the permission.
Okay.
So that is why I unzipped it and resend it again.
Okay.
Actually, most of the people have already downloaded it and they have it in their computer. So
Okay.
these things happen all the time.
Yeah, it happens.
Not a very big issue.
Take your time. There should not be the big issue. We will.
I'm just forwarding one message. Rashmi, please tell me your email ID once again, please.
Rashmi Arun, RESMIARUN. Rashmi Arun.mr@gmail.com.
Okay.
Yes, sir.
Okay, I have sent one email. You please check that. And if you have a quick internet connection or broadband connection, it should be downloaded within 10 minutes.
Right.
Yeah, you have sent one message also.
Yes, sir. Initially, I felt I have difficulty in joining, so I sent a mail.
Okay, I didn't receive the link yet. Now you can you have joined.
Yes, sir. Yes, sir.
Yes. So, sir, 89. The number is 89. So you may start, sir. 2:30. Kapil is saying my organizing secretary Kapil. Let's start at 2:30. That.
Absolutely. No issue.
Okay, sir. I think let me introduce to my co-convener Shubhendu. Shubhendu.
Good afternoon. Yes.
Could you please open your camera? I don't know if he's there or not. Maybe he's not there.
I am here.
Yeah. Good afternoon.
I am Shubhendu Roy. And
And sir, Kapil, I don't know if you know Kapil. Kapil is here. Kapil.
Yeah, Dr. Ghosh. Good afternoon.
Kapil Ghosh.
Yes.
Kapil Ghosh is here, our organizing secretary.
Right. So it's great to get introduced.
Yeah. So it's 227 and the number is 94. We are approaching century.
Right.
Yes.
Yes.
228, 98. শেয়ার স্ক্রিন করলে তো আরেকটু বেড়ে যাবে আরেকটা বাড়বে শেয়ার স্ক্রিন করলে Sir, you can share your screen now. Just one more minute, sir. You can share your screen. So we have reached the landmark, 100 and then 99. Sir, you start. We don't wait anymore.
As you say.
You start, sir. It's 229. You can start. No issue.
Okay. So good afternoon once again, everybody. All the dignitaries from the Indian Institute of Geomorphologists, Young Geomorphologists Forum. I convey my sincere thankfulness and gratefulness to Dr. Shantan Das, the convener of this program. My sincere regards to Professor Sunil Kumar De, to Professor Siddiqui, to Professor D.D. Chaunial, Shubhendu Roy, the President, the Secretary General, and Professor Sunil Rai is also known to me. We happen to know each other
So that was a good times we had together in Tripura sometimes. And I also sincerely thank all the participants who are attending this training program. And this organizing committee has taken up this initiative, for which I also congratulate them. And I am really thankful to address this August gathering. As we will be taking you through a series of a series of sharing of our experiences in this field, we will cover some of the basic components of the drone, how drone is useful for this field, what are the types of drones, which drones are useful for what purpose. Then we will share some examples. We will share how we do the working steps. It's pretty simple. We will also share with you the video of the working steps. One I had already sent. I can send another one also, which is specifically to more on the UAV that we are using. So with this brief introduction and thanking all the participants and the representatives of the organizing committee, thanking each one of you, I would share my screen and I would start my presentation. My presentation would roughly take approximately 2 hours. And in between, you are almost at any point of time, you can put your questions. So we would address, try to address the questions which falls under our domain. And if we have anything to be resent, you can share your emails. I can send it at a later stage also. But please feel free to put your questions at any point of time. That would make the session interactive and everybody would get to know each other's question. That's great. So we are set to start and I am sharing the presentation screen. Dr. Das, is it visible? Is the screen visible?
Yes, sir.
Okay. And my audio is proper or should I be a bit louder? It's okay?
It's okay, sir.
Great. So our topic would be to use of UAV for surface model generation. And I am representing Opsys Systems Private Limited, which is based in India. In this context, I must also separately and sincerely thank the participants from the foreign nationals, which I could find in this respectable number of participants. Please accept our regards from India. Thank you very much for joining. So this is the topic that we are going to discuss. The agenda roughly would cover the relationship of drones vis-a-vis the GIS that we are used to in the domain of geomorphology and water resource management, the components that comes with UAS. So you see, sometimes I have written UAV, sometimes I have written UAS, sometimes drone. So we will have a clear understanding of this terminology too. So then we will see the workflow of how it goes, the basics of photogrammetry using the post-processing software. The software is pretty much easy. What I shared with you is a photo mode software developed by Makers. It's from Russia. It is meant to be for production environment. So it is simple in nature and architecture. So
Sir,
we will...
sir, just sorry to interrupt. Very sorry to interrupt you. Sir, could you please hide this bar on the yes bottom? Yes.
Yeah.
Thank you. Thank you.
Sure. So that was the post-processing part we would cover, and then the demonstration, which will take you through the flow of the software, which you can do it at your time also, because it is a free evaluation version, a freeware from Reuters, which is not timed out after 30 days or something like that, so you have time. You can always practice on it, and then we will check upon some of the applications which we get from this digital surface model or elevation model from this photogrammetric output, how we use it for our practical applications related to the field of geomorphology, geology, maybe water resource irrigations and other application areas. So this is broadly that we are going to touch upon in the next couple of hours. And as I shared with you, please feel free to put questions. My organization has been dealing with the GIS and image processing, the photogrammetry, the radar, and additionally the drone. The purpose of sharing with you is what we do is, since these young geologists and geomorphologists would be also getting into the academics, somebody may be moving into the industry, so it would help them to understand the domain that what are available as of date for getting into it. So we have two academies and the productions which helps the industries and has been operating since 2004. And basically our prime product is TNT MIPS, which is the GIS and the image processing part. And Records is the photogrammetric part, which has been developing solutions since 1993. I would, at certain point of time, also discuss with you the redimation of digital surface model, which is now available since 2017. The digital surface model is readily available in India. NRSC provides at 10-meter resolution, and Intermap provides at 1-meter interval. So these are the developments happening worldwide to give the end users solutions related to that. And our right now I'm representing the academy, which is in collaborations with Maulana Abul Kalam Azad University of Technology. We work and provide some of the courses affiliated to Maulana Abul Kalam Azad University of Technology. Now, now we move to our domain of today's discussions, which is UAV or drone. The first point is drone is an acronym and it stands for Dynamic Remotely Operated Navigational Equipment. So anything and everything which falls under this wide domain of dynamic remote operations, including robots, are falling under the category of drone. Now, drone was a terminology initiated in the defense systems so that people could not fully apprehend what it does. So that's how the term came operational. The other terminology which goes very well is unmanned aerial vehicle, UAV, and it is it's a more understandable form of the term. And then we have something called unmanned aircraft system. So it is a bigger picture again. So UAS will include a lot many things. Drone, as we speak, might appear to many of us being a recent technologies, maybe just 5, 7 years or 10 years. It's really not like that. The early days of UAV dates back to the World War II. And imagine those times when we didn't have instruments and technologies like GNSS, more commonly which we call as GPS. So we had LoRa and the long-range communication systems. The LoRa systems was used by the aviation industry to cover continents, which that time was a big challenge. So at that point of time, we had the UAVs. So the technology has been developing since then to what we today have in our hand as drones. There are 4 types of drone which commonly we will face, out of which the multi-rotor one is the most popular and widely used drone. It's very cheap also. So multi-rotor, these are called rotors, and these are called multi-rotors because they work simultaneously. The fixed wing, by its name itself, we can understand it relates a structure which is more or less like a plane. And then we have the helicopters, and then we have the hybrid VTOL. This is very interesting. So this is the fixed wing drones. Looks like a plane, but it's unmanned. And the most powerful one technologically is this single rotor helicopter, which is used by the defense. It is the most efficient one, and technically these are being used by defense today. The fixed wing hybrid VTOL is something different. Imagine the two technologies. VTOL stands for vertical takeoff and landing. That means it goes up from the position it is positioned. It straight goes up. It doesn't require any runway, unlike the planes, or it doesn't require any momentum to be given. It's like a helicopter technology. So this lifting is vertical takeoff and landing as well as fixed wing. That means both will work together is the hybrid technology which is being now designed. So that takes us to the next generation of UAVs. It has the ability to stand at one position, lift itself like a helicopter and move like anything. So these are the new innovations which are coming in. We will concentrate on the multi-rotor type of applications. So these are more of the theoretical part of where the drones can be applied as of today. The domain is wide. If we are looking for opportunities in terms of career, that gives us a hint about which industries are now using or embracing this technology. So we have to keep an eye on these industries if we are going to have a career or the technology based on this type of drones and the UAVs. So it's quite wide. And more or less, the principle remains the same. The application slightly varies from one to each other. What the agricultural people will be doing, the geomorphologists will not be doing the same thing. So the input remains the same. The application keeps on changing. Mining and construction industries are one of the greatest users of UAV as of now. And survey and mapping is the conventional users. So survey, mapping, conventional users, land management, infrastructure inspections, the bridge monitoring group, the various feasibility studies, the recognition studies, which goes for the transportations and for volume calculations of the mining. And this is one which is now coming up is for the emergency delivery. So beyond vision, all the drones which are supposed to be flown in India should be visible to the pilot who is operating that drone. That's the condition. There is a policy which is coming up. You can also fly drones when it goes beyond the vision. So if this policy is implemented, then we will have drones which will be helping us for emergency disaster purposes, for delivery of medicines, for delivery of food packets and things like that. Now we quickly recapitulate when we are speaking about DSM, DEM, DTM. We might be slightly confused. Some of us might be slightly confused about the three terminology. So when we speak digital elevation model, it is a type of a raster, that means which is made up of pixels, and the pixel values represents the bare earth heights from the mean sea level. So it is the elevation with respect to the MSL which is available in the digital elevation models. And some people also call it as a digital terrain model. So digital terrain model and digital elevation model are synonymous, and it is the two terminologies in two different continents. Europe, more or less, Europe, India uses the terminology DEM. USA more or less uses the terminology DTM, but both means the bare earth one. Whereas the digital surface model would specifically represent all the surface features which are available on the earth surface. That means the trees, the buildings, the bridges, whatever is available would be represented within that raster data format, and that would be called as digital surface model. So the red line which we see are picking up all the things apart from the bare earth. So there is a change of the surface properties. These are known as digital surface model. And then if we technically cut off the trees, remove the buildings, remove the bridges, how would the bare earth look like? That would be known as a digital elevation model. Now, why is digital elevation model actually required? For the purpose of morphological studies and natural resource studies, we cannot use digital surface model because the cultural features and the movement of the movement of water, the natural movement of the system administratively, the watershed, cannot be deciphered if we have this information interspeeding this bare earth. So somehow some technology has to be used to convert from the digital surface model to the digital elevation model by using some software technology at the background. There are techniques, there are ways of doing it. We will share with you. So basically, this is the difference between the digital surface model and the digital elevation model. And both are in the raster formats. Many of you must have already seen these two as a structure of the same place. This is the digital surface model. It shows the buildings. When the buildings have been removed, this becomes the digital elevation model. And I was speaking about the availability of international data sets, which gives us from the various sources of data internationally used by satellite images, the digital surface model at 1 meter resolution. Because of the defense requirement, because of the aviation requirement, this has come just a couple of years back. So there is no restriction of this data in terms of resolution because you cannot see anything. Unlike images where we can see areas of sensitive locations, there you cannot see anything. So there is no restrictions of the data sets of being used in India at high resolution. When I say high resolution, it means 1 meter as of date. 1 meter is the highest resolution available for the digital surface model or digital elevation model generated from the satellite images. So please mark, this is for satellite images. So when I say the resolution, I am specifically referring to the dimension of the picture element within that raster. So when I say resolution of Landsat is 30 meters, then a 23.5 meter of the least data or 5.8 meters, basically we are referring to the pixel size, and the average of this area 1 meter by 1 meter, the average elevation is 319. So this is how it has been rearranged for the whole of the world, and it is available. So this is what we call as digital surface model and the digital elevation model. We are just trying to understand some of the terminology, because directly when we move to the software, there will be certain complex terms which might not be easier to handle. So that's why I am just explaining these things to make the concept clear. Now, this is the road on which this red dot is placed. So there is, assuming it is the bare earth, both the terrain model, that is elevation model, and the surface model shows the same value. The moment the red dot is taken and put it on the surface model, the digital surface model says 647, and the terrain model or the digital elevation model, which we commonly say, is 641. So had this building been not there, the bare earth at that position would have been 641, which essentially means the building height is 647 minus 641. This is how the DSM and the digital elevation model accuracy has been checked with respect to benchmark points and other checkpoints of the images which we have. So this is a quick way of checking crudely how these balances of the values gives us or representations of the area, how correctly we have done our process. This is what we have to do in photogrammetry, in surveys, and all the stuff related with that. This brings us to another terminology of which you might be also aware, which is called orthophoto. By the term ortho, we mean viewing at 90 degrees. Ortho is anything that is viewed at 90 degrees. If we lie on the floor and look at the ceiling, we are viewing it at 90 degrees, so it's an orthophoto. If I stand and look at the wall, I am viewing it at 90 degrees, so it's an ortho. So ortho means looking anything at a perspective of 90 degrees. So when it is, when the image is taken, there might be a tilt or there might be an error. By some means within the software, if we can rectify it to bring it at 90 degree to my viewing, then one of the criteria of orthophoto is solved. That means even if I have tilted my angle, tilted my camera to take the image, assume that the camera is rotated and physically changed in such a way to exactly change the picture while looking at it at 90 degrees. That is one condition. And there is a second condition to it, which is called the scale. Now, when we see this photograph, we can quickly understand that in this same frame, Lord Buddha and the aeroplane, they are in, the statue and the plane are in different scales. But the photograph is a single frame. No mapping or no calculations can be done in this type of situations. If I give you the scale of the map, you cannot find out the length of the plane because they are differentially scaled. This is the problem with aerial photograph and drone photograph. The same image will have two different scales. By software and by mathematical techniques, we have to scale up one, we have to scale down the other and make everything in a uniform scale. That is the second criteria for the orthophoto. So the first criteria is it has to be 90 degree. The second criteria is it has to be uniformly scaled in the same frame of reference. If we can do these two operations on any photograph that is collected aerially, we are said to generate an orthophoto. So that's by definition means it looks like a map. So This I can easily call an orthophoto of the camels. This is called perception. The shadows of the camel appears like objects, but the object is actually the camels over here which you see, and the photograph is taken directly on top, and the camels are looking like this. However, due to the presence of light, there is an illusion of the shadows that deceives us into believing the shadows to be the objects. So we must be careful when we are interpreting photographs and satellite images to bring out information out of them. So by definitions, we have now understood what we want to achieve out of an orthophoto. The two things: it must look from top, no angular vision. Second, it must be of the uniform scale. So any measurements which we do over here has to conform to a uniform scale. Now, during our courses and other programs, we all know about the stereo visions and the perspective visions. One is the normal vision. That's how normally we see. This is the normal vision. The two eyes viewing a three-dimensional object. The two eyes basically sees two-dimensional images. The left eye creates a square two-dimensional image. The right eye creates a two-dimensional image, and then it goes to the brain, and the brain interpolates it to say this is at a higher height and this is at a lower height. It's a complex operation that happens inside the brain for the images that we see, and we perceive something as we see it in nature as a 3D. Now, when we see it in a computer screen, there are two things which we have to give to a computer screen. The technology demands we need to give two objects taken from two different angles. And then if I interpolate it backwards, there is a perception created by laws of physics which appears to have an object of 3 dimension on the computer screen. So basically, when I am putting an object on your computer screen and you are being able to see it as a 3D, what happens at the background is this type of visualization. It takes you back to a technique that creates a stereo effect, and it looks like a 3D to you, 3D to us. So one is the visualization part of it. That means it should look like 3D. And the other is the mathematical part of it. It should not only look like 3D, but also give me physical measurements that it is this much meter above the sea level. From the ground, it is this much high and stuff like that. So one is looking like 3D, other is measured in 3D. So this is called stereogrammetry or photogrammetry technology. And then we have the perspective view. The perspective view is nothing but the trick that our eyes are tricked into seeing something different from different angles. When you see objects from different angles, the true picture is never perceived by the brain. The picture perceived by the brain varies from angle to angle. So that I will share with you. Just have a look at what I mean by perspective view. So that was perspective view. Initially, we thought that it is defying gravity. But the moment the angle changed, our brain began to perceive it in a natural way that there is a concave and it is actually going to that concave part, the valley part. So that was what we call a perspective view. Now, what is a stereo view? Just let us share quickly something on the stereo view. The stereo happens in our eyes if we have two images kept side by side, or there is a red cyan effect kept by an offset. So then also we will see it as a 3-dimension. Let's try the samples in the site which are given. This is called the stereoscopic viewer. Let's take this sample. It is placed side by side. Now we perceive this as a 3-dimensional object. Perceive this as a 3-dimensional object. Similarly, if I just go to another one, and then the other way, but the red cyan way. Just we will see if there is a red cyan. So there are two different filters in the images which gives us a 3D effect. The same image, if one is filtered red and the other is filtered through cyan. So both these two images, when we work together, our brain is perceiving it as 3D. See this water body, see the trees are getting upright, the human beings are seen as 3 different objects. So this technology has been brought into our natural resource studies and then measure it in 3D. So this is what we call as the perception and the stereoscopic view. So that was the two types of views that we generally have. One is called the stereoscopic view and the other is called the perspective view. We move. Right. These are again two terms which you might be hearing. One is called ortho and the other is called true ortho. So orthographic or orthophoto and true orthophoto, what does it really means or how is it different? First have a look at this image. This is shadows are distracting. So look at the base of this image and it is the top of the image. This is the base of the image. This is the top of the image. This building top, this is the building footprints, base of the building. Now, when the photograph is rectified with coordinate systems and the heights are everything done, that means the base of the building are corrected, but the top of the building is not corrected. This type of problem was not there when we didn't have very, very high resolution cameras. So these problems cropped up later when we had high resolution cameras. The base of the building is rectified with the earth coordinate system, but the top of the building got still tilted. Then this type of rectification is known as just ortho, simple ortho. And when we try to mathematically shift the top of the building also, so that it looks like the image which we see in Google Images or in the standard images, these are known as true ortho photos. So one is called a simple ortho and the other is called a true ortho. The true ortho is a much more technically sound way of representing, because the top of the building and the base of the building both are rectified, whereas in a simple orthophoto, it is only the base which is rectified and not the top. So for all practical mapping purposes, we should have a true ortho. Whereas this type of tilting errors is noticeable in general orthophoto generations in simple software. So this is the difference between an orthophoto and a true orthophoto. One of the most common questions which we face is what we do in a drone survey, what actually we achieve in a drone survey. I have been speaking about these two terms quite a lot. One is the surface model and the other is the orthomosaic or the orthophoto. Drone exactly does this thing. It creates a digital surface model and it creates an ortho photograph or the orthomosaic of the photographs. So basically these are the two basic outputs that we get from a drone survey. One is the digital surface model and the other is the orthomosaic of the whole area. When we speak of drones, our mind goes to the playgrounds or in the functions of things like that, which keeps up only the video cameras and the videos that has been operating or the photographs that has been taken. So that genre of drone is completely different from this genre of drone, which is meant for the survey purpose. So there, whatever we see in general for disaster management, for police management and defense, it is the videography which takes the videograph and we see the track of the video along which it is going. Those cannot be directly used for our natural resource studies or morphological studies because they won't be able to generate the digital surface model. And of course, the orthomosaic. This is our digital surface model, which is first generated, and then using this digital surface model, we will create orthophoto mosaic. There will be hundreds of photographs taken by the drone, and those hundreds of photographs will be clubbed together as mosaic so that they have a uniform scale to be used in GIS. We will see this in the GIS environment. So the whole idea was to show you these two outputs. And then as we zoom out, we will see in that the scale at which we can go is up to 1:200 or 1:150. So the general scale at which we have been working goes back to maximum 1:4000 scale with the cadastral sheets. 1:4000, and imagine this is 1:400. So 1:400 or 1:200. So this is the benefit of drone. We can go up to a scale of 200 to individually map the trees, to individually map the boundary walls, the cars, the people standing. That's the scale at which we can go. Now, when I said it is different slightly from the videographic drones which we see, we now come to the term called UAS, the Unmanned Aerial System. The whole thing is known as a system, which includes three major components. One is the bird that flies, or UAV, or drone. So this is one component. The other important component is called the ground control station. So whenever we are using these drones, there is a counterpart of ATC which we have. It is called the ground control station. It's a small modem-like thing which is available, and there is something called flight management software. So these three components, why we are saying this, because the drones that are now being built in India are to be used by the civilians. People like you, people like surveyor, engineers. So we are going to use it for our applications. We need to really know how it operates, the basic information related to it, and it's now available. It's now available for civilian use without any permission or piloting licenses. So one component is the bird, which physically flies in the air. The other component is the ground control station, which is there beside you standing in the field. It is a small modem-like instrument. And the other is called the flight management software, which is a tablet-like thing. You keep it in the hand and it will help you in the flight management operations. So these three things together is known as UAS. And add to UAS is the post-processing softwares which are available, like photo mode, which we are using. There are a couple of other softwares also, which does the post-processing for us. And that two together is called as the photogrammetric output. So one is this one, which is the physical drone. And the other very, very important part is the post-processing software, which is our major discussion today, where we generate things like DSM, like orthophotos from the photograph taken by the UAS. So these two together comprises of a system, which is the photogrammetric output. And obviously, this is an orthophoto. That means forget how the drone has taken the image. The images are now rectified and you are now as if looking from the top. So the original images, if you see that there will be a lot of shift, there will be a tilt, there will be a skew. All these will be taken care by the software, and they will just pull each other, push each other, and do lot of distortions, rubber shooting, to make it look like as if the drone has been flying really on the top every time. Otherwise, the alignment studies, the profile studies, the contouring, they won't be allowed. And then we can go contours up to say 10 centimeter interval contours. The highest resolution image which we have and the resolution which we get in this drone, we will check on that. So we always compare with satellite images. So this was a railway project where the profile was done. We will now, some common terms which are being used is payload. What is payload? What is endurance? What is gimbal, relative accuracy, yaw, pitch, rolls, and all these questions which comes to our mind. Now the one which you see on the right, it is called a gyroscope. We have all learned about this simple device of gyroscope in physics. Basically, you see the yellow part, the plate and the rod, they are steady. All others are rotating and moving in different directions. This whole system is known as gyroscope, and the purpose of this instrument is the all movements which the ash color object does to keep the yellow color object steady, perpendicular, vertically steady. So all others which are moving in multidimensional angles and speed, they do it to keep the yellow object still and steady. That's the beauty of gyroscope. So the camera which is being carried by the drone, no matter how the drone fluctuates, moves, tilts, hovers, goes around, the camera will always try to look to the ground at a perpendicular degree, at a 90 degree. That is done by an instrument which is called the gimbal. And the background principle is the gyroscope. Background principle is the gyroscope. In India, specifically in India, there are certain terminologies which are to be kept in mind, specifically when we are working with drones. And those specific terminology relates these few words. DGCA is the certifying agency, Directorate General of Civil Aviation. If at any point of time any authority asks us what is AUW, it means all up weight. The drone that we are flying are permitted with certain weightage. Everything it carries, the cameras, the batteries, everything, total when it goes up is known as the all-up weight. There is another term called no permission, no takeoff, NPNT. So this is a condition put by DGCA for flying drones. Whatever drones we fly must be compliant with NPNT. There is a software which is built inside the drone. Whenever it begins to fly, the central agencies will have, they will know where it is. For example, theoretically, when the mobile is on, somebody somewhere can know where I am. So that's like NPNT. And that is being monitored by a provider called Digital Sky Service Provider. Any instruments in India has to be approved, so is the drone, and it is called ETA, Equipment Type Approval. And since it requires communications, there is another department which is the WPC, the Wireless Planning Coordination Wing, which is from the Department of Telecommunications. The whole idea is to share with you that whatever drones that you fly, we fly, or the Indians fly, these are the peoples, these are the organizations from where it has to be certified and approved before we actually fly. And it is available. It's not the user's headache, it is the manufacturer's headache to get all these permissions before it is given to the end user. Things are becoming very easy. This is our domain. RGB is the sensors, and it is specifically refers to optical sensors. If I have to use the infrared sensors, we can use it. Now comes the interesting term called RPAS. UAV, UAS, drone, these are all terms taken from outside India. So India decided to call the drones as RPAS. So any communications from the government as RPAS, remotely piloted aircraft system, refers to drones. And we are supposed to have each drone a unique identification number, just like the number in our mobiles. And if the drone is beyond 2 kg weight, then we are supposed to have unmanned aircraft operator permit, UAOP. That means whoever wishes to fly a heavy drone, then he or she should have a UAP permit from the certified agencies of the government. There are 20 to 25 institutes in India which gives this operational licenses, permit training. The nearest one is in Jamshedpur. Yeah, is in Jamshedpur. And then we have the S mode and the P mode. The S mode stands for sports mode and the P mode stands for position mode. What is the difference between these two? Basically, sports mode means when we are covering the sports event, the quickness of the event is the essence of the thing. So the drone must be very agile, must move in any direction very quickly. So that's called the S mode. Whereas when we are doing surveys and stuff like that, we are into position mode. That means our position is the priority. So it must be slow, it must be accurate, it must have a control so that the coordinate system is properly inherited within the system when it takes the photograph. So you might get a very cheap drone. Remember, that is an S mode drone because the various fail-safe operations and things like that will not be incorporated over there. So that's called the position mode and the S mode drone. Service ceiling is the ceiling at which we are regulated to fly. That means we cannot fly beyond, as of now, 200 feet, which is roughly 60 to 70 meters, which is 60 to 70 meters from the position that we are flying. GSD is our terminology, which is more common to the terminology of the drones. So all the cameras, when we are using, we speak in terms of micropixels. We speak megapixels. It's a 20 megapixel camera. It's a 40 megapixel camera. So how do we really understand in our own way that what would be the ground sample distance that we collect with a 20 megapixel camera? So when a 20 megapixel camera flies at a height of 60 to 70 meters, the resolution of the photograph will be around 5 centimeter. 5 centimeter. So the highest resolution of the satellite image is 50 centimeter. And we are speaking of 5 centimeter. That means straight 10 times better than the satellite images which we have currently. So the drones are capable of giving us information 10 times better than the highest resolution satellite image which is available to us. And that's what we call as GSD. So when we fly at a height of 60 to 70 meters with a 20 megapixel camera, the resolution achieved is 5 centimeters. 5 centimeters. This also takes us to these another terms which again you might be aware of. That is called the RTK and the PPK, the real-time kinetics and the post-processing kinetics. Most of us have heard about it. Somebody of us have already used it as instruments. We will now try to see what is the difference between conventional GPS, BGPS, RTK and PPK. It's all the change of technologies that has happened over the period of last 30 years, which is taking us from the domain of simple GPS to DGPS and then to real-time kinetics and then to So these are when the GPS, when I say GPS, there are 24 satellites which is being received by the receiver which we held in our hand. And that operates roughly at a height which is giving us an accuracy of 3 meters, 3 to 5 meters accuracy. That is when the GPS started or still is. Even today's GPS, if you see, it gives you a high accuracy, but the circular error that can achieve is 3 meters. Now, when these two frequencies were both introduced, the theoretical precision between the two became in terms of centimeter. It became in terms of centimeter. These are self-explanatory. So the second one was the differential GPS. What it did was there was a base and somebody was moving to take the instruments. So the base was fixed. So the base was receiving the data. It was rectifying because the base was placed on a known benchmark point, and the rover was moving. So it was assumed in that same area, whatever error the base is getting, the rover is also getting that error, and they were trying to rectify each other. So primarily when we achieved this type of accuracy, when it came to real time, that means while the drone is moving and the base is kept near you, in real time we were trying to rectify the error of the control points or in the error of the coordinates which the photographs was collected in the photograph of the drone. That was the whole reason RTK came into being. But there was a problem with RTK. RTK has its own problem. So this is the corrections which is applying in real time. This is the base, this is the drone. And both are talking to satellites. Now in PPK, what happens is the base is taking the data from the satellite, the rover, that is the drone GPS, it is also taking data from the satellites. They come back. After coming back, we put it into a software and then we rectify the errors. That's why it is called post-processing kinetics. Whereas this is a real time. So whatever happens is in real time. The problem with real time is that by chance there is a change of number of the satellites that the rover and the base sees. There will be an error. For example, if this base sees 10 satellites and the rover sees 5 satellites, there will be a huge error which will crop in and the user will not be able to know. So in a drone, we never suggest RTK, we always suggest to go for PPK model. So there are other issues which we, for these reasons, it is always PPK model which comes into use. There will be again questions on accuracy, what type of accuracy we are expecting. So accuracy are of two types. One is the local accuracy, other is the global accuracy. When we say global accuracy, we are trying to say the absolute accuracy. For example, a benchmark point, a pillar of benchmark, we know the latitude and longitude. At the same position, how am I getting the latitude and longitude? So this is called global accuracy or absolute accuracy. And the other is called the relative accuracy. That means the distance between the two must also be the same. Physically, when we measure the distance, they must be same. We have often seen that absolute accuracy of these 2 points are equal. They are very good, but the relative accuracy is differing. That means the distance between them has changed. So that is called relative accuracy. Global accuracy is achieved by the drone and local accuracy is rectified by the software. That's why both the drones and the post-processing software are important in achieving high level of relative and absolute accuracy. This is important to us. This picture, why we say this, when we fly drones, our common example of field survey says if we get 7 drones, we should means take the reading, or say 7 or 10, whatever we decide organizationally. Now, that really doesn't suffice when it comes to drone, because the formation of the satellite present also plays a bigger role while we are flying drones. I will just touch upon that example. For example, this satellite, there are 4 satellites received by the GPS. Here also 4 satellites are received by the drone GPS. We are happy, the minimum is 4, so I can fly. But see the difference, here the formation is wider and here the formation is closer. If the formation is wider, that means the area of influence which is drawn for this satellite, if this is the formation drawn, if it is wider, the two cuts each other like almost a square. And when it is very closer, when they are closer, the two circles, when they are closer, the intersection area is a diamond shape. Is diamond shape. Now the black dot is your position. That black dot, when it comes to a diamond shape, can fall anywhere within that diamond shape. This black dot can fall anywhere within the square shape. So the square shape is smaller, the diamond shape is wider or larger. So the error in the diamond shape is higher. The error in this small square shape is less. That's why this is known as horizontal dilution of precision. It is always given in the tablet which we are operating. It is given in any instruments which we are working with satellites, HDOP. We sometimes miss it, but it's a very, very important factor, trust me. That is the dilution of precision. Wait for some time to get it increased. Once the dilution of purpose, dilution of precision reduces, then start your work. So this is how we should have a check on this part. We now come to another components which we will see in the photogrammetric software, certain terminologies like IMUs, like omega, pi, kappa, pitch, roll, yaw. These bombardments happens when we open any software and books related with photogrammetry. We will now quickly and lucidly try to understand this technology and the meaning of it. We have to take help of Einstein. In all our cases, the technology of GPS is dependent on the technology of theory of relativity. So it was unless Einstein gave us this theory, today's GPS would not have been there. The light is moving at a very high speed. The earth is moving, the object is moving. So when things moves, how light behaves, it was Einstein who first showed. And then philosophically, it first came to his mind that everything is relative. That means the frame of reference is relative. The frame of reference is relative. When something is flying, like drone, like plane, it has its own frame, X, Y, Z, which is not the same as X, Y, Z of our Earth surface. It's flowing somewhere, it's going somewhere, but they have to be somehow related with my Earth coordinate system. But for the time being, we will just understand that any drone, any plane, any helicopter, they have their frame of reference which is called the inertial measurement unit, IMU. Since it is moving, it is called inertial. Since how it is moving is recorded, it is called measurement unit. That is the inertial measurement unit. Now, the front of a drone and the back of a drone is different. It is not north, south, east, or west. It heads in any direction. It can go in any direction. So those movement is recorded in a small instrument called IMU inside the drone, and they have three different names. One is called pitch, one is called roll, and the other is called yaw. When the drone is moving forward or backward, it is called pitch. It's a terminology called pitch, just like our cricket pitch. We ball from this end or we ball from the other end. So this pitch is the forward movement and the backward movement. The drone looking somewhere moves on the left or moves on the right, then this movement is recorded as roll. And then you turn your nose on the left or on the right, then that movement is recorded as yaw. So these roll, pitch, and yaw are the different movements of the drones which are recorded inside the drone's the inertial measurement unit. And when they are compared with the Earth system, they are converted by some factors which then we call as omega, phi, and kappa. So as application people, we really don't have to break our head onto this. We must remember that roll, pitch, and yaw are terms related with the movement of the drones, what they are, and when we say omega, phi, kappa, we are actually converting them into the Earth coordinate system in terms of latitude and longitude. So this is what basically the drone does. Here is the sensor, there is a camera taking the photograph, the position of the image, and this roll, pitch, and yaw at each position is being stored inside the photograph. Now, when you see drones, you will see that the drones are moving a little bit awkward way. It is tilting, it is shifting, but this type of tilts and this type of shifts are required in any motion. It's required in any motion. When a runner tries to start his position, every time you will see that they are taking an inclined position. Without that, you stand straight and try to gain speed, it will never get happen. This is something to relate with the momentum. It has something to do with the momentum. We are really not worried about this. We will just try to understand why it happens, and then we will move. If any of you have studied angular momentum, you see when the boy is closing its hand, it is becoming slower. When it is spreading its arms, it's becoming slower. So the same thing happens inside this drone also. You rotate that tube, your position will automatically begin to. These are all related with momentum, change of momentum, which happens inside the drone technology.
Drone Drones are versatile tools that can be used for a wide variety of applications. One of the newer use cases for drones is to help create 3D models, thanks to special software programs that can turn aerial images into digital spatial models. Here's what you need to know about 3D models, how you create 3D models with drones, and how these 3D models are being used across different industries. First, what is a 3D model? It's a three-dimensional representation of an object created by plotting individual points. You can create a 3D model manually by using 3D modeling software, by using an algorithm, or by scanning a physical object. And this is where drones come in. Drones are essentially airborne scanners that can be used to turn large objects, such as buildings, construction sites, or simply large land areas, into 3D photogrammetry works as it looks at photos of a subject taken from two or more locations. It uses the different perspectives of the images, along with the location data of where the images were taken, to triangulate the locations plotted in 3D space, which is exactly what you need to create a 3D model. Drone photos are great for this process because every photo is geotagged. This means the latitude, longitude, and altitude from the drone's GPS and onboard sensors are embedded in the metadata of the image. The metadata also includes information about the camera sensor and the optics of the drone.
Whenever there is a survey grade drone, each photograph will have all these informations inside the image.
These geotagged photos can be processed by software programs such as Drone Deploy, Pix4D, and others to create 60 to 70% overlap between your aerial photos. This helps the triangulation process be more accurate and track the same points between images. Flight apps such as Drone Deploy and Pix4D Capture allow you to create automated flight paths and 60-degree angle. Next, fly at a middle altitude with around a 45-degree angle and the top of the building. You can then use a software tool to process your image. A huge benefit from drone imagery, mapping, and 3D modeling software. Construction firms can monitor progress at their construction sites with regular updates, and they can easily inspect different areas on the site. The app but you can create as 3D models and drone mapping technology. They can safely inspect previously unseen angles of property. The firms benefit from these, reach more dangerous or challenging to reach locations, and help ensure the safety and longevity of the equipment. The agriculture industry is another area where drones are transforming the landscape. While farmers are not necessarily using 3D models, they can still leverage data from drones to create orthomosaic maps of their fields. Newer drones are available with multispectral cameras, allowing farmers to create normalized difference vegetation indexes for a deeper understanding of their crop health and field performance. Public safety can also utilize 3D models for documenting.
And the higher category of this natural resource drone is the LiDAR drone, which is added to the as a drone camera. Instead of an RGB camera, we are putting a LiDAR over there.
Though LiDAR is used in a number of applications, we have chosen the top 5 areas where LiDAR plays an important role. Autonomous vehicles. If you've seen a self-driving car before, you've probably seen a LiDAR sensor. LiDAR works as an eye of autonomous vehicles. Imagine if your human eyes allowed you to see in all directions all of the time. Imagine if, instead of guessing, you could always know the precise distance of objects in relation to you. LiDAR enables a self-driving car to view the surroundings with a few special superpowers. Agriculture. LiDAR can be used to create 3D elevation maps of a particular land, which can be converted to create slope and sunlight exposure area map. This information can be used to identify the areas which require more water or fertilizer. Water information of a river can help understand the depth, width, and flow of the water. It helps in monitoring the floodplains. Modeling of the pollution. LiDAR wavelengths are shorter, which operate in ultraviolet, visible region, or near infrared. This helps to image the particulate matter, which are of the same size or larger than the wavelength. So LiDAR can detect pollutant particles of carbon dioxide, sulfur dioxide, and methane, which can be used for better planning of the city. For archaeology and building construction, LiDAR plays an important part for the archaeology by vegetation, which helps archaeologists capture the building's structure. This digital information can be used for 3D mapping on the ground, which can be used to create models of structure.
So that was the application of LiDAR. I also have a LiDAR data. I will share with you that too. Now we narrow in. We have crossed an hour or so. If we have questions, any questions at this point of time, we would definitely like to take a few questions at this point. Or if you would like to carry on, we would definitely carry on. So we tried to give a glimpse about the terminologies, the legalities of how different the drones are from these conventional ones, what are the capabilities, the LiDAR, the RTKs, and the basic technology related to it. If you have any questions, we can have it at this point, or just we move ahead. Okay, so we move ahead. So this is where the basic workflow stands. We have a tablet with us, which is giving a flight management software. Now, this flight management software, what we will have to do is we will have to draw a red line in the area of interest where we are working. As soon as we draw this red line, it will ask at what height we are going to fly. So we mentioned the flight height, 60 meters or 70 meters. The white lines will be automatically generated so that the drone will flow by this path and it will capture the whole area. So this is what the flight management software does. It is developed within, and it is within the tablet which is being carried in the field. Now this information has to be given to the drone. How do we actually pass this to the drone? We first pass it to the ground control station, and that connectivity is by Bluetooth or by hotspot, so that they talk to each other since they are closely spaced. Now this ground control station will talk to the drone by the radio frequency and transmits all these informations which the user gives to the ground control system. It passes that information to the drone and the drone begins to fly. After it comes back, it collects the data and puts to the post-processing software. So there will be thousands of images which is collected by the drone, and then the rest of the job will be done by the post-processing software. We will just show you that the drones that we have. This is the VTOL, vertical takeoff and landing. It's very light because they are made of carbon fibers.
The different parts of drone are seen here. The bird, the tablet, the battery charge detector and the camera.
This is the GPS which is shown over there.
Seen on the GPS module indicates the front of the drone.
There is an arrow That arrow indicates this is a regular body, so that's the front, this is the back, and these are the rotors.
The gimbal, which essentially is a gyroscope,
This is the gimbal, which is allowing it to have images at 90 degrees.
The drone and can take still photos or video as required.
This is a Sony camera, which is capable of taking both photograph as well as videos. It is just tagged in and it is triggered. There is a trigger cable which is kept so that automatically it will take all the photograph. We don't have to do anything.
The different motion of drone is demonstrated here. The upward throttle takes it upward and it can move
When a
downward.
drone goes up, it is called throttle.
Can move forward or backward and is called pitch.
This is the pitch when the drone moves forward and backward. The sidewise is the roll.
Recorded as heading.
These are the fail-safe operations are there. That means if there is a loss of communications, it will automatically come back to the home position.
The blue connects the drone with tablet. As soon as they are bridged, the drone position is shown as orange. Oh my god.
So the arrow indicates that it is in the home position. The location is over there. The user is now drawing.
GPS log. The area of interest is marked and flight paths are automatically generated.
Now go to settings. He's mentioning the camera type.
So next 516 mm. Now go to flight altitude.
These are just changes in the angle if it's required.
Recognition.
Waypoint saved to drone.
This information is sent inside the flight management software, and whether it has received, it will indicate that this two-way communication is established.
Then it is ready to take off.
Stabilize.
Mode stabilize.
On.
Now the user don't have to do anything. It goes from the home position to the starting position, and it starts its movement and begins to collect the blue impressions which are seen are basically the photographs being captured along the path.
Going for waypoint 5.
এটা হচ্ছে 8:30 হচ্ছে 32 তাও আমি 32 আমি রেসোর্স
Going for waypoint 6. Going for waypoint 8.
And then comes back automatically to the home position. Then we move to the software component part, which is the job of collecting the data is over. Then we take it to the post-processing environment and then begin our post-processing applications for creating the digital surface model and the ortho photographs from it. So we will be using the visible RGB camera. So we can use any other cameras like infrared and other thermal cameras. This what you see is a thermal camera. The thermal images apparently looks very blurred. We are doing operations in areas which are near the river banks to see by the DMs how the river banks are being misutilized or not. So they are using thermal cameras at night. What basically does is these are not optical photographs and doesn't give us any impression unless otherwise it is converted into a thermal variogram, which is a hotspot regions. Now these are areas which are having high temperature, and these are areas which are moisture contents. These are high areas of water content, means comparatively cooler areas. This is how the thematic maps are generated out of it. So this part we are going to skip because it is related with multispectral and more on the drone technology. This is a LiDAR data which is used. The post-processing of the LiDAR classified images. So we don't have to create digital surface model. Directly we get the point cloud as DSM from here. These are actually point clouds, and each point gives us the height values. Since there are millions of points, it is in the LAS file and it has to be accordingly taken. Now we move to the post-processing part. There are three basic areas in the post-processing. One is called the triangulation, the other is computation of the DEM, and the third part is the computation of the photo, orthophoto. So it is now clear to us, basically we are achieve digital surface model and orthophoto. And prior to that, we have to do the triangulations, which is the basic part of the photogrammetry. Now, since this is for production environment, as I said, all these steps are regulated as 1, 2, 3, 4, 5, 6 like that, so that the user can go step by step and there is no chance of missing out in any one particular area. So in interior orientation is the process where the camera information is taken from the photograph, and those informations like focal length, what is the mm of the, what is the calibration of the camera type, which is the direction of the camera, all these informations are there in this from the camera informations, which is called the interior orientation. Then comes the exterior orientation. Most of the time, whenever we have data related with its movement, like kappa, omega, phi, kappa, these are accessory values which are given by the software. So we use these values to perform exterior orientation. If we have control points, we can rectify the images further. Relative orientation is basically how the images are placed with respect to each other. Who is on the left, who is on the right. And bundle adjustment is the original triangulation, which theoretically many of the books call it as exterior orientation. So some of the books call it as spatial 3D triangulations, some call it exterior orientation. So do not get confused that before relative orientation, we are actually performing exterior orientation. It's not like that. This exterior orientation is taken from the metadata, from the images, just to give it a glance from the GPS, how it is placed. But actually, This is the interior orientation, then relative orientation, then block adjustment. So these steps are followed one by one, and then after that the DEM or the digital surface model is generated. From the digital surface model, if somebody wants to say, I want to work with a DEM, then we have to filter the vegetations and we have to filter the buildings, which will give us the digital elevation model. Now it is clear that the software will generate the DSM. We have to filter the buildings, we have to filter the vegetation, and then we will get the digital elevation model. Once we get the digital elevation model, our last step would be to get into the ortho photo. We're just skipping this part. So first is import all the hundreds of photographs. Then we have to create a block, which is called the interior orientations. Everything will be automated. And then the block adjustment has to be done within the block adjustment. Once this block adjustment is done, we will have the digital surface model generated. And after this surface model is generated, we will have the ortho photo generated from here. So run if now you can just see the interface and then follow the video which is being shared with you, so that the working steps, whatever is there, you can follow it. I am giving you an overall demonstration of the working steps. It's very easy because it's not difficult. It's an automated process, as I shared. I am just opening the software interface. Any project, we will have to first create a project. So once we create a project, there is a directory. We must remember that whatever data that we are keeping, we must put it into any of the project path directories. For the first time, if somebody is doing it, remember, just you have to connect. We have to connect, which is called creating a profile, any folder where the data is kept. For example, under E, I have kept all my datas. This is another path where we have kept all the datas. So just create profile and add your path where the data is kept. This is the starting point. I have already done that. And then we go to create a project. While we create a project, we must remember there are 4 types of operations. Since we are dealing with camera, we must choose central projection systems. Once we put the central projection systems, it will ask what type of coordinate system I am going to use. WGS84, QTM. So we need to know the one for which we are creating. For example, the dataset which I have shared with you, it is a central projection image. There are 6 images. I have used here 27 images were there originally. And the coordinate system is UTM zone 37 north. We have to select that. it will ask for a relief elevation. That means broadly, the area which we are working ranges between 50 to 400 meters. This type of basic information, if it is fed, it is not mandatory. If it is fed, it becomes this for any software to interpolate faster. Suppose we are working in Darjeeling area, we know the average elevation of Darjeeling. So we keep a range of elevation values so that when software does the interpolations, it becomes easier for them to do those things. So that's the first thing that we have done to create a project. So I am opening that project. These are the steps. I have to add images from files. So just go to add images from files and automatically it will ask you the folder, give the folder name. It is as same as any software. Once those photographs are taken, if it is from a standard camera, it will ask for import from metadata. So we will just have to import the camera informations as available. All standard cameras will have these informations. Our job is just to import from metadata. We don't have to do anything over there. Once this metadata is imported, it is telling us that the camera type was this one. These are the images which has been collected over here, and these are the camera informations which is collected from the metadata. Don't do anything on this. We don't have to do anything on these. Are advanced features which are kept for advanced users who would want to play with the data structure to create more accuracy, to remove errors in the lens and stuff like that. So we are not going to do anything over here. As I told you, again, import from file. Just click on import from file and choose your folder. Everything will be done for us. After doing this, see, the data has been imported. Whatever informations that has been there in the metadata of the files has been converted into omega phi kappa. So from the roll, pitch and yaw, it has been converted into omega phi kappa. These are all internal mathematical parameters which will be used for triangulation purpose. We don't have to do anything again over here. After this is done, automatic tie point measurements. That means automatic tie point means since there are two side-by-side images, every features are there in the side images, it will try to understand of its own that this feature is the same as this feature in the next photograph. So in that way, it is going to tie the points which are common in the side-by-side images. So the tie points will be automatically generated, and these tie points will be shown over here. There are 2,768 tie points collected between the images, and it will store in the database. As we improve, as we are more conversant on the software, we can play on this. I want to remove this tie point. This is not correct. You can individually go and check it. Otherwise, leave as it is. And then will come the final block adjustment. So when we go to this block adjustment, it has created the positions based on this, how these images were collected, and then finally the block adjustments will be done. We again have no control. If you don't want to do anything on this, just take all these values which are available, allow the software to do the block adjustment. As we move or improve, as we know the software more, we can adjust the parameters of these bundle adjustments, but it is generally 90% of the time not required, and then complete. So once the bundle adjustment is done, we will have to move on to the dense DSM model. So our first part of the aerial triangulation is over. Our first part of aerial triangulation is over. This is the video which will take you through the working steps of whatever I have described, step by step on the same data set which you have. You can follow these steps in the video. We are I have shown you the same thing. The central projection images. Give any name. Choose central projection. Choose the type of coordinate system, WGS84. There is a whole list of coordinate system over here. UTM 37. So we have chosen UTM 37. The basic information of the height of that place, elevation of that place, range. Add images from the file. We are going to the folder where the images are stored. Add the images so that it is imported within the software. It is always advisable to import the software within the software environment because various image processing techniques can be easily handled. And the original data set is already there, so it is also not lost. Say, for example, here some advanced applications like radiometric corrections, if somebody wants to perform, then we are performing the radiometric corrections on the images. These are optional steps you can do or you cannot do, and you can move to the next step as I shared. All the images are now being cached. These are the camera informations which are automatically coming over here. As I said, we should not do anything over there. This is also simple import of the data from the metadata. You just follow these steps with the images which we have given step by step. You should be able to complete the exercise. I will skip the step because we are not going to use GCPs. We don't have to use GCPs. We will just, GCP is to increase the accuracy. Without even GCPs, we can directly get the data. Automatically collecting of the tie points. Tie points is collected. The block is adjusted. This is the block adjustment. At the background, many things will come. Don't worry on those things because it is all the internal structuring it is doing to change its error and stuff like that. So just ignore those things. The block is being adjusted further. 2-3 iterations are done. So that perform it 2-3 times, the result will be done. So all these images are rectified, adjusted, positioned, taken with respect to tie points, cleaned. If you want to put tie points further, so you can do it. Otherwise, we can just exclude it from this. The dense DSM. The next step was the dense DSM. The DSM is generated. If you want to save it as a TIFF file, just export it. There will be sometimes gaps because the data could not be collected. So again, do a second reiterations, it will get corrected. 2-3 times, just repeat the operations. In any photogrammetric software, it's the same. It will fill up the holes and the DSM will be generated. And then the DSM can be used for various applications, as I said, like contouring and artwork calculations. And then final step for orthomosaic. Orthomosaic was created. This is the advanced stage called cut line operations. So even if we don't do cut line operations, it is for improving the quality at the edges. But the basic operations is automated. Just go to orthomosaic, run the orthomosaic. It will take the block adjustment images and it will complete with the adjustment. So after that, compute dense model. Just go to dense model like this. It will take time depending upon the type of computers we have. With 8 GB RAM, generally it is easier to do these operations, a minimum of 8 GB RAM. Since this is only 6 or 7 images, it should not be a big issue. The grid is already generated. After the grid is generated,
এই সময় ধন্যবাদ। তুই যদি অ্যাকচুয়াল চাকরি জীবন অ্যাকচুয়াল চাকরি না, হ্যাঁ অ্যাকচুয়ালি করবো ইউনিভার্সিটি মালদায় 1.5 বছর ছিল।
So you can apply the grid size and all these things. It will automatically take. If you want to just do this, apply. And then the parameters will come. You see the DEM size, cell size automatically taken 0.5, 0.05. That means 5 centimeter. Just run. Okay. I'm not running it. It will take time. But our job of DSM will be based on that. Now I will show you the final data set that we had done. So I am opening a data set of near Calcutta. There will be an orthomosaic and there will be our DSM. I will overlay both on together on top of each other.
কটা দিয়ে দেয় 5:30 না 6টা এক্সটেন্ড তো করাই যাবে কোনো চাপ নেই।
There is an RGB camera, so 3 bands are there. This is the composite, and at the background I am opening the digital surface model of the same place which is created as a dense DSM. So I have opened the 2 layers. One is the DEM layer, this is the DSM layer, and this is the mosaic layer. This is the mosaic layer. Now if I zoom out a bit at this place, say for example I put my cursor on the road, it says Z is equal to 4.1. That means 4.1 meters above the mean sea level. I take my cursor to say on the rooftop, 14.3. On this treetop, 10.1, 4.1. And this is in 2 dimension. If you convert it into a stereo, just convert it into stereo, then if we have spectacles, anaglyph spectacles, generally the one which we see the movies, you can see the images protruding up. It's in 3D you can perceive it. So that with the spectacles on, you can see the buildings coming up, the roads going down, the trees moving. So everything in the 3-dimensional approach. So one is the viewing and the other is the measurement. So viewing is a cosmetic thing and measurement is the triangulation which is being done inside the software for giving us the Z values. So you tick wherever on the road, it will be 3.9. So I am observing it at roughly 1:600 scale. So this is the level of approach, and then we can do the land use. If it is an undulated terrain, we can bring out the morphological units from there. do our 3D digitizations, whatever we would like to do on this top of this, we would be able to do it. Automatically the 3D will be digitized. So as we move along, when we begin to digitize, the coordinates will be picked up corresponding to that position. Corresponding to that position, it will be picked up. So for example, just as I move along, the Z values is being copied. So this is the 3D digitization crudely done on any building top, on the footprints, whichever we would like to do it. We can use that for our operations and then we can complete the digitization tools. So there are other terrain related operations which we cannot cover in these single sessions, like watershed analysis, like topographic properties. So once we get the digital elevation model and the topographic properties, we are flooded with applications which can give cut and fill, the path analysis, everything that relates with the surface model or elevation model which is generated using this drone software at a scale of 1:200 or 250 at a very, very high scale. Say for example, I just go to use the elevation model. This is just to share with you. There are a lot of images which are at the background, so that's why it's taking a bit of time. This is the elevation model, and then we say create the geomorphological hydrogeomorphological properties of each basins or each watersheds. So the yellow ones basically which we see are the smaller basins. The terminology is the basin, and the bigger ones are the watershed. It's just the opposite of what we do in India. US terminology and the European terminology is again just the opposite. These are the stream flow paths in vector. These are the stream flow paths, the standard flow paths. If I want to get the attributes of these things, if I want to see the standard flow path attributes, the stream orders, for example, click on any one. By Horton's methods, Taylor methods, Shreve methods, it will give us the stream order. If I would like to see the standard basin attributes, I just go to attributes. What is the number of streams within that basin? What is the total stream length? Bifurcation ratio, length ratio, drainage density, constant of channel maintenance. To maintain 1 meter channel, how much area needs to flow into that? So that gives an indication about the flatness of the watershed. Length of overland flow, stream frequency, form ratio, basin relief, ruggedness number. So these are the things which we calculate more or less for our watershed areas or our basin areas. These are in the form of attributes collected directly from the digital elevation model. So with that, we were coming to our conclusions. So we had been trying to share with you what the UAV does in doing the ortho images, the type of UAVs, what is the flight management software, what is the endurance time, approximately it takes around 45 minutes if we fly at a height of 50 meters with 70% overlap. In a half square kilometer area, we can expect 500 images. The post-processing will take around 5 hours. For drones, it is now DGCA approved, and the level of accuracy that we can expect in the XY level is 10 centimeter, in the Z level is 15 centimeter. So with that, I would like to conclude my session, which was to share with you on the perspective related with drones. Yes, please.
Yeah. Just a moment.
Shantunda, I think by mistake I raised my hand. Sorry.
It's okay.
Am I audible?
Yes.
Okay, thank you, sir. Thank you for your deliberation. And now I'd like to ask the participants to. Yes, one has already raised the hand before asking. So quite a long day for us, actually.
How are you, Professor Dev? Kaulachan.
How are you? I am fine. Thank you.
I am fine. It's good to see you after a long time.
Yes.
And thank you for this opportunity to come across with you once again.
Yes. Thank you.
Thanks, sir.
It was
sorry,
really
Shantan.
The students have got.
Yeah, a couple of participants have already raised their hands. So first, I'd like to call Dipanita. Dipanita, please, you may go ahead with your question, and then Arindam will ask the question.
She told that by mistake she raised her hand.
Yeah, they have already raised their hand. Dipanita, please ask.
No, Shantunda, by mistake I raised my hand. Sorry.
Okay. Then Arindam is there. Arindam Chaudhary.
Can you hear me?
Yes.
Yeah.
Yes. Very nice presentation, sir. And I have some experience in drone applications. Like I want to know one thing. Like if we just put if we fly a drone and to reconstruct a terrain topography over a large area, suppose there is a vertical drop, then how will small vertical drop near the erosional bank of a river, then how we will reconstruct the particular terrain? And the next question is that the GCPs are very important for error corrections. So how do you deploy, how should we deploy the GCPs in a larger area?
Great. By definitions of larger area means you mean to say like more than 2 square kilometers or something like that?
No, kind of a, yes, 500 square kilometer or
okay.
or a 2 square kilometer kind of.
Yes, because the drones, the one which we are doing it for our civilian use as of now, which does not require any permissions, can fly maximum up to 30 to 40 minutes. Okay. So now in one mission, in 30 to 40 minutes, the maximum area that it can cover would be 500 to 700 square meters. There are certain drones which can go slightly higher, but maximum I can say is 1 square kilometer. Now, while doing this, there is a standard operational procedure the terrain where I am standing and the area where we are operating, we should know the basic difference between the plane from where I am standing and the undulations which are available. This is a standard operational process. It should not exceed more than, say, 200 meters. Okay. So why this is being done? Theoretically, there is no problem for the software. Theoretically, there is no problem because all the photogrammetric effort, when it does the triangulations, it will take care of the undulations. As the drone flies, the changes of elevations will create a different scale in the photograph. But when we do the bundle adjustment with tie points and the GCPs, it is taken care of and it is leveled off. So we really don't have problems technically. But for all practical reasons, we have seen if there is a sudden change of elevations, then the drone functionality drops. It is unable to comprehend the change of elevation very properly and it malfunctions. That's why it is suggested, do not, even if we have to have an area which is having a high abrupt changes, it has to be tuned in the drone software to undertake an elevation change of more than 200 meters or 150 meters. Otherwise, it is advisable not to go into that area unless it is activated. As far the second question is concerned, GCPs, it is sometimes very difficult to take ground control points in inaccessible areas. So the best solution for this is to go for a PPK mod drone. So the post-processing kinetics, if it is applied, there is already, we have to keep a base somewhere and the rover will carry a GPS also and the rectifications are done with the PPK. In that case, you don't have to collect GCPs individually. This is the best possible solution for going to a PPK mode drone. It is slightly costlier, but it is much, much safer and easier.
Okay, thank you, sir. Sir,
yes,
for your first answer, sir, can we just means for that small vertical drop, can we just click some kind of ground images, ground-based camera, and we just capture those images to transfer into the photomad or photoscan for that?
When you collect images while standing, there is called near photogrammetry and the other is called far photogrammetry. All these drone-based softwares do not take near photogrammetry. That means if you take photograph of your own of the building and try to put those photographs, it will not work. There are two big domains of photogrammetry. One is the near photogrammetry and the other is the far photogrammetry or the aerial photogrammetry. All these type of softwares are generally made for aerial photogrammetry. For terrestrial photogrammetry, there is a different set of applications like pictometry. So pictometry and other application softwares are meant for you stand over here, take the photograph of the temple, again rotate, move on the other direction.
With overlaps.
With overlaps.
With 40%
right.
of overlaps.
Yes, yes. So this type of photogrammetric software won't give you right solutions of those type of near photogrammetry.
Okay, thank you so much, sir.
Yeah.
Anyone else? Please go ahead. You can put your question in the message box, but still would like to have this question answer session in a one-to-one interaction.
Right. It is slightly offbeat domain for majority of us, so we know that.
So don't put the question in the chat box if you like to ask anything. I know it's a very long day for all of us.
Yeah, it is.
Almost all of us are sitting from 10:30 in the morning India time, so it's over 6 hours now.
Yes, and specifically in an online mode, it is more treacherous.
Yes, it is very energy sapping.
Yes. You get drained out very easily.
Exactly.
In offline, you have psychological diversions. a little
Exactly.
bit of topic.
I don't know. You have continuously, sir. You have continuously, presented for 2 hours. You have presented.
Yes.
So hats off to you.
It's
Because
a
there are
challenge
so many
for all of
participants.
us.
So anyone, please.
Just in case sometimes questions don't come to our mind, I had shared my email you can write it down, bolenbasu@gmail.com. It's simple. Any questions which comes to your mind in the future also, do not hesitate to put. Okay, we would be there to address our questions.
I'll just do one thing. I'm just
Right.
copying your email ID.
Yes.
I'm just copying your email ID and I'll just put it in the chat box so that everyone can download it. Everyone can copy it.
Yeah, right. Here it is. Here it is.
Okay, one question is there. Gyanendra Sharma.
Yes.
Can you, Gyanendra Sharma, where are you right now? Because you can easily open the camera and ask a question.
Yeah, I got his question. Pix4D versus photo mode.
Yes.
Versus what? Yeah, both are very good software. Pix4D is a very good software. If you want to do like 3D digitizations, then Pix4D might not have the answers. Photo mode do have answers for that, where you do it digitizations in a standalone mode, in a 3D vectorization mode. The second is if you are going from RGB camera to multispectral camera, there is a requirement like rig alignments which needs to be done. So there, for rig alignments and for thermal images, there are stuff and solutions which helps sometimes in the photo mode. So yes, to answer specifically, both are good. Both are automated process and it depends on who is using what. There is really no very specific yes, good, bad like that to this. Both can serve the purpose. Both can serve the purpose.
Okay, then if there is no more question, we'll move. Yes, thank you, sir. He's writing now.
Right.
He's written here.
Right.
We'll move to the next speaker, the last speaker of our day. Before that, thank you so much, sir.
Thank you
once again.
Thanks.
And I'm sure you will receive some queries.
Sure. Absolutely. Most welcome. Most welcome.
Okay, sir. Okay. Now I'd like to welcome on this platform Dr. Sujay Bandyopadhyay. I have seen that he has already joined.
Yes, I'm here.
Okay. Dr. Sujay Bandyopadhyay is an assistant professor of geography in Kazi Nazrul University, India. And he completed his PhD from the University of Burdwan in 2019. And he's an early career researcher in geomorphology, and he's engaged in evidence-based research related to the detailed record of fluvial response to techno-climatic change and human riverine interactions throughout the Quaternary period. Especially in the alluvial landscape, he has his works concentrated on. And he has multiple publications related to this, and his research provided a new framework for understanding the late Quaternary alluvial history of the Ganga-Brahmaputra Delta, which is the largest delta of the world, by using different proxy records. Now, another thing that he is an IAG young geomorphologist, and he received the IAG grant a couple of times, and he participated in a couple of field work, couple of training programs, conducted by International Association of Geomorphologists. Okay, so Dr. Bandyopadhyay, once again from this forum, we are welcoming you, and you may share your screen for the presentation.
Thank you, Santan. Now I'm.
People are very much, almost drained out, because this is you can understand.
Yes, I realized. Yes,
this is the last presentation.
So I think they're already tired.
Yeah, most of them are already tired. It's very awkward to speak in such a formal manner with you.
So, right. Is it visible, the screen?
Yes. Yes.
Is it visible?
Yes, yes.
Hanson?
Yes, it is visible.
Okay. So, firstly, I'd like to thank you, the organizing committee of the second intensive training program organized by the Indian Institute of Geomorphologists, Young Geomorphologist Forum, for inviting me in this important platform. And today actually I wanted to share on the dating the sediments and landforms especially during the Quaternary period. What I actually learned during the past few years. Basically, I'm not geochronologist, but I'm the user, and what I learned and what I have faced the problems during the performing the dating techniques, I will share with you. So first, actually, my outline of the talk is first to understand how we conceptualizing time in geomorphology. And there are several dating techniques by which we establishing time in the landscape. So among them, I will highlight the fundamentals of some basics of luminescence dating, especially optically stimulated luminescence dating, and finally the practical application, how we sample the sediments for the luminescence dates, and how we calculate and finally calculate the age using the LDSE software. Basically, we know humans are curious about the past, and at the same time, we want to predict the future societal and environmental trajectories. So that's why we know in the Earth's surface there are several types of landforms and sedimentary archives which are actually recording the past environmental history. Already Professor Kale discussed about the reconstruction of the past environment. So, but the thing is that, interpreting the sedimentary archives, the most important thing to know the time when the sediment deposited and when the landform created. So, for that, understanding geomorphic changes over the time is very much essential. We already read the classical papers published by Suman Lichi in 1965, and also the book Geomorphology and Time by Thorns and Bernson in the year 1977. Already Thorns and Bernson, they discussed in their books like how we measure the time in a continuous scale, like measurement of stream flow recorded at a gauging station, or sometimes we want to date some specific process or specific event. So it's a sample time. And what Suman Lichi discussed in their classical papers, like there are three types of temporal framework in geomorphology, and the most important, if we want to understand the long-term landscape evolution, the important thing is to understand the geological time. It means the deep past, and within the vast expanse of the if you know the 4.6 billion is history of the Earth, then the important in geomorphology, the Quaternary period is very important. The last 2.58 million years. Because within this period, actually, we know there are a variety of landforms we observe within the Earth's surface, which are the results of erosion and deposition. And the other thing is, the period actually, we know the climatically most unstable period within the Earth's history, because the climate, long-range investigation, mapping, and prediction actually funded by National Science Foundation, who prepared the map of during the last glacial maxima. And if you see the map, then during the last glacial maxima, most of the northern part of...
Sorry to interrupt you. I think your screen has been paused. Sorry, sir. Sujata. Yes.
Sorry.
From the beginning, there is no presentation actually.
Oh, there is no presentation. But
yeah.
I just... asking like is it visible or not? Like,
visible, obviously your screen is visible, but your presentation is not coming actually.
Presentation is not visible.
Okay. Sorry. Again. Oh, the slide is not actually. Okay.
Yes, now is okay.
Now it's okay?
Yes.
Now it's okay.
Slides, the changing? Slides are changing or not?
No, it is
Yes,
okay.
it's changing.
Slides are running now.
Okay. So the thing is that what I actually am highlighting, the climate, the long-range investigation, mapping, and prediction, they prepared the map during the last glacial maxima. And if we observe the map, if you see the map, like that, the northern part of the America and North America and Europe is covered by the ice sheets. So that's why we know the Quaternary period actually associated with massive climate and geological changes, and also its rise to the ecological dominance of the human species. So if we reconstruct the recent past, it means the Quaternary. So there are several type of archives already we have heard in the morning time. So there are several type of archives and also proxies involved, by which based on the proxy analysis we can unlock the climatic signals also. And there are several type of proxy, basically two type of proxies used by the scientists, like biotic proxies, or and the other one is the geological or geochemical proxies. But if we understand the evolution of the global physical environment, so first we have to understand the physical process and the rates of this process. And for that, we have to, first interpret the environmental archives based on the sedimentary archives or geomorphological records or oceanic records. And the other one is important. It means that developing the chronologies. It means the absolute dating methods by which we can get the numerical age, like 14C luminescence or uranium series dating. So for that, establishing timing in the landscape, so it's very important, which involves basically the long-term rates of geomorphological process, and also we can date the specific events or sedimentary units or depositional environment. Suppose if you look into the section, this graphic log of the river-dominated delta succession, so we can there are several layers. So if we have we can also date the individual layers, or suppose we can date the all layers and interpret the depositional environment. So for that, we can develop first the accurate chronological framework for landscape development and processes, because which actually provide us the landscape, the understanding of the landscape and the depositional environment, which basically have responded to the changes in the external factors. It means changes in the sediment supply or changes in the climate, suppose the sea level changes or any tectonic processes.
Sujata, just a moment. Sujata, could you please hide this notification bars? Yes, this one. Thank you.
So, so for performing the dating techniques, so we should remember some points. So there are, we should remember, the questions that needs to be addressed first. The first question is, what is being dated? Whenever we perform any dating technique, so first we consider this question: what is being dated? For example, we can date any dating the timing of the sediment deposition, or we can date the specific landforms. And this one is the first step towards the creation of the dating strategy. And the other question is another important question: which method is most appropriate for dating the chosen event or landforms or depositional environment in specific geomorphic situation? And the second question actually creates some complexity in dating strategy, because there are several factors by which we choose the appropriate method actually, because the first thing is what materials actually available to us. The second one is the expected ranges, the expected dates of the sediments. That's very important, because based on the expected dates of the sediments or landforms, we can fix which method is suitable, because in later I will come these things. And the other one is very important, is what resolution we require. resolution of the dates. And another one is a geological setting. It's very much important. If you see the figure, there are several dating methods for which we use different type of materials for dates, different type of dates. So that's why which material is available to us and what we are looking for. So that's very important. And based on this, we can choose the appropriate method. Suppose if we follow the books of by Noller et al. 2011, Introduction to Quaternary Geochronology, they classify the different type of geochronological methods, and we know there are several methods like incremental, isotopic, radiogenic, or chemical or biologic, geomorphic, or correlation. There are several methods by which you can get the numerical age, and there are other methods that you can get whether the surface or whether the landscape or older or younger, much younger. It means the relative age. And there are two groups of people in the world. One group's those who are actually developing the science in a particular dating techniques, and the other one those who are user, like me. I'm the user. I'm not geochronologist. I'm not developing any science in these particular methods, but whatever the methods already developed by some geochronologist, I have used and I'm using and I'm learning also. So that's why whether some groups they are also developing, and the groups we are. So the first thing, if you are in the second group, it means the user. Then we have to first fix our focus, what we are looking for, why we dates, and what kind of materials available to us. So based on this, and we can fix our dating techniques. So and the other important thing what I already highlighted, that the expected dating range of the surfaces of sediments or landforms, like at what time period actually what we expect the age of the landform. So this at particular time ranges, there are several methods is applicable. Like in case of luminescence, we can use also for recent sediments, and we can also beyond 100,000 years. And for 100,000 years, we can use the IRSL dates, and below 100,000 years, we can also use quartz-based OSL. So, the other thing is based on the radioactive decay principles, we can also use several dating methods. Like the most important during quaternary, we can use nowadays for merged samples. If the carbon content is low, nowadays AMS accelerated mass spectrometry 14C also we can use for dating the merged samples. So where the carbon content is low. So the next part is some fundamentals of the luminescence dating. What does luminescence dating tells us actually, and what is luminescence? So actually see the figure of this slide. So luminescence means nothing but light. It is the release of the energy storage in the crystal lattice actually, and crystal lattice of the mineral of a particular mineral like quartz and feldspar, where basically electrons trapped by some holes. So luminescence is nothing but a phenomena actually arises from the interactions of ionizing radiations. Like when the quartz or feldspar, any minerals, crystal lattice, these are called dosimeter mineral. So these minerals, when exposed to ionizing radiation, so it actually some electrons trapped into these minerals, and this is called the dose. And when we apply heat or light, then definitely luminescence happens. So for that, in case of luminescence dating, that's why there are several terms we can use. In case if we apply heat, then in this case we can use the term thermoluminescence. If we use blue-green light, then it is we can use the term optically stimulated luminescence dating. And if we use the infrared photons, definitely, then you can use IRSL. And there are other several terms you can follow. There are several good books and journals you can follow, and there are other several terms associated with the luminescence dating. The most important three terms here I have highlighted. And this is the broad history from TL to OSL, and now it is RSL. We should remember some important year if we perform or if we have interest in luminescence dating. The first one is the 1985, the year when in Simon Fraser University, basically first the optical dating of sediments was presented. And the other one is the year 2000, basically when SAR protocol developed by Murray and Wintle. And this is basically a very important protocol by which we can use for calculating the paleodose or equivalent dose D. And the other one is the year 2008. It's very important because the IRSL protocol for feldspar actually introduced in this particular year. So that's why we should remember if we have interest in luminescence. And this is the basically band energy model, for luminescence production in crystal lattice. Suppose there are three parts in this model. First one is the irradiation. Second one is the storage of the luminescence, and third one is the stimulation part. So if the crystal lattice of any minerals, exposed to radiation, exposed to actually ionizing radiation, then the electrons of this particular, mineral actually jump into the conduction, exciting high energy band, conduction band, and definitely the impurity in the minerals, basically the holes actually trap the electrons, and the electrons accumulated in the trapped. And if we stimulate we are using heat or light, so the signals, the electrons actually recombine, reaches the luminescence center, and the signals releases in the form of light. This is the stimulation part, and this is the process of the luminescence production in the crystal lattice. And this figure, actually very interesting figure, how the luminescence signal accumulated during the mineral formation, and when the erosion occurs, how the signal decreases, and again during the burial time, how the signal increases. Like this, when the during the mineral formation, the luminescence signal increases due to the natural radiation. So signal increases, but when it eroded by some geomorphic agents, it exposed to sun, daylight exposure, and we already know if we apply light or heat, then definitely the signals releases luminescence, the energy releases. So that's why whenever it exposed to sun, then the signals decreases again. And during the transport and after the transportation, where again it deposited or buried, so again due to the natural radiation, environmental radiation, so again the luminescence signal accumulated. And when we sample we sample for dates, then after that, so we will get the age from the last daylight exposure to the sample up to the sample time. So we can get the depositional age of the particular sediments. And this is the principles of the luminescence dating, like when it exposed to sunlight during the daylight exposure, zeroing occurs. It is called resetting of the signals or bleaching. And when it not exposed to heat or light, then the signals increases with time, burial time. So this is the basic principles of luminescence dates. And if we compare with the sedimentary process and with luminescence process like this, if the sediments buried, then signal accumulates. If reworked and transported, again bleaching occurs. It means signal reset. It means the signal decreases. Again, when deposition occurs and bleaching stops. During buried, signal accumulates, and when sampled, then accumulation ceases. And from the sample, we can measure the luminescence. It means the amount of dose. It's called the paleodose. This a good analogy example we will find in the good papers by Singhvi and Kale in the year 2009. That's a good example by which we can understand the luminescence dating methods. It's a Singhvi beaker example. Like this, suppose if we consider there is a beaker kept under the dripping tap, so we can measure the time duration. The beaker has been under the tap. So like this, so because if from this figure, if suppose if in this because suppose if we initially if we consider there is no water, so if we know the drop rate, so a drop rate like 1 drop per year, so we can consider after the 120 drops, it is equivalent to 120 years, like this. So in this slide, we can get the time duration of the beaker has been under the tap water, like time equal to total amount of water by drops per year. Similarly, analogous to, we can get the final luminescence dating and age equation, like equivalent dose by dose rate. Equivalent dose, it means it's equivalent to, analogous to amount of water or volume of water, by dose rate means the similarly the drop rate. So by which the equivalent dose in case of luminescence dating method, the unit SI gray, we use gray. It means the 1 joule of energy absorbed per kg of mass. So see the figure, the difference between the luminescence and radiocarbon. Like in case of luminescence dating, the signals increases with the time. But in case of radiocarbon, the signal decreases with time. It means the decaying principle, we can get the age in case of radiocarbon dates. But in case of luminescence dating, we can get the age based on the accumulation of the dose. It means the energy. So finally, if we summarize this analogy, so in case of dating method, so it means the beaker is equivalent to, it means the dosimeter minerals like quartz, feldspar, zircon. The drops means the electrons produced by the radiation, and if we or the resetting mechanism, it means if we emptying the beaker, so it is equivalent to the daylight during the sediments during the daylight exposure. It means the bleaching phenomenon. And if we know the drop rate is, it means that if we measure the uranium, thorium, potassium in sediments, so we can get the dose rate. And the measuring the accumulated water, it is equivalent to the luminescence measurement. It means the amount of the dose. It means the equivalent dose. So this is typically by Duller in 2000. Typically, sand dune radiation dose rate is 1.5 gray per 1,000 years. So it is the radiation, how much the dose rate in case of sand dunes. This is the good example of the environment, different type of environment from where we can get the vessel samples. Or this is the cartoon illustration by Rhodes in 2011. There are different type of environments from where we can collect the samples for the luminescence dates, and we can get on time scale of 1 year to 200,000 years, definitely depending on site and sample characteristics. And the next part of my talk is the practical application. That's very basic things, the basic part of the luminescence, not very, the how to sample the sediments and how to get the final age. So first is the sampling strategies in the field. So how to sample the sediments. So first we can use for sampling is the opaque tube, the near about 30 centimeter long. We can use non-rusting iron opaque tube. So and we can first clean the surface, and remember, water content is very important during the sampling time, because in water content actually reduces the dose rate. So that's why definitely the final age increased for that. And the other thing is the sediment should remove from top of your sample. And other one is the better to avoid sampling where basically big boulders or grains or calculus are present. So these are the factors, things to be considered in the field when we prepare the strategies how to sample the sediments. And during the sample preparation, two part actually. One part by which we separate the grains, mineral grains, and from where we get the equivalent dose. It means the amount of the paleo dose. And the other one we can use for bulk geochemistry, and based on this we can get the dose rate, amount of dose rate. So this is the basic chemical treatment we can follow during the in the lab. So if you see the opaque tube, the middle portion of the sediments we can use for actually measuring the luminescence decay curve or the equivalent dose calculations, and the remaining part we can use for the dose estimation, like uranium, thorium, potassium estimation, and based on which we can get the dose rate. And basic chemical treatment procedure we can use, like for removing carbonates we can use HCl, or for removing organic matter H2O2. We can sieve the sediments for the grain size, for getting the grain size, because 90 to 150 micrometer, or sometimes 150 to 50 micrometer is important for the luminescence dates. And after that we have to separate the quartz and feldspar, because if we use the quartz based vessel, then we can separate by density separation method. And after that we use the HF etching for removing the alpha layers from the quartz, and finally mounting the grains over on the aliquots. We can use aliquots later, and finally we measure the luminescence, means the dose, paleo dose or equivalent dose. So this is the etching. In case of quartz, we can use the etching method for removing the outer portion of the grain. And this is the aliquots we can use for mounting the grains in an aliquot. So sometimes we can use single grains method or multiple grains. In case of single grains, disc with 10 into 10 holes of specified size we use for single quartz grain, and sometimes we also use multiple grains method. And these are the dark laboratory for vessel sample preparation, where where basically red light used. And these are the readers, TL, OSL readers, RISO, and lexic readers. These are the readers by which we actually use for measuring the D. And the thing, this is the Marine winter SAR protocol by which we estimate the equivalent dose. This is very important, protocols where basically we first apply the preheat and for removing the unstable signals in the crystal lattice. That is, and after that we first apply the natural vessel signals, and after that we apply the test dose, the machine dose, and again we then measure the signals in the laboratory. Then find and here sensitivity corrections are there, and 7 or 8 times we apply this. We apply the test dose, machine dose, and again we apply the vessel signal. We measure the luminescence signals, and first we have to measure the natural signals, and after that we have to measure the 6 or 7 times we have to measure the luminescence signals in the lab. We apply the test dose, and again measure the vessel signals in lab. So this is the regenerative protocol, single aliquot regenerative protocol in case of measuring the equivalent dose. And this is the growth curve diagrams by which we can get this is one LXTX laboratory, the luminescence signals and the test dose, the ratio of this, and based on this we can get the D actually by interpolation method. And finally for measuring the age, we can apply this kind of models by Galbraith et al. Sometimes we can central, in case of well bleached sediment, if we look into the radial plots, like the ratio, if the D value, these are the D value. If the D value is over dispersion ratio, that the dispersed more, then it means the partially bleached prior to deposition. There may be some different signals in the sediments. So if there may be several models we can apply, but the most appropriate model in case of if the sediments is well bleached, then we can apply the central edge model if the over dispersion ratio is less. And finally, I just give you, I have applied this techniques in the Ganga plains. The few dates I have applied from in case of Ajay River sediments and Damodar sediments, and get the results. Like these are 3 sections from the Ajay River floodplains. And in case of first boreholes, we apply during the night time. We collect. It's very difficult to collect the samples in case of boreholes, and during the new moon time, very difficult. We collect the samples in case of these sections, and and we got results, better results in between 2,400 years to 1,300 years. In between the three dates, we have dated 3 samples. And the other one, we have dated the sections along the Ajay rivers. It's a very recent sections. We get results in between 800 years to 200 years. And if we put the results into the different proxy, compare the records from the proxy records like Delta 18O records and other records. So that's the dates actually indicates the deposition of the sediments actually occurred during the wet period, when basically the discharge is more, the rainfall is high. So that's why the climate is wet. Then during this time, we can the dates indicates this the situation. And other sections from Damodar River, it's very interesting sections, and we are till date we are facing actually these samples already we have done in Wadia Institute of Himalayan Geology, and till date we are facing some problems to date the samples, because till date we have applied the quartz based luminescence dates, because till date we not applied the IRSL, because I'm the learners, I don't know about the IRSL dates, but I only applied here the quartz-based OSL dates and get the results in between this. But the bottom samples, till date, we are facing problems because this is the saturated samples, and by quartz-based OSL, it's very difficult. Several times we have run the samples, but the results is not good. And in case of these 2 samples, we applied the single grains techniques. And we get the results like in between 71,000 years to 40. This is the first time dated evidence for late Pleistocene fluvial activity in Damodar rivers, definitely. So these are the results from a few dating results from the Ganga plains, lower Gangetic plains. And finally, these are the several softwares by which we can calculate the final age, or we can get the different graphs or like this. So if we run the samples in Wessel reader, so you can get the in lab actually what the situation, you can get the bin file, and the file you can run first the analyst software, and you can get the D value. Each aliquot, whatever the aliquots are used, each aliquots give the D values and the equivalent dose in seconds. So this from that firstly I have used the ACE software for final calculations, but now another very easy software, LDAC, is the Microsoft Excel Visual Basic Applications, by which if we import the data from analyst software, the D values, so we can easily calculate definitely the final dates. These are some of the overview of the basic of luminescence, not very, because it's a luminescence, it's a very big science. There are several scientists, they are working from India, A.K. Singhvi sir already, several, and there are several labs in India where basically nowadays luminescence dating will perform the luminescence date. So and if you have interest in luminescence date, so you can follow some books or some journals. You will get some idea or in luminescence dating, like the Handbook of Luminescence Dating by Mark D. Batman, or luminescence dating by ladies Singhvi, Feathers et al. And Walker, of course, the quaternary dating methods, very important books. And the other one, important books by Atkin, 1998, the Introduction to Optical Dating. And these are the journals where we can get the good papers by which you can get an idea about the Wessel dates or luminescence dates, all over things. So finally, thanks. And Santan, can I share the software portions?
Yes, definitely, Sujata.
Okay, so Just the next few minutes, I will share how we actually calculate the age, final age, using the LDAC software. So I think I have already shared the LDAC software to all of you, and you have, I think, so you can just the basic things about how we get the results if we have the D values. So just I'm sharing the LDAC software.
আমি জানতাম না ওর নাম কি। ওর সাথে আমার মুখ চেনা হচ্ছে, জাস্ট আমরা একের পর এক টপ ইন্টারভিউ দিতাম, ঠিক আছে? একটা টাইমে ছিল ও তখন কুরিয়ার ওই করে চাকরি পাইনি,
ওকে,
ইউনিভার্সিটি লেভেল বলবো ও
right. So is it visible?
10 বছর হয়েছে, আমি তারও আগের কথা বলছি, 2010 বঙ্গ ইন্টারভিউ, ও তখনও চাকরি হয়নি।
Is it visible, Santan?
Yes, it is visible.
Okay. So suppose if we have the LDAC, I'm just giving the examples. If we have some value here, the inbuilt some values are there. If you load the value, suppose the load example, if you click on the load example, so you can get some values in the inbuilt values in the software. So first you have to click in the load examples value. So first what I will do, first if you have the D values, analyst D values from analyst software, so you have to calibrate the software. Click on the calibration part, and you have to edit the portions, like you have to give the machine dose, like the grays per minute, because the different machines OSL readers are different dose, because in laboratory we apply the test dose, and again we apply the luminescence OSL, performing the OSL. So that's why here we put the machine dose as per the inbuilt value of the machine. So this portion we will do if we have the D values. Then after that this is what we'll do here. If your D values in gray unit, then you can here in this software you can use the gray direct, and if your D values in second, then it's okay. Then you can use some the machine name of the machine, RISO 1 or RISO 2 or RISO 3, like this. So and you will put the lab number, definitely as per the lab requirement. You have some lab number, and you have some field number of the sample, particular sample, to identify later the sample, and I will put the locality, of course, and also the name of the submitter of who actually will do the dates. And after that you have to import the values of the analyst from the analyst software. You will import the data from and here you will directly copy the data, and here you have to paste here. And suppose it's the inbuilt data, and it is from like this. If we merge the suppose if you merge the here, so this is from the BG4285 samples, like depletion, this bin file. I'm highlighting I have highlighted this part, the bin file you will get from the reader, OSL reader. So from that we'll get the this values, D values, and errors also. And you will put the grain size whenever in a lab or whenever you sieving the sediments. So the grain size will put this, and the geochemical analysis, from the geochemical analysis you will put the uranium, thorium, potassium oxides, and rubidium also. And you will put the water content also, and the latitude, longitudes, elevation, and depth of the samples, definitely, and the elevation of the surface, and the aging time, and you have to here put the age estimate, expected the range of the age. Suppose, because it's very important, I already have discussed these things, what you expect the age of the particular sediments or any landform. So this is the part of the dose rate information. And the other thing is the sequence and ED information, like how much the irradiation, the time you will, the natural time in lab you will perform as per the laboratory requirement, and the cut heat, preheat temperature, and the cut heat temperature in the lab, what we apply. So you will put the value preheat temperature already in SAR protocol. You already found the preheat temperature, like we apply for removing the unstable signal. So for that, we'll put the values here, sequence and ED information, and after that, it will transfer the all D values into the D calculation part. How for that you will click the transfer and execute successfully, and after that in D calculation part you will get the D values and D errors, but the D values. And if you apply the central age model, so you can click on this, and if you include the dispersion ratio, if it is less than 20%, then it's okay. You can apply the central age model, and the plot link and the radial plots. If we apply the radial plots like this, so this is the over dispersion. You'll get the over dispersion ratio like 16 plus minus 2%. It means it's lesser than 20%. So this is using the common age model, you can get the ED equivalent dose value is 366.0540. And if you import the value into the summary portion, so you can click here, and then you will get in summary portion, you will get the central age model value is the D in seconds and D in gray. And this gray is depends on the machine dose value, whatever we calibrate the first whenever we apply these things. So for first calibrate as per the machine dose, and based on the machine dose we can, because the machine dose is gray per minute, so if we convert the seconds into minute, then after that if we multiply with the machine dose value, then we will get the gray value, D in gray value. And after that, if you want to find the age, so just click the find age, and we'll get the value of the central age as like 10,000 years, 10,000 years, close to 10,000 years. So this is the central age. Using the central age model, you will get the results of the final age. And if you want to export the report, so you can also click on the export reports. You will get the PDF file of the reports, all reports. So this is all about the overview of the LDAC software, how to get the final age if you have the D values in the from the analysis software. You will import and you can get the results. That's all. Thank you. So finally, if you have any questions, you can ask to me.
So we are just at the brink of closure for day one. And finally, the participants, if you have any question, please go ahead and ask the questions. I know you must be very tired, but still, there must be something.
Yes, I have a question,
Stepanita, go ahead, please.
Sure.
Sir, in terms of paleo-dose evaluation, what is meant by the residuals? Is there any particular number or value over which it is considered as residuals?
Residuals?
Yes, sir.
Residuals means I am not getting your points. Residuals at what sense?
Paleo-dose evaluation, in terms of paleo-dose evaluation.
In terms of paleo-dose evaluation, actually we just consider the aliquots, number of aliquots. Right, number of aliquots, and each number of aliquots provide us the D values. And based on the D values, we can use any model, central age model or minimum age model. But the residual side, I'm not getting your points.
Sir, any unwanted components or the residuals? I mean.
Unwanted components means what? In signals?
Yes, yes.
In signals, actually, I already mentioned the things is that the bleaching, during the bleaching, if there is in signals, there is a mixed signals, it means it reflects the partial bleaching. So in case of partial bleaching, it's very difficult because, sometimes you can use the minimum age model or like this. So there are different situations you can face whenever, you perform you want to calculate the D values. So so in case of partial bleaching or mixed signals, so it's very difficult to get the better results. So there may be some errors in dates, final dates. So that's the problem in luminescence dates. So there are several problems. So that's why the other techniques we use, there are other kind of development in luminescence dating also. So this is what.
Okay, then another participant raised her hand. Oluwatosin, okay, bola. Yeah. You want to ask something? Your voice is not much clear.
Yes. Can you hear me now?
It's very.
Yeah, getting your point. Yeah.
You go ahead and yeah.
Can you make the videos available after the program? Thank you.
No, it's not very clear. Can you just put your question in the message box if it is possible for you? Can you please put your question on the message box so that I can read it out? Oluwatosin, can you please put your question on the message box because the voice is not very clear. Sorry. Oluwatosin, just I'm asking you to. Yes.
If he has any questions, he can put the question into the chat box. So
you just put the question in the chat box. I will read it out. There is a question from Ram Kulapkar. I think there is a question from where we'll get the training about this dating technique. That's a very basic thing, obviously. So, Sujata.
So from where actually you will apply for collaboration in a lab. So you can get the definitely. Whenever you perform, actually training is not, the thing is that what I experience, whenever you perform the techniques, then you will learn. Otherwise, it's very difficult. Because attending training or attending workshop, it's very difficult to learn luminescence dates or other kind of dating techniques. Because in my initial time when I attended 2 or 3 training programs, then I've learned definitely. I've heard several presentations. But the thing is that, but when I perform the techniques actually, then I have faced several problems. And I realized what actually the complexity is there. So that's the problem. So you have to fix in your mind what you actually dates, what you want to dates. So then you have to collaborate with any lab, or if you have collaborate with any good labs, then luminescence labs, then you will learn definitely whenever you perform the dating techniques.
And I think obviously you have to reach out somewhere. Nobody will train you just like that.
Yes. It's not like this because it's for sometimes for getting one dates. For getting sometimes in any section, suppose if you observe like one date, it's not like this one value. For getting one date, it's very difficult. You have to try it several times. You have to run the samples and you will get the results. And sometimes your results is not good. So very difficult.
And one silver lining is, yes, as far as Indian perspective is concerned, when we were students, these results, we could not get the results from the Indian labs most of the time. So we have to send the sediment abroad to get the results done?
Not like actually.
Now the situation has changed. I'm talking about 10, 12 years.
Yeah, definitely. Now, the thing is different because I have seen in the Wadi Institute like this, that there are several samples actually. The institute from where actually they already sent the samples to the lab. So there is no the manpower is important for performing the samples.
Yes.
So if you want to date your samples, then you will collaborate and you perform the techniques by your own. And so that's the better things, I think, if you want to date your samples, any dating, if you want to perform any dating techniques. So first you have to collaborate with labs, and you perform the techniques by your own. That you have to learn. I think you learn these techniques. Otherwise, it's very difficult.
It is my suggestion to all the young geomorphologists that you have to reach out.
Yes, you have to collaborate with labs. It's very, because
nobody is obstructing you. So you have.
Nowadays, there are several labs in India, and they are very much cooperative, I think. Because I'm also a student of geography, and I definitely collaborated with Wadi Institute, and they helped me a lot. That's why I learned little bit. I know not because luminescence world, it's a big science. Many scientists they are working in the luminescence states or luminescence world. So it's very difficult to learn within a few years.
Okay, anyone else? Anyone else with the question? I'm just searching through this YouTube.
Sir,
there is no question on YouTube. Yeah, you ask.
Sir, I want to ask about the uncertainty of this OSL dates. Like, sir, when we are dating, we are getting like results like, for example, if 80 Ka plus or minus 25. So this kind of things, actually, when we are communicating papers, okay, so they will also put a big question mark.
Yes. The thing is that the problem I have faced and I'm facing till now, because the errors is sometimes sometimes they consider 25% error, or sometimes some scientists they consider 5 or 10% of the 10% error of the mean age. So it's very difficult.
Sir, any kind of modeling is available for this? Actually, I used this CAM I used once, but that also I am not getting that much good results. Then also that
which one? Please
this
again.
CAM I used once, but in that also I am getting like plus or minus 10 Ka.
Okay, the errors. Also. So it's very difficult to because errors depends on several factors. So that's why, because in any dating techniques, there are several controlling factors by which controls the final dates actually. So that's why you should perform very carefully, or you should sample during the sampling time also. You should carefully sample the sediments or like this. So there are several criteria, okay, by which you can removing the error or like this.
So you want to tell about this is depends on sediment type?
Yeah, sediment types, different environmental environments, definitely the depositional environments or other kind of what you want to do actually. So that depends on several criteria. So this is the problem. Santan, I think another question by Saidul Kurim in the chat box. Can I?
Information is expected.
Reply?
We will encounter in final result. I couldn't understand.
Can I reply to these questions?
Yes, you can reply actually. Santana is muted.
Is there any impact of expected? No, not like this. But the thing is that the expected age is actually you have to put the expected age, because sometimes calibration is needed for because analysis we actually in performing dating techniques we are analyzing, not experimenting. So there are two things: analyzing, because instrument actually gives us the different type of results, whether maybe beyond our expected age range. So that's why expected age is very important any sample.
Sir, if I'm telling my personal experience in OSL dates, I did OSL date with peninsular rivers and Himalayan rivers. When I'm doing Himalayan rivers, I'm getting more error. I think there's some.
I have no experience in Himalayan rivers, definitely. I only apply actually there are different type of environments, so it's very difficult because in case of my, in a Gangetic plain, the rivers in the Gangetic, there are also the errors are more, definitely. If you observe my slides, the dates, what I mentioned actually in my slides, the dates, the error range is more. So it depends on different types
of bleaching. That means
definitely, because in case of fluvial deposits, the bleaching is not good. Because in case of aeolian samples, the bleaching, the resetting mechanism is very good. So that's why. But in case of fluvial samples, sometimes we underestimated. We can get the age underestimated because in case of my samples, the samples is saturated. Because if the sample is saturated, but the time duration is more, so how you get the accurate age? It's very difficult. So that's the problem.
Deposit and time duration, I think peninsular rivers also more. I think that is why they are.
That is why. Yes. There are several problems,
So I think I want to incorporate one thing, and sometimes
Sure.
what I felt,
Sure.
what I find during my case, I found that inclusion of some kind of zinc or feldspar, even several type of bleaching. After that, we are facing some kind of problem, basically in Himalayan sediments.
Okay. Yeah, you are done in Himalayan sediments.
Yes.
Yeah,
It's
okay.
the key part. So even I think rock types, the particular sediments from where that has been brought.
Provenance,
So that is also yes.
Yes, provenance also. Provenance is important part. We have to be taken into consideration. The provenance from where actually sediment coming from and deposited. So that's the problem. There are several factors which affect the age range of ages or like this. So that's why there are several geochronological techniques or like this. And till date, the developing already till date there are several type of development in scientific development in different dating techniques.
Yes.
Okay, anything else?
If we put very much wrong information in expected age, what kind of deviation we'll encounter in final? We don't know. I don't know. I've never tried to this. You can try also. If you have the D values and the final age, so you can put, but I never tried. Because previously I have used the ACE software, but now I'm using this LDAC. So I'm very newer in this. Previously I used the ACE software for getting the final age. So you will try it definitely.
Sir, I have one more doubt. How moisture is controlling this?
Moisture, definitely. I mentioned these things. So moisture actually reduces the dose rate, right? So if the dose rate is reduces, definitely we'll get the age is increased. Definitely the increased age, the final age. So that's the problem. Because if the moisture content is very high, it reduces the dose rate. Because the amount of paleo dose which actually accumulates, it depends on the dose rate of the natural radiation, and the moisture content actually affect the dose rate. So that's the problem.
Okay,
there is another question by Rafiq. Sir, in your presentation, when detailing the states...
So I already mentioned these things. Yes. The role of water, burial in the bed. So moisture content, that's very important part of... So you have to consider the moisture content in the final age calculation also.
Okay, may I ask anyone from outside India to have some query to ask something, please? Because all the questions mostly from the people who are working in the Indian environment. So if there is anyone from outside India, you're welcome to
definitely it will enrich us also. If anyone experienced any other kind of,
yes,
you can share, because this is the discussion forum, right? So we can discuss and we can definitely some points, arises during the discussion.
Anyone, please? Actually, that lady, she asked one question and we couldn't understand, and she's not here now. She is logged out. So one last time, if there is anyone from outside India want to ask anything, please go ahead. No, still no response. Anyway, in that case,
if anyone have any questions or any further clarifications, then they can mail.
Yeah, I'll do one thing once again. I'll do one thing. Just a moment. I will just copy your email ID.
Yes.
Okay.
So any clarifications, then
I'll just copy your email ID and put it in the chat box so that people can reach you even after this session.
Yes, definitely.
Okay, so this is Dr. Bandyopadhyay's email ID. You can reach you even if you have any question after this session. So with this, I'm closing this session now, and
thank you, Santan.
Thank you, Sujayda. Thank
Can I leave now? Can I leave now from this platform? So now my task is over, I think.
Yes.
Okay. Thank you.
Thank you.
Thanks again to the organizing committee, for inviting me here. Thank you.
Thank you so much. Thank you so much. With this, I'm closing the session now, and yes, as I said yesterday, that I'll leave this particular space to the participants for about half an hour. So you can interact with each other, especially through the chat box. You can share your email IDs, contact numbers, whatever, through this chat box, and you can collaborate. You are always free to collaborate with each other. Obviously, this platform is for this only. And secondly, because you are not attending this particular event physically, so it's very important to collaborate. It is very important to communicate through this medium. So for that, I'm leaving this space for half an hour, and I will close this window at 6:15 approximately. So you may go ahead and interact with each other here. Okay. So right now we are leaving from this space. Our profile will be inactive right now, and we'll close this session on 6:15. Thank you so much, and be there on 2:30 India time tomorrow. For the participants from outside India, you please see the timings with respect to your country and join at that particular time. So from 2:30, we have our next day's session. Okay, that will continue up to 8 p.m. Indian Standard Time when we are supposed to finish off the valedictory session. So thank you so much. Thank you for participating in this event. I'm leaving this space now, and this space is yours for the next half an hour. Thank you so much.
Okay, good night, Shantan.
Good night, sir.
I will leave now.
Okay, sir. Okay, sir.
Going.